Although the terms are often used interchangeably, data and information are not the same thing. They are not synonymous. Data is essentially raw numbers, raw text, and raw dates. So in other words, there is no real organized structure. An example of data might include, for instance, details related to anti-malware scans that have been run on individual hosts on our network. Information, on the other hand, results from processed data, and from which we can then gather insights. It's more meaningful. An example of information, sticking with our anti-malware scan example, would be how often specific malware types cause security incidents within the organization. So the raw data was just the details about the scans, but information we can gather more insights from, like the number of malware incident types. With data and information, we always have to consider the reliability of that data, confidentiality, which is often achieved through things like encryption, the integrity of the processing systems and the resultant data to make sure that the data is authentic and hasn't been tampered with. And that includes controls at the technical level, things like file hashing when it comes to the integrity of files, but also internal controls at the business process level to make sure, for example, a single employee doesn't control an entire business process from beginning to end. Then we have to consider data transformation. This is going to be important if you have data that you need to make available in a dissimilar processing system. So in other words, you need to export it from one environment and import it to another. That also would apply if you are migrating data into the cloud. So sometimes you'll have to transform data, maybe so that dates are in a specific format or numbers are in within a specific range. At the end of the day, when we've got solid information, if we can trust the accuracy of that, it means that we can result in informed decision making. We make better decisions when the information on which we base those decisions is correct. It's one thing to gather and store vast amounts of data, but then what do you do with it? What is the benefit of doing that? That's where data analytics kicks in. It usually involves large data sets, in other words, big data. And using technology and automation can allow us to process vast data sets or big data quickly. Now, the benefit of that is we can gain insights from that data that otherwise might not be possible. So examples of that would include performance insights, where we might be able to determine the optimal placement of a database server to increase performance, or maybe the reduction in the amount of time it takes to complete a customer transaction. We would have gathered all of this data over time where we can identify these types of things. We might gain security insights, so we can, over time, and with enough of a sampling of data, determine if there are abnormal network host or application usage patterns. We can also perhaps get indications of wrongdoing related to things like fraud within the organization. We can also get cost efficiencies as a result of data analytics, where, for example, we might be able to identify job roles or functions that overlap, and we can remove some of those duplicate items so that we end up with cost savings. Also, it might allow us to streamline, remove, or even completely replace processes that aren't actually required. They might have been relevant at one point in time, but are no longer needed. And so this is going to be easy to do if we have the required data, that data is accurate, that is then manipulated and processed in such a way through data analytics where we can gain these insights. With data analytics, it also supports our informed decision making. We get overall summaries of all of the vast amounts of data. We can uncover hidden patterns. It can even serve as a basis for prediction modeling down the road, whether it's financial or environmental or related to healthcare. With data analytics, the technology side is important, and that's because we're talking about large volumes of data that need to be processed quickly. And this usually means working with cluster nodes, where we've got a number of machines, normally virtual machines, working together so that we get the combined benefit of the compute power available with those clustered nodes. An example of this that's commonly used for data analytics, whether on premises or in the cloud, it's usually much easier to deploy and manage this type of complex solution in the cloud, would be Apache Hadoop. A storage area network, or SAN, is a network that is dedicated only for storage communication traffic. Storage consumers, such as servers, can access shared storage over the network. And to that storage consumer, once it's made a connection over the network to storage space, that appears as if it were local to the operating system. But at the same time, storage consumers can also use local storage. And that might be the operating system boot disk, for example. And that is called direct attached storage in this context, or DAS, D-A-S. As an IS auditor, you might need to audit backup procedures within an environment, whether it's a specific business unit or for a specific project, whatever scope that the audit is supposed to encompass. Now, the reason that this kind of knowledge is important, for example, imagine that backup agents are not installed on a number of servers on a SAN. And during the audit, that might serve as a red flag. Why do we not have a backup agent or a solution backing up these storage consumers, these servers? And the answer might be because the data that they are accessing is actually stored elsewhere over the network where there is already a backup solution. So having an understanding of how this technology works, and more importantly, how it's been implemented, so that means having documentation and network diagrams, is crucial for the IS auditor. Storage area networks come in many forms, including Iscsi. Iscsi uses standard network equipment, things like Ethernet switches, for example, network interface cards in machines, and it allows SCSI disk commands to be embedded within IP packets. SCSI is an old standard that was traditionally used to access storage devices. And so all we're doing with Iscsi is using that same standard command set, but putting it in IP packets so it can traverse a network where the storage might be located elsewhere. Now, on the enterprise side, you can also spend more money on a true fiber channel type of SAN or storage area network, where it uses not standard network equipment, but instead specialized equipment like host bus adapters or HBAs. These are special interface cards that we install in storage consumers. They make a link to fiber channel or FC switches, which is similar conceptually to a network switch, except it's designed specifically for storage. In a fiber channel SAN, we start with servers each having an HBA, a host bus adapter. Now, in the diagram, each of our two servers has two lines stemming from the server, one line to each of the two fiber channel switches. This is called multipath I/O, multiple paths to the storage. So it increases resiliency in case we have a failure, for example, of a fiber channel switch. The fiber channel switches, in turn, are connected to storage arrays. Now, storage arrays can use options such as LUN masking to control which storage consumers can see which space on the storage array. It's also important to note that in a storage area network in this type of environment, the backup units might reside at the storage array location. So we don't have a backup solution perhaps for each server, or maybe you do, but in this context, it occurs where the storage arrays exist at the bottom of our diagram. Let's not forget that we also always have to consider the physical security. Where are these servers and fiber channel switches and storage arrays? They need to be behind locked doors in server rooms or storage closets with locks, or in a data center behind a locked rack. The other thing to consider is for the data being stored in the storage array, is it encrypted? So are we protecting the data at rest? Are we enabling file access auditing so we can track which users are accessing data stored on the SAN at certain times of the day or the night? Because this might indicate some kind of improper usage of data or abuse of privileges for the file system. Even though an Iscsi storage area network should use a dedicated network for this type of traffic, there are some other things we can do to help secure Iscsi connections, one of which is to enable password authentication. So here on my Windows server, I'm going to create some Iscsi network storage that will be available over the network, and I will secure it using password authentication. So to get started here in Windows, I'm going to go into my Start menu and fire up the Server Manager tool. Server Manager is one way that I can install and also uninstall server components. Here I'm going to click Add Roles and Features, and I'm going to proceed through the wizard until I get to the Select Server Roles screen. Down under the File and Storage Services role, I'm going to expand File and Iscsi services, and I'm going to install the Iscsi Target server. The Iscsi Target is the host that provides the shared network storage, whereas the Iscsi Initiator would be configured on storage consumers to reach out over the network to the target to consume that space. So I'm going to go ahead and click Next and proceed through the wizard and click Install. And after a moment, we can see that the installation succeeded. So I'm going to go ahead and click Close. And in the left-hand navigator, still in the Server Manager tool, I'm going to click on File and Storage Services and Iscsi. It says to create an Iscsi virtual disk, start the wizard. Okay, I'll click that. Now the first thing I have to do is determine where I want to store the virtual hard disk file that will be created. That's how the Iscsi Target server is implemented in the Windows environment. I'm going to choose Drive J, and I'm going to choose Next. So notice the path here on Drive J. It's going to create a folder called Iscsi Virtual Disks, in which all of my virtual disks will be stored. So I'm going to go ahead and make this first disk. I'll call it vdisk1. And notice it's got a VHDX file extension. It's a virtual hard disk file. I'll click Next. How big do we want this to be? Well, for this example, let's just make it 10 gigabytes, fixed size, so it will allocate this space now. Then I'll click Next. And I have to choose what's called an Iscsi Target. Now that's confusing because an Iscsi Target is the server hosting the shared network storage. But in this context, what we're talking about is which hosts are allowed to make a connection to this storage. I'm going to choose New Iscsi Target and click Next. And I'm going to call it Allowed Consumers. Now the next thing I'll do is click Next. And I'm going to click Add. So here I can specify things like a DNS name, an IQN reference, an IP address, or MAC addresses of hosts that should be able to make a connection to this storage. So for example, maybe I'll specify just a single host IP address, after which I then can make sure that that value, let me just make sure it's typed in correctly, that value matches to the host that should be allowed to make the connection. So I'll click OK, and currently there it is. I'll click Next. And this is where I want to enable Challenge Handshake Authentication Protocol, or CHAP, where I can specify credentials, a username and a password that will be required when the Iscsi Initiator makes a connection. So I'm going to go ahead and fill in that information. And then on the Confirm Selection screen, I can see that we are ready to go. CHAP is enabled, so I'm going to click Create. So it's creating the virtual hard disk and making it available as Iscsi storage over the network. And after a moment, we can see the process has completed. So I'll go ahead and click on Close. So we now have our virtual disk that has an initiator ID. I've gone and changed the IP to make sure it matches the host that will connect properly. So the next thing I'll do on this same server is act as the Iscsi Initiator, although realistically it's normally a different host. So in the Start menu, I'm going to look or search for Initiator. So I'll type in INI. The Iscsi Initiator software is built into the Windows Server OS. You can also use it with things like Windows 10 as well as a client, as a storage consumer. When I go to the Iscsi Initiator, it'll tell me the Iscsi service is not running, and it needs to be for this to work, so I'll choose Yes. Let's turn it on. And then I'll have to specify the host I want to connect to. So I'm using the same host itself here. So I'm going to go ahead and pop in the IP address and choose Quick Connect. And we now see that we've got some storage available. However, notice by default that it says down below, unable to log into the target. That's because CHAP is enabled. So what I would do in this case is I would choose to connect, not Quick Connect, but connect using other options. And I would click Advanced, where I would need to specify the CHAP logon information. So I'm going to go ahead and specify that info here that I configured when I set up the Iscsi Target. And so now, after having specified the authentication information, we now have a status of connected. And so what that means then is on this server, this Iscsi Initiator in this particular context, if here in the Server Manager we look at disks, we'll see that we have access to our new 10 gigabyte storage space available through Iscsi. Now, if that doesn't show up right away, you can always go to the Tasks button in the upper right and refresh the screen to make sure you're looking at the most up-to-date information. These days, Is Audit team members need to be well versed in cloud computing technologies, including cloud storage. We need to be aware of laws and regulations that might apply to the organization and its data, where it might specify things such as whether or not cloud storage is even allowed in the first place. And if so, it might be required that the data centers housing the physical storage of our data be within certain national boundaries, and that the data center technicians are of a certain nationality. There are a number of items to consider related to cloud storage security, both from the security perspective, IT governance, and also the Is Audit perspective. We have to think about the cloud provider's security compliance. It's one thing for an organization using cloud storage to be compliant with laws and regulations, but what about at the cloud provider level? Some things are out of our control as a cloud consumer, such as the physical security of data center facilities. So we have to think about cloud provider security compliance at the physical level and also compliance with standards such as PCI DSS, ISO standards, and so on. We then have to consider whether we need to use encryption of data at rest. The answer to that is usually yes. So we might be required, for example, to use at least AES 256-bit encryption. Also, we have to consider data retention policies. How long can data be retained, and under which circumstances will it be archived, for example? Maybe if the data hasn't been accessed in more than 90 days, it goes to our first level archiving, after which at some point later, based on our configuration, it gets archived in longer term storage. We then have to think about data wiping practices. What happens when we delete cloud stored data? What techniques are employed by the cloud provider to give us assurances that there are no artifacts that remain that can be recovered by nefarious users? So we have to think about also cloud storage security and external connectivity. So imagine that we've got a smartphone with a cloud storage app. And so what it would then be doing is synchronizing those files so that they are stored in the cloud. Now, depending on the configuration of that specific cloud storage app would determine whether or not the data also resides on the phone or for how long it resides on the phone. Is it in both places? Are we replicating, or is the phone simply used as a gateway to access cloud storage? Then we have to think about how secure is the smartphone. Even if data is not stored on the smartphone, we have to consider the fact that there is a cloud storage app that has access to store data in the cloud. So we don't want the phone to be compromised for that purpose. Also, if we are storing a replica of files that are replicated to the cloud on the smartphone, then we certainly want to enable mobile device storage encryption. Then encryption would also be something we'd have to consider when it comes to replicating over the network, such as over the internet. And then the encryption on the cloud side, the encryption of data at rest. All of these are considerations for the Is Auditor. It really depends on the nature of the business and which laws and regulations would apply. Some organizations and also some government agencies and law enforcement agencies might require data to be wiped in a specific manner from storage media. Also, there might be requirements to physically destroy storage media, such as physically shredding drives. In this case, I'm going to be using a free tool I've already downloaded and installed called Disk Scrubber. From the Drive to Scrub drop-down list, I can choose the disk I want to wipe. In this case, it's going to be drive E on my computer, a USB thumb drive. Now down below, I can determine the scrub type, the overwriting that I want to use, whether it's normal or whether it's specific types of wiping mechanisms, such as Ultra, 9-stage wipes going over it 9 times as per Department of Defense or the US DoD recommended specifications. So I'm going to leave it on that default. And what I'm going to do at this point is choose to scrub the drive. So I don't want to scrub specific files or folders, but rather the entire storage media. Now when I choose that, we can see up at the top the current progress of scrubbing this drive using, in this case, the Ultra 9-stage type of scrubbing. We can also see the estimated time remaining to properly wipe this device. So depending on the requirements of the organization will determine whether a secured disk wiping or scrubbing solution is required. Pretty much all software uses some kind of a database to store records of some kind, configuration information or data relating to customers and so on. And so it's important then that we secure databases. Databases can exist on premises, so for example on enterprise database servers, whether they're physical or virtual, and databases of course can also be deployed in the cloud. Now we're talking here about database servers that house databases. And so both components really need to be hardened. Then mobile devices enters the picture. What does a mobile device have to do with the database? Well, pretty much every mobile device out there has some variation of SQLite as a database. So whether it's an Android phone or an iPhone or a Mac, a Windows 10 computer, all of these platforms will store information in a SQLite database. So you're going to have a database then on every mobile device is really what we're saying. Database security begins with network security, where we can isolate database servers from other network hosts where required. And we can build firewall rule sets specifically to allow connectivity to the database from specific origins. We want to make sure that we don't place databases on an enterprise network, specifically in the DMZ, the Demilitarized Zone. The Demilitarized Zone is a portion of the network whereby whatever is in the DMZ is made available, for instance, to the public internet. And while we might want the front end for a web application to be accessible that way to the public over the internet, maybe not the database, at least not directly. And so the database should be on another internal private and secured network. At the server security level, we must go through standard operating system hardening techniques. So physically securing the host by placing it behind locked doors, preventing booting from removable media, patching the OS, applying anti-malware solutions, disabling unneeded accounts and services. All of that standard OS hardening stuff needs to be applied. So once we've done all of those things, we should also configure server firewall rules to control access to the server and strong access control mechanisms, meaning we might consider the use of multi-factor user authentication before allowing access to the database server. Database security also includes encryption of data at rest, so encrypting the data stored in the database, enabling data masking. So for sensitive data like credit card numbers, when it appears on the screen, we can have it masked with other characters to hide the true values. And often there will be an option where we can actually display, for example, the actual credit card number if required. Queries, which are used to ask questions about underlying database data, should adhere to secure coding practices. So this is for developers that build the queries, and also input validation to make sure that we don't allow for the possibility of SQL injection attacks. But honestly, these days, it really depends on the programming framework that a developer would be using. But generally speaking, there are enough safeguards built in where SQL injection attacks just aren't going to be as common as they once were years ago. But it's still something to consider. We should also think about database security at the database level, database objects like tables, views, stored procedures, and also individual rows of data within tables, and column security or field level security. We can control what kind of access is allowed to very granular database object components. The other aspect of database security is going to be availability. So in the diagram on the left, we have an on-premises database, and we can configure it such that we are replicating that into a cloud provider environment. Now, why would we do that? We would do it for safekeeping while ensuring that we have encryption over the internet, if that's what we're using to get to the cloud provider, as opposed to a dedicated network circuit, and also encryption of database replicas in the cloud. We should also consider programmatic database access. Often, in many cases, before programmers can write code that talks to a database in the cloud, they might need some kind of set of credentials or some kind of access key to make that connection. Most public cloud providers provide an option for customers to deploy cloud-based databases, even as a managed service. Managed service really just means that the underlying work and complexities, like setting up the operating system and installing the database software, that's already taken care of for us with the managed service. So it's very quick to deploy and work with in the cloud. Here in Microsoft Azure, I'm going to deploy Azure SQL Database. To get started here in the Azure portal, where I've already signed in, I'm going to click SQL Databases on the left. We don't have any SQL databases deployed currently, so I can go ahead and click the Add button. Now I'm going to have to specify a resource group into which I want to deploy this database, where the resource group is a way to organize related Azure items. So I could create a new one or choose an existing resource group. I've chosen an existing one. Then the database details. I'm going to call this Database Test 172. It accepts the name. We have a green check mark. This has to be hosted by a database server, where I can either choose an existing one from the list if I've got one, which I do not, or I can create a new database server. So I'll click the Create New link to do just that. I'm going to call this DB Server 172. Notice it's going to append a specific DNS suffix here for azure.database.windows.net, and I'm going to fill in the server admin login name and password. Once I've done that, I can determine the physical region into which I want this database server deployed. I'm going to go ahead and click Select. So now we've got our database server listed here. Down below, I can see the compute and storage details in terms of the amount of storage space and the database transaction units, which is a measurement of database I/O. I'm okay with the defaults here, so I'm going to click Next. Here I can specify whether I want to start with a blank database or a sample database or data from a backup. I'm going to leave all of that stuff as it is. I'll click Next. Here I could use tags to associate this database with, for example, a department or with a project. I'm not going to bother with that. I'm just going to go to Next, and I will review and create this database. So the settings look good. I'm going to click the Create button. Now this is one of those things, after it's been deployed in the cloud, only keep it running while you need it. Databases running in a cloud computing environment can cost a lot of money if you keep them running, even if you're not using it. So be sure to shut it down and delete it when you know you don't need it anymore. Before too long, our database deployment is complete. So now if I go to SQL Databases on the left, we can see our database listed here and the server, of course, on which it is hosted. It's currently online. And when I click on it, it pulls up the property sheet. So I can see, for example, the database server name listed up here as accessible over the internet. This would be important because if you wanted to connect to that SQL database running in the cloud, let's say from your on-premises environment, using a number of tools like SQL Server Management Studio, for instance, you could by specifying this server name and then popping in the credentials that were configured when this was deployed. So at this point, we've got our database deployed in the cloud. And as we scroll down, we can see that we've got a number of options that are also available related to things like security, such as transparent data encryption or TDE, which by default is on. So this means that encryption of data at rest is enabled by default with our Azure SQL database. The CIA security triad is comprised of confidentiality, integrity, and availability. The availability side is the focal point here, where we can enable additional availability for a database that's deployed in the cloud. Here in the Microsoft Azure Management Portal, in the left-hand navigator, I'm going to click SQL Databases, where I'm going to see a SQL database running in the cloud that I've deployed previously. And if I click on that database to open up its properties sheet, down under Settings, I can configure what's called Geo Replication. What I'm seeing currently on the map is a blue symbol with a white check mark, which indicates the current physical location of that database. But for additional resiliency against failure in that geographical region here in Eastern Canada, what I might do is enable replication to an alternate region or an alternate location. So for instance, if I just scroll over a bit to the right to show that vertical scroll bar, I can see currently Canada East is the primary replica of that database. And so I've got a number of target regions available down below. How about Central US? I'm going to choose Central US. Now when I do that, it pops up and says that the secondary type of the database will be readable as opposed to writable. And I need a target server. Now when I click on that, I don't have any servers available in that region. So I need to create a new one. So I'm going to call this DB server, let's say 173. So I'm following naming convention standards within the organization, and I'll specify the server admin login name and password. And then I will click Select. So now we've got the server specified. I'm going to accept the default pricing tier, which really determines the underlying horsepower. I'm just going to click OK. So what's now happening is it is creating a readable replica of that database in the alternate region. And we can see here up on the map a little dashed active line that points to where it is going to be creating that geographically. So depending on the amount of data in that database, of course, will determine how long this will take. But this is an important aspect of availability, and it could be a very important part of an IS audit, determining whether the appropriate controls are put in place as part of a disaster recovery plan. Implementing and maintaining a backup and restore strategy is absolutely crucial for the success of the organization, because what holds the most value to an organization? It's data. And so the protection of that data is going to be paramount. It's important that data be backed up so that, for example, if data is deleted, if it becomes corrupted, or heaven forbid, a ransomware infection breaks out, we have something to go back to get a good copy of data, and ideally, a recent good copy of that data. So backup and restore then means thinking of many considerations, as in the case of working with an on-premises backup solution or a cloud backup solution. And often these days, we might do a bit of a hybrid of both, where we've got both an on-premises backup solution, but also we are backing data up or replicating it to the cloud as an off-site additional backup mechanism. We also have to consider the backup schedule. How often do backups need to occur? This is related to the recovery point objective, or the RPO. The RPO, when it comes to disaster recovery, is all about the maximum tolerable amount of data loss. And if that is 12 hours, for example, then that means that our backups have to occur at least once within every 12 hours to adhere to the RPO. If you're dealing with an on-premises backup solution, you are probably dealing with tape drives and some kind of tapes, backup tape storage media. You have to come up with a rotation strategy. For instance, you might have 3 weeks worth of tapes that can accommodate the amount of data that you need to back up. So after you do your first week's backup, those tapes are stored in a safe location elsewhere, and you've got the second set to do week 2's backups. After that's done, those tapes are stored safely elsewhere, ideally off-site, and then you do the same thing with week 3. And when you come into week 4, you can start reusing the week 1 tapes. So that kind of a strategy has to be accounted for. We then have to think about data retention policies. How long do we keep data backups? So if we've got a tape rotation strategy, that has to take into account how long data must be kept. Now you might use tapes and rotate them every few weeks, but then before you reuse the tapes, you might archive the data on write once, read many times type of storage. So that would be called worm type of storage, WRM. So it's long-term, essentially data archiving. You might be required by laws or regulations to keep data for a specific period of time. The other thing to consider is data immutability, and this is especially relevant to archives. When data is immutable, what that means is it cannot be changed. So once data has been archived, as per our policies, then it no longer can be changed. It is a historical record of that data at that time. Then we have to think about data restores. It's one thing to back up data, but quite another to test your restores on a periodic basis to ensure they work, and also to make sure that any security mechanisms are still in place after a restore. So imagine that you're restoring a bunch of files that were deleted from a file server. Well, when you restore those files, you want to make sure that the security settings, the ACL, the access control list for each file, is restored so that people still have their original permissions that they did at the time of the backup. There are three primary backup types, the first being a full backup. So when you configure a full backup, whether it's scheduled or whether it's performed manually, you are backing up all data. Now when we say all data, that depends on what's selected when you configure the backup, whether it's all data on a server, all the data in a folder, whatever the case is, it backs up everything, regardless of whether it was backed up already. Incremental backups only back up new and modified data since either the last full backup or the last incremental. So it's called incremental because it backs new and modified data up in increments. So if on Monday we do a full backup, then on Tuesday we might do an incremental, and it will pick up everything since Monday's backup. On Wednesday, we might also do an incremental, which will pick up everything since the last incremental, which would be since Monday night. So it doesn't go back and include everything that happened Monday. If we do an incremental on Thursday, it only backs up what's new and modified since the last backup the previous time, last incremental on Wednesday. And so when you do a restore, you're going to need all of those sessions, which might be spread across multiple physical tape media. So incremental is generally considered to be the longest type to restore, yet the quickest to back up. Then we've got a differential backup, which means that new and modified data since the last full backup is what gets included. So on Monday, if we do a full backup, we know it backs up all data. On Tuesday, we do a differential. Well, it's everything that's new and modified since Monday's full. On Wednesday, if we do a differential, it's everything that's new and modified since Monday's full. It goes all the way back to the full backup. So it's important as an IS auditor to take a look at the backup strategy currently in place to determine whether it's compliant with laws and regulations that it might need to be compliant with. The Microsoft Windows Server operating system includes a built-in tool to allow for backup and restore of data. Now, while you might need a different enterprise class tool that works centrally on a larger scale, this one serves well for small numbers of servers. So here in my Windows environment, I'm going to go to my Start menu and start the Server Manager GUI tool. I'm doing this because I want to check whether or not the Windows Server backup feature has been installed. So I'm going to start by clicking on Add Roles and Features, and I'm going to go through until I get to the Select Features screen, where I'm going to scroll all the way down because I want to take a look to see if the Windows backup options have been installed. So I can see that Windows Server Backup is listed here grayed out with a check mark, and in parentheses it says installed. So I know that that component is there. Otherwise, I would install it. So given that Windows Server Backup is there, I can then go into the backup tool. So I'm going to go to the Tools menu, and I'm going to go all the way down to the W's, and I'm going to choose Windows Server Backup. Now I can also fire that up, of course, from the Start menu. So from here, we have a local backup option where we'll see if any backups are configured. So we can see the last backup, the next backup, all backups. Well, we don't have anything configured because it's never been used before on this host. So over on the right in the Action panel, we can choose to configure a backup schedule, or we can configure to do a backup only once at this point in time. And of course, we also have the choice of configuring recovery, so we can perform a data recovery from backup. So in this case, I'm going to choose backup once. When I do that, I have to go through the wizard and specify options such as whether I want to back up the entire server, and it tells me how much space I would need, or if I want to cherry pick which aspects of the server I want to back up, which I'm going to do. So I'm going to choose Custom, and then I'll choose Next. Then I click Add Items. I can choose a bare metal recovery. Notice it automatically checks on other items like system state and my disk partitions. Bare metal recovery means I essentially want to back up enough to get the server up and running in the case of a problem. And so bare metal, because I'm installing it on bare metal, although technically it could be a virtual machine I'm actually doing this to. We can also back up specific areas, including the file system. So for example, here I'm going to expand drive letter J, and I'm going to choose Sample Data Files, and I'm going to click OK. Then I'm going to click Next, and it says choose the type of storage for the backup. In other words, where will you be backing this up to? So I'm going to go ahead and click on Next. And then from the drop-down list, I'm going to choose a backup drive I've plugged in, which is showing up here on my server as drive K. So I can see the total space in the backup destination and the free space that's left available. So that's fine. I'm going to go ahead and click Next. I can see what I'm going to back up. I'm going to go ahead and click Backup. And after a moment, we can see that, in fact, the backup has completed. So I'll click Close to close out of that part of the wizard. We can see our last backup succeeded. We can see the date and the time. I could also click View Details to see exactly what was backed up. So we can see here some details related to that. Notice when we go into the details, there's also a link at the bottom, by the way, to view a list of all of the backup files. Now also, of course, we could have clicked Backup Schedule to determine when we want an automated backup to occur. So we can go through, much like we did before, and choose exactly what it is that we want to back up. I've chosen Custom. I'll just choose the same information for this example. And then I'll click Next, and then I get the scheduling options. However, I'm going to cancel that because we also have the option of performing a recovery. And when you perform a recovery, you get to choose where the backup is stored. So we can choose this server or another location. And then I'll get a calendar here where the bold days are the days that actually have a backup. So I can see here we've got a backup. I can see the recoverable items here on the right. And as I proceed through this, we can choose what we want to recover, such as files and folders or entire disk volumes. And then we can start to actually browse through the backup set to the point where we really could cherry pick specific items that we want to continue with for recovery purposes. So having an understanding of how a backup strategy has been implemented is going to be very important for an IS auditor. Cloud storage used for backup purposes has become more and more popular for both individuals and enterprises. There are many variations of cloud storage from a number of different providers, but the overarching concept remains the same. Let's take data stored on a specific device and sync it over the internet to a storage device elsewhere, run by a cloud provider. So if something happens to our device, like a smartphone, we don't have to worry about losing all our data. It's already been synced up to the cloud. So if we get a replacement phone, for example, we're good to go. The data gets synced back down to the phone when we sign in to our cloud storage account. So in this example, I'm on a Windows 10 computer, and I've selected OneDrive here in the Windows Explorer tool, where I can see a couple of default folders like Attachments, Documents, and Pictures, and a folder I've copied here called Sample Data Files, where I have just that, a number of data files. Now notice here that we have a status column, for example. Here we see one that looks like a little cloud, which means that we do have that data stored in the cloud environment. It's actually stored not just locally, but in the OneDrive environment. If I right-click on OneDrive in the left-hand navigator, I can choose Settings. Here I can see the OneDrive account that I've connected to, how much space I'm using of the allocated space available in the cloud. We want to make sure we don't run out of space. So here we have Get More Storage. If we need to pay for more storage, we can also unlink this PC from that specific storage account. Or we can add an account, but I've already got all this configured. Then we get to choose which folders that are stored here in OneDrive locally that will be available. So I'm going to choose folders. Here we have check marks next to all of the folders that we want available locally. These are the ones that exist in the cloud. Now remember, the benefit here is that we can have a multitude of devices, a laptop computer, a desktop, a tablet, a smartphone, and if they've got the OneDrive app installed, and if we're signed in to the same account, we see all of the same files are kept in sync. So that means during the day, if you're using your laptop at work and you modify a file in OneDrive, then later when you're traveling, you can access that same content from your smartphone. So I'm just going to leave that as it is. We also have auto-save options. We can choose to synchronize local folders like documents, pictures, and so on into the cloud. Of course, make sure you have enough space to accommodate the amount of data that you want to back up to the cloud. Same thing with photos and videos. We can determine that when we plug in a device like a smartphone where we've taken a number of pictures, any photos or videos or anything like that will automatically be saved into OneDrive. Same goes with screenshots. Now under network, we've got some limiting options for both upload and download. Currently, they're both set to don't limit. But if we're going to be plugging in, for example, a smartphone on a frequent basis, because part of our job entails taking a lot of pictures and video, perhaps for real estate, let's say, we could be dealing with large amounts of pictures and video at the end of the day when we plug our device in, for example, to a desktop, that are going to be synced. And we might want to limit how much network throughput it can utilize when it's doing that. So for example, I might limit it to 125 kilobytes per second, KBS. Same thing goes for download rates when we want to bring stuff down from the cloud. Now, if you've got a high-speed network that isn't already oversaturated, then this might not make a difference, and so it might not be a consideration. But it is something that we need to think about. The other thing to bear in mind is that when you are deleting content, so I'm just going to select a file here and delete it, it says here it's going to remove it, and indeed it is removed. That also means it is removed from the cloud. So anything that you are synchronizing, any folders that you are synchronizing to the cloud will reflect changes made from a device, because really it's just an interface to what is stored in the cloud environment. Malware stands for malicious software. These days, malware is so prevalent besides the obvious reason of financial gain, but also because of the ease with which nefarious users can build and deploy malware, such as by acquiring a malware authoring toolkit and referring to malware authoring tutorials to build malware, even in some cases without even writing a single line of code. And on the dark web, people even have the ability to rent infected machine networks, botnets, in order to attack other environments. So malware comes in many different forms, and it is a real and present danger in today's computing environment. The other thing that we have to consider is how machines get infected in the first place. Malware infections normally begin with malicious users performing some kind of reconnaissance, whether it's scanning a network looking for certain types of vulnerable devices, or whether it's somehow learning more about a company, reading about employees in the company, the nature of the business, how business processes work, where the next order of business could be for the malicious user to trick a user. Now, that might come in the form of an incoming email message to the user mailbox that looks legitimate, and so the user might trust it. And the user might be tricked into clicking a link or into clicking a file attachment on that message, either of which could be infected with malware, and so could infect the device, whether it's a smartphone or a server, a laptop, even a smart TV in some cases. So the result of this then could be malware that steals sensitive data, that encrypts data and insists on a ransom to be paid before decryption keys are provided, if they're provided at all, or it could end up with a system that's unusable or even data that is deleted. Malware types begin with Trojans. Essentially, this is a wolf in sheep's clothing. It's something that looks innocent. It appears benign when really it's not. And so a Trojan is usually a vehicle used to deliver other types of malware, including things like viruses. Traditionally, the definition of a virus is malware that attaches itself to a file, whether it's an office productivity file like a Microsoft Word document, or maybe it's an app installation file that you're tricked into downloading because it looks like legitimately useful software. And it might actually be legitimately useful software, but a malicious user has infected it. The other thing to think about is media files. And this is a big deal with people downloading illegal copies of popular television shows and music and movies, where we know that if the latest season of Game of Thrones is hot, then we know that we're probably going to have people downloading it illegally, and malicious users will then provide those episodes of that show, but they might be infected. And so this needs to be something that is thought of. In the first place, of course, people should never be downloading content illegally, such as through the torrent type of system. Worms are malware that do not need to be attached to a file. They are self-propagating over the network. So worm malware will normally scan for vulnerable file-sharing hosts on the network, and then when it sees them, it can reach out over the network to infect them. And then that continues on. Ransomware prevents system startup, or it can encrypt data files, or both. But either way, what happens when a machine is infected with ransomware is that a ransom payment is demanded to be paid in some kind of anonymous digital currency, such as Bitcoin. But the thing to watch out for is that there's never a guarantee that even if the ransom is paid and received by the malicious user, that the keys will be provided. And at the same time, it's almost as if we are encouraging the propagation of this further by paying a ransom. IS auditors are not only concerned with technical controls like firewalls and intrusion detection systems and so on. Also, what needs to be important is user awareness and training. This can be considered a preventative measure against risks. Social engineering essentially is trickery and deception, where the goal is for the disclosure of sensitive information from unsuspecting victims. Now, one part of social engineering is fear, such as receiving a message of some kind, whether it's a telephone call, an email message, an SMS text message, something through social media that appears to be coming from a government department. Or it could be a message that appears to be coming from law enforcement. Most people have a degree of fear against government departments like the tax agency for income tax. And if you get a message saying that you need to pay your income taxes, otherwise you'll be incarcerated, that can play on people's fears, and then they can provide sensitive information or even payment. Same with law enforcement. So phishing is a big aspect of social engineering. Phishing means that malicious users will start to send specific messages to people that they know might be inclined to be tricked easily to click on links or to provide sensitive information or to provide a payment for something. We also have to consider the fact that extortion is a reality related to social engineering. Again, it's all based on fear. Even sextortion we hear more and more about, where we get some kind of a threat from a malicious actor about compromising pictures or messages or texts, intimate texts perhaps, that have been sent between people. And there is a threat of revealing this unless a payment is made. So that's another reality. It's an easy way for people to be targeted to make payments, and it's an easy payday for malicious users, as wrong as it is. So extortion, sextortion, and blackmail have been around for eons. We're really talking about how modern technology is being used to perpetrate those types of crimes. So how does social engineering work without malware? Now, we know that people can be tricked on clicking on a link or a file attachment in an email that will infect their computer, but what are other examples of social engineering? Well, one example would be the impersonation of a communications provider technician over the phone. So, for example, someone from the local internet service provider might call the front desk and say they need to make a visit to check on the configuration of the company's internet connection. So then the attacker would then show up physically at that place of business, dressed appropriately so they look the part. Next, the victim, such as a receptionist, might allow an attacker into the server room or wiring closet because they look the part, a call was made ahead of time, and they said they were going to show up to do some kind of servicing. Finally, the attacker would now have physical access to equipment. So network switches, perhaps storage arrays, servers. Basically, the attacker is in a place they have no business being. So it's important then that people, employees within the organization at every level, be aware of social engineering. User training and awareness is one of the most effective ways to mitigate those types of security risks. As an example of a phishing message, we might receive a legitimate looking email. So it might look like it came from our boss, or it might look like it came from a government agency. And we might have a link in that email message asking us to reset our user password. So for instance, it might look like it came from our help desk within the company stating that mail servers are being upgraded this weekend. Please reset your password, otherwise you will be locked out. So it's kind of playing on people's fear, and people want to comply with what's being done in the company, so they might easily be fooled to do that. Next thing is the victim would click that link, thinking it's legitimate, thinking they're doing the right thing. The link might then download and install malware, or user credentials that they enter in are sent out to malicious users. So people need to be aware of this. Pictured on the screen, we have a real example of a phishing email message. It looks like it comes from Commonwealth Bank, but if we look carefully at the email address up at the top, it looks rather convoluted. It does not look legitimate. Then down below, it says that our account has been locked due to several unsuccessful login attempts. And this would be strange if, for example, you are not a customer of Commonwealth Bank. But even if you are a customer of Commonwealth Bank, if you read their security policy carefully, it will state that they will never send out an email message asking you to click a button or a link to unlock your account or anything like that. So we need to be very careful with making sure, as part of an IS audit, that there are controls in place to mitigate this type of risk. And that could be periodic lunch and learns to make people aware of these types of scams. So we know then that user training awareness is important. We need to also make sure we've got related security documentation that's easily accessible to users. That might be through an intranet website, for example. There should be periodic email reminders about security. You want to be careful with this one because too many means that people will essentially grow desensitized to the volume of security-related messages they might be receiving. We could also have security posters in the workplace so people will see them all the time. At the technical side of things, we've got controls that can be put in place such as email spam filtering, up-to-date malware scanners, network firewall rules to control traffic, host firewall rules to control traffic at the individual host level, and finally intrusion detection and prevention systems to look for suspicious activity. In this exercise, you will start by listing ways to secure a storage area network. Following that, you'll list ways to secure a database server. Next, you will define social engineering. And finally, you'll describe ways to prevent malware infections. Pause the video and take a few minutes to think about these 4 items and then come back to view the solutions. A storage area network, or SAN, can have security applied in the sense of ensuring that the storage components are on an isolated network. We don't want to have a storage area network such as Iscsi transmitting traffic over a regular network where normal TCP/IP traffic is also present. LUN masking can be used to control which consumers can see which shared storage configured on the SAN. We should also have a separate SAN management interface on a protected network, just like we would do for a hypervisor that runs virtual machines, a separate network card that allows remote access. We should also have separation of duties so that, for example, we don't have a SAN administrator that has the ability to completely configure all security aspects of the SAN, including backups. Database security begins with placing database hosts on an isolated network and then configuring network, host, and database-specific firewall rules to limit access to the database. Standard operating system hardening, such as patching and removing unnecessary accounts and services, is also crucial to hardening a database server. When it comes to access control and permissions, we need to make sure that the principle of least privilege is adhered to, whereby anyone granted access to the database server is granted only the access needed to perform their job tasks and nothing more. We also have the ability of implementing database object, such as tables and views and stored procedures, security on them, as well as security for individual rows stored in tables and columns. Data masking can be used to hide sensitive data that might be displayed on the screen, such as credit card numbers. We can also encrypt data that's being transmitted over the network to and from the database server, and also data actually stored on media, so the databases themselves, in other words, data at rest. Social engineering, really, if we were to ball it up in one phrase, is user deception. That means tricking users, not the user being the deceiver. And so it really is all about sensitive information disclosure through trickery, and it does not have to use technology. For example, social engineering could come in the form of making a phone call and tricking somebody to divulge a password or to make some kind of a payment that shouldn't be made. Malware can be prevented with periodic user awareness and training so that people know not to click on things that might be questionable, and also to question things that look legitimate when it comes to things like messages in their inbox. We should have up-to-date anti-malware solutions. We should have intrusion detection and prevention systems to detect abnormal activity and in some cases even be configured to stop it in its tracks. The use of technology is not without its risks, and that's where high availability kicks in. We're really talking here about reliability. Reliability of our data processing systems that support business processes, data itself, and also the business processes themselves to make sure that the business can still function in the event of some kind of a negative incident occurring. Unavailability could result in things like reputation loss for the organization, or lack of compliance with laws and regulations, and that in itself might be the reason for the IS audit in the first place. It could also increase customer wait time, which could result in loss of revenue over time for the organization. And in a worst-case scenario, unavailability of an important system or process could also put personnel safety at risk. So high availability comes in many different forms. One thing to consider is a service level agreement or an SLA, especially if you are outsourcing some of your technological solutions to a public cloud provider. Now, an SLA is a contract that guarantees a specific level of service, including how available something is, such as cloud storage or a cloud-hosted website that you're using for e-commerce. With IS availability auditing, we need to make sure that we prioritize processes as well as systems data. The systems themselves don't have as much value as the data that they result in. So a virtual machine unto itself isn't as crucial as the data it produces, whether it's running off-premises or in the cloud. So as an IS auditor, you need to think from the context of assessing current availability implementations to identify any risk or deficiencies that are unacceptable. Availability solutions would include things like data backup, whether that's on premises or done in the cloud, or perhaps a hybrid of both. As an IS auditor, we have to look for all of these variations. Replication to other regions, such as replicating an on-premise database into the cloud, or clustering or load balancing a busy web app to improve performance and also increase availability. Other availability solutions would include using redundant internet connections, especially if you have important business processes that depend on systems or data in the cloud. If your connection to the cloud is your internet connection, you want to make sure you've got some redundancy built in. Backup power generators can be used to supply power to data centers or to systems that still need to be up and running, such as e-commerce websites that might have clientele globally. Uninterruptible power supplies, or UPS systems, are designed to provide power for a short period of time compared to a backup power generator, usually used to bring down systems gracefully in the event of a power outage. So all of these things we need to consider when looking at availability within the context of an audit. In some cases, the scope of an IS audit is going to include taking a look at how negative incident handling is done within an organization. And that's where the Disaster Recovery Plan, or the DRP, comes in. The DRP is part of the overall Business Continuity Plan, the BCP, which exists to ensure the ongoing functionality of business processes. So some examples of problems that we'd want to plan for proactively ahead of time would be things like a crashed e-commerce website, or a remote data center that is no longer reachable from other locations, or corrupt data, or other issues such as a fire that could destroy a location that might house sensitive data. So what we need to think about in terms of IS auditing is what are the likelihood of these events actually occurring. Remember that always considering risk is an important part of being an IS auditor. When it comes to disaster recovery planning, we have the recovery time objective, the RTO, and the recovery point objective, the RPO. Let's start with the RTO. The RTO is related to the maximum tolerable amount of downtime. So it means that we're tracking how long it would take to do things like bringing an important system back online, or recovering data that isn't available for some reason, maybe due to deletion or corruption, or how long it would take to move business operations to an alternate site. In this case, a smaller RTO is better. The less time it takes to get back to business, the better off the business is. The recovery point objective, or the RPO, is different. This deals with the maximum amount of data loss that can be tolerated by the organization. And so that means it will be related to how often backups are taken. And think about things like finance servers in the organization versus a file server that contains employee documentation. Naturally, the data on the finance server is going to be a lot more valuable than the data on the file server that contains documentation. And so the RPO then will be different for those items. We might have an RPO for the finance servers where we can tolerate up to 6 hours of data loss before there are serious negative consequences against the organization. But for a file server with documentation, we can handle more data loss than that because we can regenerate that data. It's documentation as opposed to something like financial information. The other thing to consider is the mean time to repair, or the MTTR, and the mean time between failures, MTBF. Let's start with the MTTR. The MTTR really relates to the restoration time average to get a piece of equipment or a service up and running. So normally it deals with equipment reliability, such as hardware for an IT environment. So the more mature a system is, the less time is needed for restoration. Maybe due to honing the amount of time it takes to do it gets reduced over time. The other thing is the less time, better. For the mean time between failures, this is an average for the failure rate, for example, for a piece of equipment or for a system like an e-commerce website. And we can determine the availability percentage by taking the MTBF, the mean time between failures, divided by, and in parentheses, the mean time between failure plus the mean time to repair, and then outside of the parentheses, multiply that by 100. So let's look at an example. Let's say that we've got an important e-commerce website, and based on historical data, it seems that it comes down approximately once every 250 days, which works out to be about 6,000 hours. So that's where the 6,000 comes from. And let's say on average it takes about 4 hours to recover that failed server, maybe due to reimaging and restoring data back onto it. So then filling in those values in our availability percentage formula, we can then determine that the availability percentage in this example is 99.93%. A disaster recovery planning document contains a lot of items, including the recovery objective. So what is the scope of what we are trying to recover in the event of a negative incident? So the scope is a big part of it. We then have to think about the disaster recovery plan team member responsibilities. Because we're talking about proactive planning and handling negative incidents, people involved need to know their roles and responsibilities. There needs to be contact information in case people within the organization need to be notified when a negative incident occurs, which could also mean contact details for escalation. If we need to escalate a problem that can't be resolved, then we have to have that information set up ahead of time, and DRP team members need to know about it. In accordance with the auditing process, IS auditors need to consider the audit objective and the audit scope, and sometimes that will include looking at business continuity plans within the organization. In other words, the proactive planning on what to do when things go wrong. So this is proactive planning for business disruptions, things like natural disasters, man-made disasters. So employees need to know their roles when it comes to business continuity. And that means having up-to-date documentation easily accessible by different employees in the organization. So for example, for an IT server team on premises, they would have to have knowledge of and access to up-to-date documentation on the step-by-step procedures to be followed when servers fail. So business continuity then is a crucial part of an organization's risk management strategy. A business impact analysis, or a BIA, is a document and a process that we go through to identify and prioritize assets. Now, because we're talking about IS auditing, we know that this is always based on risk and managing that risk. So we need to consider the loss of an asset, the likelihood that that would occur, and the restoration time should it occur. We have to think about things like the amount of revenue that would be lost in the event of this negative incident actually being realized, reputation loss for the company, also non-compliance with laws and regulations, and reduced shareholder confidence. So for example, if we've got an intranet website that employees connect to, let's say for training, maybe it's for new employee hires, for onboarding, that would be a different issue than if we have an e-commerce site that fails. So with a failed intranet user training site for employees, that means user training can't occur, which is fine relative to an e-commerce site that's failed and is no longer generating revenue. So it's important then that we prioritize the assets and then focus our energy on those assets that have the most value to the organization. The Business Continuity Plan, or the BCP, is used to identify critical business processes and, of course, the technology that supports those business processes. We need to have specific disaster recovery plans. So a disaster recovery plan, or a DRP, that would relate, let's say, to failed e-commerce servers versus a malware outbreak on a network versus having a network compromise on a Wi-Fi network segment. So we need to consider things like alternate business sites that we can relocate to continue business operations. Or, during a crisis, the ability to outsource certain types of tasks, such as using a different payment processing provider in the case of a failure within an e-commerce website type of ecosystem. So there needs to be a periodic review of the business continuity plan to ensure that it's up to date and that it's effective. When specific types of incidents are known to have occurred within an organization, it can trigger an incident response. And that's where we're going to focus on the incident response plan side of things, or the IRP. So the incident response plan then is something that needs to be created, planned for, and placed into effect before negative breaches. Effects of inadequate incident response would include things like financial loss to the organization, reputational loss, business partnerships that will suffer, or contracts that will be negated due to some kind of a problem, such as a security breach that is shown to have been easily preventable. So therefore, there needs to be, at the minimum, an annual review of incident response plans to keep up with changing threats. Bear in mind, we're talking here about multiple incident response plans for different types of incidents and different types of systems or environments. So it's not as if there's a single incident response plan that's all-encompassing. Because dealing with negative threats that are realized against, for example, an e-commerce website will be dealt with differently than if we have a customer credit card information data security breach. So we need to think about the step-by-step procedures that are part of incident response that outline the exact steps that should be taken as part of the response. We need to make sure that data flow diagrams are available. When we have incident response team members responding to an incident, we don't want any questions about what should be done or how something works. It needs to be spelled out very clearly. And so that's why data flow diagrams, such as for an e-commerce purchase system, should be clearly outlined and made available to incident responders, along with network diagrams that might show the names and IP addresses of hosts involved in a certain business process and their placement on the network, which could also include things like usernames and passwords to authenticate to those hosts, or a call list so that we know who to contact that does have access to those hosts. We would need to have system configuration details available in order to respond to an incident properly. The call list we talked about could be used not only to talk to other technicians that might have access to a system that incident responders do not, but also to notify any other stakeholders about the incident that's occurred. So we need to think about the step-by-step procedures that are part of incident response that outline the exact steps that should be taken as part of the response. We need to make sure that data flow diagrams are available. When we have incident response team members responding to an incident, we don't want any questions about what should be done or how something works. It needs to be spelled out very clearly. And so that's why data flow diagrams, such as for an e-commerce purchase system, should be clearly outlined and made available to incident responders, along with network diagrams that might show the names and IP addresses of hosts involved in a certain business process and their placement on the network, which could also include things like usernames and passwords to authenticate to those hosts, or a call list so that we know who to contact that does have access to those hosts. We would need to have system configuration details available in order to respond to an incident properly. The call list we talked about could be used not only to talk to other technicians that might have access to a system that incident responders do not, but also to notify any other stakeholders about the incident that's occurred. And in some cases, that could also include things like a public relations department. So the call list then is really a contact list for the incident response team. On that list, we might have detailed communication information for how to get a hold of the Chief Information Officer, CIO, or system administrators, legal counsel, law enforcement, the public relations or PR officer, and so on. Then there's the compliance side of things. In many cases, organizations and government agencies must remain compliant with certain laws and regulations. And as such, if we've got some kind of a security breach, there might be a requirement to notify certain parties, including affected individuals, such as customers. Anything that deals with personally identifiable information, or PII, is usually subject to some kind of rules about reporting security breaches, such as the United States HIPAA breach that involves more than 500 individuals, or the Canadian Digital Privacy Act. So when customers or patients or anyone whose PII is somehow disclosed without their consent, notification is required by the party that gathers, processes, or shares that information. So as an example, imagine that we've got a requirement to notify customers when their credit card information has been breached. When the Is audit is related to things like high availability, alternate recovery sites can be something that an auditor needs to look into. Alternate recovery sites allow for business continuity, and in some cases, it could include physical facilities that are used as an alternate plan B in case our primary location where business is conducted becomes unavailable. So it could also be an alternate network location for IT services that doesn't even need to be another physical facility under an organization's control. So for example, it could even mean that we've duplicated a network environment and IT systems and data in the cloud, in the public cloud. So if we have a failure on premises, we've got our systems and ideally up-to-date data that's been replicated into the cloud. The other thing to consider are the types of alternate sites. An alternate physical site would include a cold site. This is an alternate business location. However, it does lack things like hardware, IT hardware, software running on the hardware, and data. So it's called a cold site because it's not ready to be up and running immediately. A warm site, again, is an alternate business location that has hardware and software available, but what's missing is data. So in order for a warm site to be operational in the event of some kind of negative incident, then the data would need to be restored from backup before the site is operational. A hot site is another alternative business location that turns out to be the most expensive because it's essentially a duplication of a primary functional site. It's got the shortest recovery point objective, or RPO, at least compared to cold and warm sites. That means that it's got hardware, software, and up-to-date data. Normally, it means that data has been replicated from the primary site in real time or near real time, so that when we have a failure, the hot site has what we need to keep the business up and running, to keep business processes supported. Part of the information system or Is Audit process is to determine the audit objective. And in some cases, that objective could be to take a look at data high availability. And that's where redundant array of independent disks, or RAID, kicks in. What we're talking about is multiple physical storage devices that work together as a single logical drive. Now, why would we want to do that? Well, the real benefits would be increased performance for disk reading and or writing, and also additional fault tolerance, so the tolerance of one or more failed disks. And this would apply whether we're talking about disk storage arrays on premises and in the cloud. So we can do this using our hardware RAID controller. This is firmware that would exist automatically in most modern servers that allows the connectivity of multiple disks to be configured as RAID, of which there are many different levels, some of which we'll identify in this discussion. Another alternative, in the absence of a hardware RAID controller or circuit board, is to use software RAID within the operating system. However, when you have the choice of using a firmware dedicated solution versus software within an operating system, you should gravitate towards the firmware hardware solution. RAID 0 is called disk striping. Imagine that we've got two disks. Well, with RAID 0, what we're doing is configuring it such that when we have a write to the disk, to the logical disk, there's two physical disks, but it would look like one logical one in the OS. When we have a write to that logical disk, the data would be striped or written across all of the disks in the array. Here, there's only two disks in the array, but you could have more. What's the benefit of this? Increased performance. You've got more disks doing the work than reading and writing to a single disk, but there's no fault tolerance. If we have a failure in one disk, all of the data is inaccessible. RAID 1 is called disk mirroring. In this example, what we're doing is writing something to a logical disk that's configured as RAID 1, but what happens is that same data is actually written to both disks. Now, you're not going to really see a performance improvement on the writing side, but you could when reading that data. And certainly there's fault tolerance here. Essentially, if we have a failed disk, we don't have to worry because we have an up-to-date copy of the same data on the other disk that was mirrored. Now, this doesn't mean you shouldn't do data backups. Most certainly, we still should be doing that in addition to configuring RAID options such as RAID 1. RAID 5 is called disk striping with distributed parity. With this RAID level, we need a minimum of 3 physical disks that are grouped together as one logical disk. In this case, what happens is data is written across all of the disks in the array. Well, that sounds a lot like RAID 0, and it is, but there's more. Because parity information, which is really error recovery information, is additionally written on a different disk than the related data. So in this case, we've got 3 disks in our RAID 5 array. So when we have one disk write, let's say it gets broken down into 3 chunks, each of which is written to one of the 3 disks. Well, the error recovery or parity information for what's written on the first disk would never be stored on the first disk. It would be stored on one of the other disks. Because we want to allow not only for an improvement in performance with RAID 5, but also fault tolerance. We can tolerate the failure of a single disk because the error recovery information for the data on that failed disk is on other disks in the array, and it can be reconstructed dynamically in memory, although it will slow down file access. So it's important then to understand how RAID works because it could be related to data availability as part of an Is audit. And certainly there are many other levels of RAID beyond the 3 that we've defined in this discussion. High availability at the disk storage device level can be achieved by configuring RAID, either at the hardware level or, as we're going to see here, at the software level within an operating system. The operating system here is Windows Server 2016, and so I'm going to go into my Start menu and search for Disk, and then I'll choose Create and Format Hard Disk Partitions. Now in here I can see I've got at least 3 disks, which is required if you're going to configure RAID 5. Now RAID 5 is disk striping with distributed parity. So I'm going to go ahead and right-click on the first disk here and choose New RAID 5 Volume, Next. Now the disk I've selected here is already listed on the right, so I'm going to select the other 2 disk items and I'm going to add them so that we've got 3 disks listed on the right. Although the amount of space I'm going to use here is only going to be 5,000 megabytes. That's only to expedite this demonstration. And I'm going to click Next. It'll use drive letter E. So to the operating system, it's going to look like one logical disk, drive letter E, when really we know physically it's 3 disks. I'm going to go ahead and click Next and accept all the defaults and Finish. I then get a message in Windows stating that these disks must be treated as what Microsoft calls dynamic disks for software RAID purposes. I'm okay with that. I'm going to click Yes to continue. And after a moment, it's going to create our RAID 5 volume. And we can see currently that based on the legend down here, the RAID 5 volume is listed with a certain color. And we can see that the same color is applied to the 3 disks where we're using approximately 5 gigabytes of disk space. Currently, the logical drive letter, which will be E when it's completed, is in the midst of formatting so that the file system is usable. After a moment, we'll see that we have drive letter E, and if we were to go into the file system on this host, just to examine how that appears at that level, under this PC, we'll see drive letter E. Notice here that the total size is approximately 10 gigabytes. So that's what you get approximately when you have really what amounted to be 5 gigabytes of space on each of the 3 disks, 15 in total. So you lose a bit of space when you do this, but here it is, drive letter E. It's treated as a regular disk volume that's ready to be used immediately. And the benefit of RAID 5 is we get the performance improvement of 3 disks working together for reading and writing, but we also get the fault tolerance benefit where the failure of one disk can be tolerated. One way to achieve high availability for a database is to replicate the contents of a database to another geographical location. And I'm going to do that here in Microsoft Azure in the public cloud. Here in Azure, I'm going to start by deploying an Azure SQL database and server in the cloud. So I'll click Create a Resource, and then I'm going to choose Databases, and I'm going to choose SQL Database. When I do this, I'll have to fill out some blanks. So for example, I'm going to deploy this to an existing resource group. And down below, I'm going to enter a database name, DB172. And I can either select an existing server if I have one, which I do not in this region, or I can click Create New, which I will do. I'm going to call this Serve172, and I'm going to fill in and confirm the password as well as the admin login name. And after that's been filled out, I will go ahead and click Select. Select that server to host this cloud-based database. So now it's in the list as we can see. As I scroll down further, that's pretty much all I'm going to change. I'm not going to change the amount of storage space or anything. I'm going to choose Review and Create, and I'm going to click the Create button. And before you know it, we get a message stating that our deployment is underway. Now, this is one of those things that when you deploy it into the cloud, you don't want to leave it running when it's not being used because you can accumulate quite a large monthly bill. So I'm going to go ahead and deploy this, after which I will then configure geo redundancy. In other words, replication of the database to an alternate geographical region. And after a moment, if I switch over to the SQL Databases view, we can see indeed that we've got our database DB172 that currently has a status of online. Now at this point, I can see under the location column that it exists in the Canada East region. But if there's some kind of a disaster for the data centers in that region, we have a problem because the data doesn't exist anywhere else. So what I can do is click on the link for our deployed SQL database here in the Microsoft Azure cloud. And I can then, in the Properties blade, select Geo Replication. We can currently see where our data exists. However, the great thing is that we can add other locations we would like to replicate to. So down below, we can see our primary location is Canada East, and here we have target regions. It also says Geo Replication is not configured. Well, that's going to change in a moment. So maybe I'll choose Central US as another target location to replicate that data. But when I do, I have to make sure that I take note that the database name is unchangeable and that the type of that replica will be readable. The other thing is I have to specify a target server in that region. And if we have no servers found, we'll have to make another one. So I'm going to make another one here called Serve173, and I'll fill in the server admin and password credentials. Once I've done that, I'll click Select to deploy that new SQL server in that region in the Azure cloud. And now that that's selected as the target server, I can complete geo-replication by clicking OK. Now, interestingly, if I kind of scroll up here on the map geographically, we can now see that we are replicating from Canada East over towards the location in the US further to the west, so central kind of west. This means after this is completed that we've got geo-redundancy, we've got replication. If we've got a disaster in one of the two regions, we've got an up-to-date copy of the data in the other. Competent IS auditors also need to have a strong sense of IT security and mitigations related to common threats. Network attacks include those against wired networks as well as wireless. Generally speaking, a wired network is considered to be more secure than wireless because malicious users could potentially make a connection to a wireless network without even entering a building. Whereas for a wired network only, it would require on-premises access. Wired networks come in many different forms, such as twisted pair cabling. You'll see that in most common networks, where we've got copper wires within the cables that transmit electronic signals. So what happens then is that we end up having a type of communication that could be relatively easy to wiretap. As long as access to the physical twisted pair cabling is made available, it's possible to insert wiretaps to interpret the transmitted electrical signals going down the copper wires. However, it's not quite so easy with fiber optic cabling. With fiber optic networks, tiny fibers, very thin fibers, are used to transmit light signals as opposed to electrical signals. And as a result, fiber optic then has a longer transmission range than twisted pair because light travels much further than sending electronic signals, which can attenuate over a much shorter distance. However, fiber optic networks, while not impossible, are much more difficult to tap into to capture those transmissions and interpret them. But again, it would require physical access to the fiber optic cabling. The other thing to consider from a security perspective is someone simply cutting a lot of these wires. So, for instance, if we have someone with the ability to go into a fake ceiling in an office environment where fiber optic or twisted pair cabling is exposed, it's not protected within a conduit, well then that might allow them to even simply snip cables, which could, of course, cause a network disruption. So these are the things that must be thought of. We have to account for all possibilities as it falls within the IS audit scope. With wireless networks, we have many different forms, such as near-field communication or NFC. This is commonly used for things like smartphones as payment systems where you can hover the smartphone with the app installed on it, a payment app, very near a payment terminal, such as at a point of sale system in a retail shop, and make the payment. But it requires a very, very close proximity in order for that to work. Another type of wireless network is Bluetooth. This has a range of approximately between 10 or 20 meters. However, that will vary depending on the specific type of Bluetooth device. And also, it depends on whether or not we're using antennas, which could increase that distance. Then we've got Wi-Fi as a wireless network. Most people are familiar with Wi-Fi because they're probably even running it at home, or they've connected to it in a public location, such as a coffee shop or in a bus terminal. Then we've got cellular wireless networks, which are used for today's smartphone communication, at least for connecting to data services and making calls. And then, of course, there is satellite communication, which could be required in some cases, such as ships out at sea, or if you are traveling to a location where there is no other alternative for communication, such as in mountain ranges that don't have cell towers on top of the mountains. And so you might need some kind of a satellite communication device to make a connection to a network. The other thing to consider are attacks such as distributed denial of service attacks, or DDoS attacks. In this diagram, we see that we have an attacker at the top that has a number of computers under their control. Those computers are called robots, or simply bots, and a collection of them is called a botnet. Now, the botnet is under the hacker's control. They would have infected it in some way so that the hacker can issue commands such as for all of those bots or zombie computers within that botnet to attack a victim network or computer, such as sending a flood of traffic that would prevent legitimate connectivity, let's say, for example, to an e-commerce website. Other common types of attacks fall under the umbrella of man-in-the-middle, or MITM attacks. With an MITM attack, what we're really talking about is two communicating parties that think they are communicating directly with one another. In this diagram, that would be the server on the left and the smartphone over on the right. However, unbeknownst to both parties, we've got a malicious user in the middle that has somehow hijacked the connection. And that comes in many different forms. It could be as simple as eavesdropping on the communication and then altering the captured traffic and sending it back to the other party. Or it could mean an attacker has gotten a hold of a user's web browser cookie because their machine is not configured in a secure manner, or the user was tricked into clicking something that ran executable code on their machine, which allowed the attacker to gain access to their cookie. The website cookie would be sent between the client device and the server with things like preferences or current session information. In this example, we're going to talk about Arp Poisoning. This is another example of a man-in-the-middle attack. So on the left, we've got the router. Now, the router allows connectivity to other networks. So even for a tiny network, even a home network, we would have a router that would allow connectivity out to the internet. So the router is going to have an IP address internally, as well as a hardware or MAC address, as we see here. Now, what would happen is that the attacker would somehow get connected to that network, whether it's wired or wireless. Now, the attacker's device would have a different IP address and, of course, a different MAC address, but the attacker would have the ability to spoof or forge the MAC address. Now, this is where things get interesting. It's because if we have a victim device, here pictured as a smartphone, it has what's called an Arp Cache in memory. Arp stands for Address Resolution Protocol, and essentially it's a list of IP addresses and MAC addresses, because on a local area network, devices communicate in the end using the hardware address. And so what would happen is the attacker would send out a forged Arp broadcast that the victim device would read. And that Arp broadcast would essentially be telling victim devices, hey, you know the router, which has an IP of 192.168.0.1, well, its MAC address is, and in this case, 002233445566. That is the attacker's MAC address. So what this means is that when the victim, for example, communicates with something through the router out on the internet, the traffic would first go through the attacker because the victim's Arp Cache thinks that that is the router's MAC address. And from there, the attacker then could capture and have access to all that traffic and then continue to forward off the traffic to the real router. So that's an example of Arp poisoning. And we have to think about these types of possibilities. So this is the communication flow that would occur. DNS spoofing is yet another type of attack that we have to consider. With a DNS spoof attack, attacker compromises a DNS server or the client DNS resolver cache. Remember, DNS, the domain name system, is used to essentially resolve names to IP addresses. That's commonly how it's used. And so what happens then is we could have valid DNS names that users are used to connecting to, or it could be software that automatically makes a connection to DNS names, but it returns a fake IP address. And that fake IP address could point to sites that are under malicious user control. And so there are a wide variety of these types of network threats, whether they're hardware-based for cabling or wireless, or whether they are more software-based, such as with Arp Cache poisoning attacks and DNS spoofing attacks. We know that there are risks associated with the use of technology to support business processes, and some of those things that need to be considered are related to network threats. And so we are interested then in security controls that meet control objectives to mitigate those types of threats. On the wired network side, one way to mitigate these types of problems is to limit access to wiring closets. This is where you would have things like routers and switches and network communication equipment. It should not be readily available to anyone within a facility. It should be behind locked doors. We should also disable unused switch ports. Every single physical switch port that accommodates a network connection, which ends up going through a wall jack somewhere else in the building, needs to be accounted for a device that's plugged in there that is required because there's a user sitting in that office space, in that cubicle, for instance. So if we've got extra wall jacks that are currently not being used, such as in a hallway where there used to be a network printer, if nothing is currently using that legitimately, it should be disabled at the switch level. We should also consider configuring switches in specific ways to adhere to security standards, such as switch port static MAC addresses. In other words, once a MAC address is detected the first time a device is plugged into a switch port, which in the end is through a wall jack, then that same MAC address must remain the same. Otherwise, it could mean that we have an attacker, perhaps that's come in after hours, disguised as a janitor, that's unplugged someone's computer and plugged in their own laptop to try to get on the network. On the wireless side, we can mitigate network threats by doing things such as configuring SSID broadcasting in a disabled state. Now, this is for a Wi-Fi networking. The SSID is essentially the wireless network name. Now, depending on your network requirements, you might want that to be broadcast so that users can see it and connect to it easily, such as on a guest network. However, by hiding that, you're making it one step more difficult for malicious users to detect wireless networks. However, there are freely available tools that will still display them, despite the fact that the SSID has been disabled. The other thing to consider is MAC address filtering. So we can make either a list of allowed MAC addresses that are allowed to connect to a wireless network, or we could specifically list ones that are disallowed. Either way, bear in mind that MAC addresses can be easily spoofed using freely available tools. But again, it's another level of security that should be put in place. It's a good security mechanism. WPA2, Wi-Fi Protected Access version 2, or its newer version 3, should be considered to encrypt Wi-Fi network communications. What we shouldn't be using are older equivalent types of standards like WEP, WEP, or WPA1, or the original WPA standard. Radius authentication allows for central authentication to occur outside of a device, such as not within the Wi-Fi access point. We'll talk about that in a little bit more detail in a moment. We should also configure guest networks whereby, for example, in a medical clinic, if we want to allow patients that are waiting for their appointments to connect to the internet using their smartphones, we would set up a small guest network that would allow them to make a connection to the Wi-Fi network, and the traffic would only be allowed out to the internet. And that would be completely isolated from the network used by devices, by technicians within the medical clinic. Access point isolation mode, or AP isolation mode, is another consideration. Having this turned on means that Wi-Fi clients connected to a Wi-Fi network can only see their own traffic and not other Wi-Fi connected clients' traffic. Network Access Control, or NAC, is a great way to control access to a network. It is the IEEE 802.1x standard, whereby we can configure IEEE 802.1x on supported devices or different types of network connectivity points, like network Ethernet switches, or wireless routers, VPN appliances, or dial-in appliances. Any point that a device could use to connect to a network could be configured with IEEE 802.1x if it supports that standard. And so when we do have devices that support that standard, the network authentication process works like this. The client device is called a supplicant. Let's say that's a smartphone. Now what happens is the supplicant device tries to connect to a network. Now let's say they're trying to connect through an Ethernet switch or a wireless access point, whatever the case might be. In this case, a wireless access point, let's say. Well, the wireless access point is called the radius client. So to be clear, the client device is not the radius client. That's called the supplicant. The radius client is the network connectivity point. Finally, we have a centralized authentication server called a radius server on a separate, protected, and isolated network that actually does the authentication. We don't want the authentication to happen on the radius client because it is the network edge point that allows connectivity in the first place, and as such, it could be compromised. And if it gets compromised through a security breach, we don't want credentials to be made available. Network access control also allows client or supplicant health checks to ensure that they meet certain conditions before they're allowed on the network, besides having proper, for example, username and password credentials or PKI certificates in their possession. The other thing is that some configurations can be auto-remediated. So for example, let's say we've configured our network access control environment such that when devices attempt to connect to a network, beyond letting them authenticate through radius, they also have to have a malware scanner that's up to date. If not, and auto remediation is supported by our solution, a malware scanner could either be installed and or updated with the latest definitions, and then the client will be allowed to connect to the network. Again, when I say client, we're talking about the supplicant, the client device. We could also have a health check that checks that a firewall is enabled on the device, that updates are applied at the OS and software application level, and that even certain correct hardware peripherals are plugged into the device before allowing network access. Another consideration to protect networks is to use VLANs, virtual local area networks. Pictured here, we have an Ethernet switch that consists of 8 physical ports that we can plug devices into. Now, one way to configure a VLAN, and there are others, is to do it by the physical port that a device is plugged into. So in our example, to the left, the first 4 Ethernet switch ports would be configured as a guest VLAN. So anything plugged into those first 4 ports would be considered to be on the guest VLAN, and it might only have access to go out to the internet. However, the next 4 ports in that same physical Ethernet switch where we plug in devices for network connectivity might be configured as the accounting VLAN. And so we've got 2 networks essentially that are configured logically or virtually, hence VLAN, within one physical Ethernet switch. Of course, a VLAN can span multiple switches through trunking, but that's another topic. The idea here is we are keeping traffic isolated. We don't want guest VLAN traffic to ever interact with the accounting VLAN, and perhaps vice versa. Now you might wonder, because they're in the same switch, doesn't that allow traffic to go between the 2 VLANs? Not at all. So this is another way to mitigate this type of network threat and to harden devices. And remember, we might even harden IoT devices by placing them on an isolated VLAN. Firewalls are used in network security to control incoming and outbound traffic from an entire network and also for individual hosts on the network. And the firewall can come in many different forms. It could be a physical hardware device with multiple network interfaces, or a firewall could be implemented as software, such as the built-in Windows firewall in the Windows operating system. Packet filtering firewalls look at things like source and destination, IP addresses, and port numbers. And remember that port numbers identify a network service. So an SMTP mail server would listen on port 25, an HTTPS web server would listen on port 443, but then we have to consider the protocol type. So is it TCP, such as a web server, or is it UDP, such as client requests to a DNS server? Then we have to consider the traffic, whether it's coming into or leaving a specific interface within the firewall. For example, we might allow port 443 traffic for secured websites only in an outbound direction, not incoming, because we might not be hosting an HTTPS web server. The placement of the firewall is always crucial as well. In many cases, firewalls, at least packet filtering firewalls, are implemented within routers, and so they're already at a point between networks. However, other firewalls, like layer 7 firewalls for the OSI model, can look deeper than just the IP address and port number. IP addresses apply to OSI layer 3, port numbers apply to OSI layer 4. So we're talking about content filtering firewalls, layer 7, that can look at the content to make a decision as to whether or not something is allowed. Another consideration at the firewall level is a proxy server, a forward proxy server, which is a configuration. It could be a physical device, it could be installed and configured within an existing operating system on a server. But either way, placement-wise, a proxy server, in this example, would sit between the user and the internet. So it would sit on the DMZ, the Demilitarized Zone. The idea with the proxy server, then, is that it fetches content that is requested by internal users. And that content can then be cached on the proxy server if it's configured to do so, so that subsequent requests for that same content are served up much more quickly because the forward proxy server already has it cached. The great thing about a proxy server too is it normally has multiple network interfaces with TCP/IP routing disabled. And so this means that the proxy software has to be used to make a connection out to the network, in this case the internet. And that means then that we could force user authentication and time of day restrictions. We could even configure whitelists or blacklists of sites that are allowed or not allowed, respectively. Then we get into specialized firewalls like a web application firewall, a WAF. Now what this means is that we've got a firewall that is specific to HTTP and HTTPS communications to a web application. And as such, it provides protection against very specific common web application attacks, such as SQL injection attacks, cross-site scripting attacks, directory traversal attacks, and a large host of other types of attacks. So basically, part of hardening a web application, and this isn't just for public-facing web apps. Just because you have an intranet website only used by employees doesn't mean you should harden it to the fullest extent. Remember, many network attacks actually occur from the inside, for example, due to an infected user computer. So web application firewalls then should most certainly be also applied to intranet websites that might only be used by internal employees. Wireshark is a free and open source network protocol analyzer. It allows you to capture network traffic, whether it's a wired or a wireless network, and to examine it so you can determine whether there are security deficiencies, which is our perspective as an IS auditor. Each line in this capture that has taken place previously represents an individual network packet. And when I select the packet, in the center we get to see the headers in the packet, such as the IP header, Internet Protocol, or the TCP header, Transmission Control Protocol. So this is IP version 6, but if we choose some other packet that uses IP version 4, in the IP header, we'll see some things like the source and destination IP addresses, and that's layer 3. The Transmission Control Protocol, or TCP header, has source and destination port, addresses, which identifies a service. Here we see, for example, a destination port of 80, which is a web server. However, we can identify traffic that is not secure. So we could do that, for example, by determining what's been captured. I know that there's FTP data that's been captured in this network traffic capture file. FTP, the file transfer protocol, has long been used to transfer files over the TCP/IP protocol. And if I filter by typing FTP in the filter line and pressing enter, all I see is FTP traffic. However, the problem with this is we can clearly see that the username that was passed is administrator, and that the password is listed here as a variation of password ABC123, after which the user was successfully logged in. That's how easy it can be to identify plain text traffic when sensitive data like credentials are being sent. And so, in place of doing this, more secure solutions like secure FTP should be used, or perhaps using IPsec to encrypt everything on the network. So even protocols that aren't secure unto themselves like FTP, they would still be protected by other types of network security protocols that would encrypt the packet payload. Host-based firewalls can be a great way to apply a security control that meets control objectives. However, it really is in the details that we have to look carefully to determine if that's the case, to make sure that assets are protected in an acceptable manner to mitigate the risk. So what I'm going to do here in my Windows server is go to the Start menu and type in Fire so that I can choose the Windows Firewall with Advanced Security option. Here we're going to make a firewall rule that will allow inbound traffic to a web server that is within a protected network. So that means we're going to be interested in specifying the source of the connection that gets initiated to the web server. So I'm going to choose inbound rules, and I'm going to right click on that and choose new rule. Now from here I can choose predefined rules, standard stuff that would be available here in the Windows platform. However, in this case I'm going to choose custom for custom rule, and I'll choose next. Then I'm going to apply it to all programs running on the machine, because I'm not specifying it based on an executable that's running here in Windows, but instead a specific protocol type, in this case TCP. Web server connectivity happens over Transmission Control Protocol, or TCP. Now I can specify the remote ports here, so I'll choose specific ports, and I'm going to choose 80,443, or rather I will type that in. Then I'm going to choose Next. Now from here, which IP addresses does this rule apply to, whether they're local or remote? Well, if I've got a multi-tiered web application, so we're talking about the web server component that we're trying to protect here, the database server might reside elsewhere, and also we might want to control traffic into the web application front end. So to do that, I'm going to specify a local address. I'm going to choose these IP addresses locally, and I'm going to click Add. Now from here, I'm going to specify the IP address of a firewall that funnels inbound traffic, basically as a load balanced incoming solution. So I'm going to specify the internal IP address of that host, and I'm going to click OK. So we are now building a firewall rule that not only is limiting allowed traffic to ports 80 and 443 using TCP as the transport protocol, but also only from this specific IP address. And so during an IS audit, if part of what that entails is looking at firewall rules, it's important to look at the need. What is the requirement that's trying to be met by the firewall rule or rule set, and how are those rules configured? At this point, I will click Next. Here we want to allow the connection if it meets the conditions. We don't want to block it. So I'm going to go ahead and leave that, and I'll apply it to all of the network profiles here in Windows, and I'll give it a name. Allow firewall incoming HTTP and HTTPS. And I can put in a detailed description if I so chose. Now I'll click Finish. So we now see that we have our firewall rule, which is enabled. That's the green circle with the white check mark, to allow that type of traffic in from that location. At any point in time, we could right-click and disable the rule or copy it and make modifications if we had the need to make another rule that was similar in nature. content filtering firewalls, as the name implies, can allow or deny traffic based on the content of the request, as opposed to packet filtering firewalls, which can really only look at packet headers that would include things like IP addresses and port numbers. Here on my wireless router, I'm going to go ahead and log in to create some content filters, and then we'll test them to make sure they block the appropriate traffic. Once I've logged in, I'm going to make sure I go into the Firewall tab, but depending on the model of firewall you're working with will determine exactly how you configure the firewall rule sets. This is simply a consumer-grade wireless router. So the first thing I notice is that the firewall is enabled. We can see that with the check mark, and some other security mechanisms are built in here too, like denial of service attack protection and so on. What I'm interested in doing is clicking on parental controls over here on the left. For an enterprise class firewall device, it'll be labeled as something different, presumably, and you'll also have the ability to configure a multitude of firewall appliances in the enterprise through a centralized policy management tool of some kind. So parental controls in this case are enabled. Down below, I can either filter based on certain keywords that I don't want to allow access to, regardless of what the website URL is, or I can actually filter by website URL, which I'm going to do in this example. So for example, let's say we don't allow access to social media sites like Facebook.com on work networks all week and all day, so all the time. So I'm going to add that website filter. After a moment, it will be in effect on this wireless router, which has an embedded web server. That's what we're configuring it through. And sure enough, if I open up a new tab and try to go to Facebook.com, I get a message about not being able to connect. Can't provide a secure connection, when normally that works just fine. So in other words, our content filtering firewall, through which all internet traffic is funneled, is now blocking access to a social media site. And that might be in accordance with an organization's security policies in terms of data loss prevention, to disallow access to social media sites. In this exercise, you will first differentiate between RPO, the recovery point objective, and RTO, the recovery time objective. Next, you'll describe when RAID 0 should be used instead of RAID 5. You'll then list network security options that can be used to harden a network. And finally, you will configure software RAID level 1 using a Windows Server virtual machine. Pause the video and think about each of these items, and then come back to view the solutions. The recovery point objective, or RPO, is really all about the maximum tolerable amount of data loss. Now that's expressed in time. So maybe before we have really serious consequences to the organization, maybe we're hosting an e-commerce site, the company can tolerate a 3-hour data loss window. That's it. If we lose any more than 3 hours worth of data, it could really be detrimental to the organization to the point where it could cause serious problems. Now, the recovery time objective, or the RTO, is the maximum tolerable amount of downtime. Has nothing to do with how much data is lost, but how long something is not functional before we can return back to a normal business operation. There are many different RAID levels, such as RAID 0, which is disk striping. This improves the performance because we've got multiple disks handling reads and writes, and it requires a minimum of 2 disks. RAID level 5 is called striping with distributed parity, where parity is essentially error, recovery, or rebuild information. So it improves performance and availability. That's because it can tolerate the loss of 1 disk in the array. With RAID 5, you need a minimum of 3 disks. Now, network security is a pretty general umbrella term. So what can we do, generally speaking, to secure a network? Well, at the cabling level, using fiber optic is considered more secure than twisted pair. We should always encrypt data in transit, whether we're using a VPN or HTTPS for a website with a PKI certificate, or even IPsec. We should consider using network access control devices so that we can check that devices connecting to the network are configured in a certain way before they're allowed on the network, such as having an up-to-date anti-malware scanner, and also so that we could use centralized authentication. At the Wi-Fi network security level, we should disable SSID broadcasting, and we might want to enable MAC address filtering to limit which devices can connect to the wireless network. But always bear in mind that MAC addresses are easily forged with freely available tools. The last thing I'll do is configure RAID 1 disk mirroring within a Windows Server virtual machine. In my Windows Server virtual machine, I've already added a number of virtual hard disks. So from the Start menu in that operating system, I'm going to go search for disk and choose the Create and Format Hard Disk Partitions tool, although there are other ways to work with disk management. Here I've got a number of disks that are available, such as disk number 2 and 3, which I want to configure mirroring for. So I'm going to right-click on the first of the two disks, and I'm going to choose New Mirrored Volume. That's for RAID 1. And I'll click Next. So the disk that I right-clicked on is selected here. I will add another disk, and I'll tell it I only really want the mirrored partition to be 5 gigabytes. So the unit of measurement here is megabytes, so I'll just pop in a value of 5,000. And I will click Next. I'll let it use drive letter E and accept the defaults, and I'll click Finish. I'll choose Yes when it asks to convert these disks in the OS to dynamic disks, as they're called. After a moment, we can see here that the legend shows a dark red color for a mirrored volume, and in fact, that is what was used here. Now, we can see that it very quickly formatted that tiny mirrored volume. So let's go ahead and see how that looks at the operating system level. Let's go into Windows Explorer, where we can now see drive letter E, a single drive. And drive letter E is listed here as having about 5 gigabytes in terms of space, when really we have two 5 gigabyte disks. That's pretty much how it works with RAID 1 disk mirroring. You get 50% of your available disk space that is actually usable. Because remember, what gets written to one disk is automatically written to the second disk. The software development lifecycle, otherwise called the SDLC, is a structured approach that's used to manage complex projects related to IT. One of the things that's important to do is to assess whether or not secure coding practices are in use during the development of the solution, and even after the fact when building smaller updates that will be deployed as part of that solution. And for that, we can refer to a number of resources, such as the OWASP Top 10, as related to web application security, the SANS Institute, and the Center for Internet Security. The first SDLC phase is the definition of the requirements, where the business need needs to be clearly defined. What is the purpose of going into this endeavor where we are building an IT solution? How does it serve the business? That also can include conducting a risk assessment. What risks are introduced by building this solution and engaging in this type of activity? The next thing we have to do is define what kind of inputs are required to feed into this software solution and what the resultant outputs are. Now, that's going to be important because it will help us define how to secure data. So if it's going to result in very sensitive data, such as protected health information, then we have certain laws and regulations that might dictate how that data is treated. The next thing we have to do is think about the planning and design phase, where we have to determine, for example, will this software solution be available as a mobile device app? Where will the solution be used? What laws and regulations must be complied with? And that's going to drive, of course, some of the design items in this solution. Do we need high availability built into the solution? That could drive configuration such as replicating back-end databases to different locations. And of course, part of planning and design is assembling a team, people that have the right skill set to do the job. Next, we have coding. In the coding phase, secure coding practices must be followed. Now, it's important to understand that security needs to be a part of all SDLC phases. But at the coding level, specifically, we have to think about security as related to coding. And that would include things like making sure we have strong input validation. Any user input into an application is generally treated as hostile or untrusted. And so it needs to go through proper sanitization to make sure that we aren't receiving malicious code through, for example, user input fields on a web form. Another part of security coding practices is a peer review to make sure that we have another set of eyes looking at code to look for not necessarily syntax errors, but perhaps logic errors or flaws of some kind that could perhaps disclose sensitive information that should be kept hidden. In the testing phase, various types of tests will be conducted depending on the nature of what's being changed. Now, this could be part of the initial development of the solution or just an update after the fact. So as a result, we've got a number of different testing types, like unit testing to test just a tiny segment of code, or functional testing to test the overall functionality, and user acceptance testing, where we would engage subject matter experts or end users that will be using the solution to make sure it meets design requirements and does what it should do. Even regression testing when we make changes just to make sure that the changes don't introduce new problems. Also, we might include fuzz testing where we throw unexpected data to the app to see what the results will be. We observe the results to ensure the security and stability of the solution. In the SDLC deployment phase, we might start by using a small pilot testing group to see how the behavior of the solution will be in a production environment as opposed to within the development environment. Another part of deployment is continuous integration and deployment, where developers will be making changes to segments of code and then making those available almost immediately. Now, often that's driven by automation. So when a developer checks out a piece of code and makes a change and then checks it back in, that could trigger regression testing. And then after that is successfully passed, then that solution can be made available. And even in the case of mobile apps, push notifications might be used to notify end users of an update that has passed testing. Finally, we have the operation and maintenance phase, where the solution is maintained. That means also dealing with help desk tickets related to end user problems with the app, adding user accounts, and applying the actual updates. Now, the deployment part deals with the deployment of the updates, but the operation and maintenance also deals with making sure we have the latest updates. The periodic review of security controls is going to be important over the lifetime of the solution to ensure that security controls that were effective earlier at a point in time are still effective. Otherwise, new security controls or changes to existing security controls must be employed. IT project management, otherwise called ITPM, is a structured approach to the management of IT projects where the primary goal is to align IT solutions with business goals. So then it's important that we have projects within the organization that work towards serving the organization, the business. IT project management considerations include ensuring that projects come in on time. This means diligent project tracking using project management software to ensure milestones are met. Compliance is going to be important as well to ensure that laws and regulations are complied with throughout the lifetime of the project, and also ensuring that the project is on budget. Remember, the overall goal of IT project management is to carefully monitor projects through all phases to make sure that the technological solutions that support business processes provide value to the organization. Now, being on time with the project, being compliant with regulations, being on budget, these are not things that we only consider at milestones or at the end of the project. They need to be considered at all phases of project management, just like considering security needs to be a constant issue that is addressed, not just after the end. So part of being on budget in a project is thinking about security throughout the entire project, and not at the very end of the project where sometimes we have to retrofit security solutions, which ends up being much more expensive than if we had thought about security from the onset of the project. Other project management considerations would include risk management, where we have to identify assets, threats to those assets, and the likelihood of risk. The next thing is managing teams and resources, where we assemble the appropriate skill sets for the project. Now, in some cases, that means that we will have to outsource work. And so we have to think about supply chain and outsourcing management and security related to that, such as ensuring, for example, that using an outside contracting organization adheres to specific industry certifications and security standards. We also need to make sure that stakeholder expectations are managed correctly. This can be done by carefully defining what the overarching goal of the project is from the onset. Now, when we think about the business purpose of the project and how technology will serve it, we always need to consider stakeholder needs right from the beginning. So it should be rather easy then, if that's done correctly from the onset, to manage stakeholder expectations and keep communication lines open throughout the life of the project. The project management process begins with initiation of the project, where we identify stakeholders and needs and how the solution will serve business goals. Next, in the planning phase, we define the scope of what needs to be done. We gather the requirements, including legal and regulatory. What are the inputs and outputs for the project? We think about project scheduling, and we assemble a team of qualified personnel. Next, we execute the project and track it using project management software to ensure that milestones are achieved on time and on budget. This also means that as we're going through the project, that we have an open line of communication to stakeholders, progress updates in other words. Next, monitoring. And again, this means that we need to be constantly tracking how the project is doing, making sure that milestones are met, and also keeping track of accumulating costs and also risks that might change throughout the lifetime of the project depending on the complexity of it. Finally, in closing, we have to generate reports. Documentation should be kept up to date throughout the entire project management process, and that will lend itself nicely to facilitating the creation of reports related to the project at the end of the project, also generating lessons learned. That way, we have a set of items that could be used in future projects that will facilitate that project management. When we talk about secure coding, we're talking about adhering to a series of best practices used when developing software solutions. So security needs to be a part of each SDLC phase, where SDLC refers to the software development life cycle. We need to think about security at all times and not just at the end, because if we discover at the end of a project that, oops, we need to remediate some security vulnerabilities, that's going to be very time consuming and very expensive compared to if we had simply thought about security from the onset of the project. So we need to have a clear definition right from the beginning of what the security requirements are. That means we need to think about how this solution will address a business need. We need to think about the technology that we're going to be using to do that. We also need to think about inputs for the software and resultant outputs, and perhaps any laws, regulations, or security standards that we need to adhere to. Secure coding includes things like peer review, having another set of developer eyes reviewing code, looking for problems that might not be clearly visible to the author of that code. Input validation is crucial. Whenever your application is going to take any type of input from a user, that needs to be treated as being a potential attack vector. And we don't know necessarily if we should expect benign data as developed by the developer, so we know that they expect proper data to be fed into the app, or if a malicious user is going to try to feed malicious code into the application, or even randomized data the app doesn't expect, which could cause an app to crash. So we need strong input validation practices. An example of this would be to ensure that in a field on a web form, we aren't receiving any executable code, whether it's a SQL statement or JavaScript. If that field is only supposed to accept something like a customer name, then it should be validated to ensure it does only contain that type of information. Now, modern development frameworks will do a lot of this for you automatically. We need to make sure then that we follow a series of best practices related to securing development of applications, particularly web applications. That's exactly what the OWASP Top 10 does. It identifies the top 10 security threats related to web application development. There are other resources that we can refer to also, like the SANS Institute and the Center for Internet Security, which all provide security best practices when it comes to application development. Secure coding also includes continuous integration and delivery, or CI and CD. So what this means then is that developers would check out segments of code that need changes, or if they're going to be building segments of code, they then check them in when they're complete. After code segments are checked in and you need a centralized solution or repository of code that will do this, then you might have triggers that automatically test that code, whether it's brand new code or changed code, to make sure it adheres to security practices and perhaps to make sure that it is functional and doesn't introduce new problems. As a developer, you would need to be wary of third-party code that you might be using, whether it's an existing plugin you're going to be using in a client-side web browser to be used with an application, or calling upon third-party code libraries, or even simple code segments written by other developers. And it's important that there be a standardized process where third-party code is reviewed before it is accepted and used. And as an IS auditor, these are the types of things that need to be looked at. Then there is code analysis tools. Aside from peer review, there are automated tools that can look for problems. Tools such as Find Bugs, or on the Android platform, AndroWarn. Then, of course, there is software developer security awareness and training. There needs to be periodic training provided to developers to ensure that they know the latest secure coding techniques and are aware of the latest threats. Much as a product manufactured in a factory is then tested to make sure it works as designed, so too do we have the same type of requirement for software testing. This is called quality assurance, or QA. We also need to make sure that the application solution is secure. Now that means different things to different organizations that might have to comply with different laws and different regulations. With software testing, we have static code analysis. What this means is taking a look at the software code without it actually executing. So in other words, doing a code review. Now that is in comparison to runtime testing, which is called dynamic testing, which means that we are testing the code as it is executing to make sure that it runs correctly and, for example, does not disclose sensitive information that should be kept private. At the same time, with runtime testing, we can also determine what our security baselines are that we're testing against, as well as performance baselines. So we know what is normal for security and performance, which easily allows us then to identify anomalies during the dynamic testing. Then we have to think about the testing environment. Are we going to configure some kind of a sandbox environment that is designed solely for testing? Often that is done through network and host virtualization, whether you are using a solution on premises or in the cloud. In the cloud, it's very quick and easy to spin up a virtual cloud network and some virtual machines and databases, whatever's required to test the solution, and then to deprovision it when it's no longer needed to save on costs. We then have to think about tools that will be required for testing. For instance, you might need to use a fuzzing tool to test an application's behavior when it receives unanticipated randomized data. So this way we can be assured that the application doesn't disclose sensitive information, that it is stable, and that it doesn't crash, for example. Software testing can also include a web application vulnerability scan. So we aren't necessarily testing the actual code itself, but we're testing the security of the overall solution. And that can be done manually or through the use of automated tools that use databases of known vulnerabilities and compare that against scanned hosts running applications. So that means that our solution then might check for misconfigurations, so maybe using simple passwords as opposed to complex passwords. It might check to see if directory traversal attacks are allowed, where an attacker can go back in the file system beyond what is designed to be allowed by the web application developer and the web server administrator. If SQL injection attacks are possible, where malicious users can inject SQL commands and pass that to a backend database, which can cause that database to reveal sensitive information that it shouldn't. Now, this can be addressed using input validation techniques. There might also be a check for things like remote command execution. to ensure, for instance, that developers can't send specially crafted packets to a server that might provide elevated privileges that will allow command execution on the remote host. So software testing then is going to be important as part of an IS audit, whether we are testing customized built solutions or off-the-shelf commercial software solutions, to ensure that they comply with business needs and legal and regulatory requirements. There are times when the scope of an IS audit will include taking a look at software development processes. And as such, it's important to understand the variety of different types of testing, including unit testing. Unit testing essentially really allows us to check that the code that is written does what it should do and that it does it securely. So we're talking then about evaluating code segments. Now you might wonder, what exactly is a code segment? It could be a specific subroutine written by a developer. It could be a code module. It could be an object class, or even just a method of an object or a property of an object. It could even be a component such as a web browser plugin. Either way, unit testing allows us to ensure that the code is written correctly and also in accordance with secure coding practices. Now, unit testing is related to other types of testing. We know that unit testing allows us to test essentially each individual chunk of code. However, it's also related to integration testing. What this means is that we are testing multiple units working together. So we perform individual unit testing, then integration testing looks at the behavior of those units interacting with one another. That also leads into regression testing. Regression testing means that we want to take a look at the integration of different units, or even fixes made to them if problems were discovered, to make sure that it doesn't cause problems or doesn't break any other software components. So in other words, if we've integrated 5 units together and each individual unit testing was fine, and the integration testing might not be fine, it might introduce a problem with the interaction of those different code segments. And that's where regression testing kicks in to make sure that integrating all of these units together or introducing changed code hasn't broken anything else. With unit testing, we want to make sure that there are no dependencies on other external code components, because we're talking about self-contained units of code, where the testing is actually performed by the software developer, whether it's done manually or whether it's using automated tools such as RSpec. RSpec is a tool that you would use if you wanted to automate unit testing for apps written in Ruby. Regression testing is a type of software testing that gets triggered either by code changes or by integrating code segments together. In other words, individual unit tests that work separately, bringing them together to see if problems are introduced. Regression testing can be automatic or it can be manual. Either way, what we're looking at doing with regression testing is identifying whether or not changes means perhaps software updates or fixes, or the integration of components together, have introduced new problems that didn't exist previously with each individual or independent component. So we're talking about looking for unwanted side effects. Regression testing involves running tests more than once. It means that we've got tests run against each code segment or each unit, that's unit testing, then making sure that those units work well together, that's integration testing, and then of course regression testing would follow that. Now, selective testing is important. We need to prioritize the most important or critical software components or features, such as items that users will be most impacted by. The reason that this prioritization is critical is because every time a code change is introduced, it's just not feasible to retest everything in the entire piece of software to make sure that everything works perfectly and there's not been a problem introduced. And that's why sometimes we end up with bugs in software. While we have regression testing taking place, it's important that any related code be locked so that it prevents code changes by other developers during the testing phase. And after regression testing has identified that we have no new introduced problems, as code changes come in the future, or as new code segments are developed, so unit testing would be involved, and then the integration testing, bringing that unit into the overall software solution, means that regression testing would have to occur once again. Another type of testing technique is acceptance testing. This allows us to determine whether or not the solution behavior aligns with the original design requirements. Are the user needs addressed? And are the requirements implemented correctly? Acceptance testing means that we want to make sure that we are compliant with laws and regulations that affect the organization and ultimately will affect how applications are built and how they are used. We also want to make sure that we are compliant with any contractual obligations that might require, for example, adherence to security best practices. We need to ensure that the application performs well. Now, this means establishing a baseline of normal activity so that we can easily identify when the application is no longer performing correctly. You might also want to take into account load and stress testing, separate types of tests, for the application to ensure it behaves in a reasonable way at peak workload levels. Then we need to consider SME testing, subject matter expert testing, where users, for example, that might actually be affected by or directly interact with the software solution can test it themselves to make sure that it works as expected and that design requirements are met. So really, acceptance testing can serve as a final type of verification that we've got a technology-based solution that meets business needs. Now, we can run acceptance testing manually, or we can use automated tools like Cucumber or Selenium. So the automated acceptance testing process would look like this. We would have a configured solution that would, for example, navigate a custom web application that was developed. Now, the automated testing tool would then interact as users would with the application. That would mean following links that users might click on, clicking buttons, filling in web forms and submitting them to perhaps a back-end database. And also, the next thing that would happen is all activity from the beginning is recorded in a specific file format, whether it's a text file or whether it's written to a database or an XML file. Now, all the activity needs to be recorded so that we can look at the test results. So, for example, if our automated testing solution filled in a web form and submitted it to the backend database, did that succeed, or was there a failure of some kind when a certain type of data was input in a field? Now, the other interesting thing about these automated tools for testing is that we can feed specific types of parameters into the testing initially, such as specific credentials we want to use, in this case, when connecting to a web application. Because you might find that if you test, for example, a web app with administrative type of credentials, it works fine. But when you test it with standard user credentials, maybe that's where problems would show up. And so this is very important. Now, in the case of testing a web application, which is a very common method these days, bear in mind that often that comes in the form of a web browser plugin that actually does the monitoring and recording to a file. And tools like Selenium do just that. It's just a web browser plugin that is used for performing testing and recording it to a file. The purpose of integration testing is to ensure that all components of a software solution interact together properly. Now, as compared with unit testing, which tests the individual software components independently of one another, integration testing brings all of those together. So really, you could kind of think of it as grouping a bunch of unit tests together to ensure that the interactions work correctly. So imagine, for example, that we're building a web application that needs to periodically talk to a specified database on another host. Well, we might have different code segments or units to do that. We have some code units that control the front-end web application, but there might be one code segment that controls the connectivity to that back-end database on another host. And so while we might test the individual units together, ultimately with integration testing, we want to make sure, in our example, that our web app functions properly, input validation occurs, everything is stable, performs well, and that it also successfully makes a connection to the back-end database. And we want to make sure that all this happens securely, of course. So integration testing then is more encompassing than individual unit testing because it groups unit tests together. With integration testing, the first thing we have to consider is gathering the documentation from each individual unit, and then also, if it exists, gathering documentation for how various units or code segments should interact with one another. That could also mean looking at API documentation if we're going to be making calls between these different code segments. So this means that our integration tests can only occur after successful individual unit testing is completed. Integration testing is normally performed by developers that are a testing team, so not end users, where user acceptance training, for example, would be something that a user might test if we're doing it manually, as opposed to using automated tools. Integration testing is performed at the developer level. Often, automation is used. Instead of using manual techniques to test all of these items, we can configure inputs for automated testing tools such as credentials, or such as which units need to be tested in conjunction with one another, configure output file format or report formats, and then essentially let the tests run in an automated fashion. The great thing about this is if we're using an automated tool to do this, when we receive new code segments or code changes, we could trigger the running of these tests automatically, which in turn, upon successful testing, could automate the deployment of the solution or the update. It's one thing to have run tests against an application to make sure it meets design requirements, to make sure it's functional and secure, but it needs to perform well. So performance testing is important so that we can simulate realistic conditions to identify what is normal performance. Now, this will vary from one organization to the next if we've got the same software solution that will be used in different companies. One type of this performance testing is load testing. This allows us to determine the maximum amount of data that can be handled by an application at a time. That could include being transmitted within a certain time frame to a server, or the maximum amount of data that might be allowed to be input into a web form field. We also, through load testing, can determine the maximum number of concurrent users that is allowed while the application still performs well. So we can take a look at performance during peak workloads that we anticipate the solution to be used with. So that would mean looking at not only the application, but also the underlying supporting infrastructure like storage, or if we've got a front-end web app, we might want to test the performance of the database server if it is a separate host also. We can also take a look at historical peak workload data to get a sense of how applications performed in the past, even previous versions of applications, bearing in mind that we might have peak workloads that might be seasonal. For example, if it's an e-commerce site, it's probably busier during the holiday shopping season than it would otherwise be online. The other thing to consider is the fact that if performance is not good of an application, let's say a web application that's publicly accessible, people tend to wait a moment or two when a page is loading. But if it doesn't load quickly and yet other pages do, so it's not the user internet connection, they're going to forego your site and go to a different one. And so this is one reason why performance testing is so absolutely crucial, especially when it's public facing. A stress test is a little bit different because what we're doing with this is really trying to push beyond the limits of the application to determine its reliability. So we're looking at load conditions way beyond normal activity. So we're trying to break it. What is the breaking point of the solution, whether it's the amount of network traffic or the amount of data it can receive in one transmission or within a certain point of time, or the maximum number of users where the solution breaks as opposed to performing well. So this allows us then to identify what we should do to configure high availability. What if we have a problem with the solution where it no longer responds? Maybe we would use a load balancing and clustering solution where other hosts can pick up the slack. We also need to consider alternative solutions when required. For example, this might require us to replicate a database to different areas so that if we've got a failure of a database server within a specific geographical location, the data has been replicated to another geographical region which can pick up the slack in that case. Fuzzing is a technique used to test applications. This happens by feeding an application unexpected data, and then of course observing how the app behaves after having been fed that data. The idea is we can determine the security and the stability posture of an app by fuzzing. Fuzzing means we're using an automated testing tool and then feeding fuzz data to an application. Now you might wonder, what is fuzz data exactly? Well, the definition varies. Generally speaking, we're talking about randomized data. However, most automated fuzzing tools will allow you to specify details about what type of ranges you want for fuzz data to be fed to the application. And it could even be tied specifically to expected data inputs that an app might require, things like fields on a web form. It could also include malformed packets where you can determine the contents in the packet payload or even the packet headers that is sent to an application. Fuzzing means supplying incorrect data types. It can also mean sending data to an application whereby we are writing beyond defined memory boundaries. In other words, we are trying to instigate a buffer overflow. And this is exactly how the Heartbleed bug related to the OpenSSL package worked years ago, whereby if we fed data to the web application, so over at OpenSSL, and if we fed data that was supposed to be repeated back, we could ask for more data in memory than what we were asking for. In other words, if we asked the application through OpenSSL to repeat back the word dog, we could do that, but then tell it to return 500 characters. So we would get an extra 497 characters beyond that boundary in memory where the word dog might reside. And so that is a problem. That's one of the things that can be uncovered with fuzz testing. Fuzzing can also include sending large volumes of data in a small amount of time, and of course, submitting malformed URLs. So fuzz testing tools are many. There are some free open source tools, there are some enterprise class commercial tools that you pay for, but in the end, they all do the same thing. They allow you to feed unanticipated data to an app and then to observe its behavior. Sometimes the scope of an IS audit will involve continuous integration and delivery, otherwise called CI/CD. This is related to software code changes. So essentially, CI/CD is a type of DevOps control. DevOps essentially combines software development with standard IT administration, with the goal being to efficiently deliver software in a timely manner while aligning with business objectives. So we're really talking about software changes and the rapid deployment of those changes. With continuous integration, developers make code changes that are then merged into the main code branch. Now, in order to do this, developers need to use a specialized tool to make this happen, whether it's a team development suite or some kind of centralized web-based or cloud-based repository where developers can take a main code branch, make modifications, and then merge it back in. So the idea is that this can happen immediately when code changes are committed, or we can synchronize a copied repository that is very commonly done with developers that work locally with code, make code changes, commit those changes, and then synchronize that with an online copy of that same code repository. Now, with the time constraints that are always in place when working in IT. Things can never be done quickly enough, it seems. It's important to understand that automation in the form of testing code changes is absolutely crucial. And when we're talking about code changes, or even sometimes adding new code, we're looking at really performing perhaps unit testing on that segment of code, and then perhaps integration testing and even regression testing to make sure that our changes didn't introduce new problems or bugs. Continuous delivery of the solution means that software changes can be made available quickly, whereas continuous deployment means that changes are made available. So there's a little bit of a difference between continuous delivery and continuous deployment. Delivery means the changes are available. Deployment means the changes are available and applied. The other thing to consider is after successful testing is when the automated delivery would take place. So we want to make sure we've got automation for testing, and in some cases automation for sending out these changes to code bases. The benefit is that automating these tasks can result in the more efficient delivery of software solutions in a cost-efficient manner. In a cloud computing environment, you can use a template to deploy infrastructure in the cloud, where infrastructure could be as simple as a single virtual machine, or it could be a collection of virtual machines, also a web application, a database server, a virtual network, cloud storage. The idea is using the command line or GUI tools, we can use that template to conveniently deploy those resources. And if you're in a testing situation where you keep needing to test the same kind of environment, it's very convenient to automate the creation of that infrastructure in the cloud when you need to test. Then you can deprovision it and then use the template again later when you need to test in the same type of environment. So to get started here in the Azure portal, I'm going to click Create a Resource, and I'm going to search for Template. Then I'll choose Template Deployment, and I will choose Create. Now I can build my own template in the online editor. See the different lines listed here, and I can keep pressing Enter to add as many lines as I need. What we're editing here is a file in JSON format. Now you might also already have one of these that you've used previously stored on your local machine. So notice that you have the option to load a file up at the top. You can also download what you've done here in the editor and save it as a file if you haven't done that previously. However, I'm going to close that. We can also use these common templates, such as deploying a Linux or a Windows virtual machine, a web app, a SQL database. We can even refer to templates used to deploy Azure resources in the cloud from a GitHub repository. So here in this example, I'm just going to do something simple. I'll choose Create a Linux virtual machine. Now, normally when you deploy a virtual machine in the Azure portal, there are many more questions than just these ones that you have to deal with. So this template really determines what I see here when I use the GUI to deploy the template. So I've got to choose a resource group to deploy this virtual machine into. And I'm going to tell it, for example, that I want to use password authentication. And I'll fill in a bin username and a password and a lowercase DNS label prefix. Once I've done that, I'll be able to actually deploy this resource. Now, all of this could have been automated in the template. It doesn't have to be set up as parameters as we see here. Now, once I've filled in those values, I'm just going to scroll down and agree to the terms and conditions, and I'll click Purchase. Right now, it's going to do a validation to make sure I've supplied the correct type of information, such as not using incorrect characters in the name of something, characters that aren't allowed, like uppercase letters. So we can now see the deployment is in progress. We can see that it's currently happening, and once it's completed, we'll get a notification here that tells us the deployment succeeded. And if I go back to the notification area in the upper right of the screen, I can see, if I scroll all the way up now, that our deployment succeeded from our template to a specific resource group. So if I click Go to Resource Group, we'll see that we've got our Ubuntu virtual machine that successfully was deployed from our template. And if I actually click on that virtual machine to open up its properties, we can see the DNS name includes our prefix that we specified when we used the template. Here it's Linux 1. There are times when an organization will have to consider migrating systems to a different environment, as well as migrating data to a different environment. Migration means that we are moving a system or data between dissimilar systems. Conversion can sometimes be required, whereby what we're really doing is transforming data from one format to another, where the target data format is designed so that consumption can occur in the target system. Now, this is common with cloud adoption as well as with company mergers, where we've got dissimilar systems, maybe dissimilar data formats on both sides of the equation, and we want to migrate systems and data from one organization to the other, or from on-premises into the cloud. And when it comes to cloud adoption, we need to take great care, because really that's a form of outsourcing. And when you're outsourcing to a degree, you are transferring risk to the third party, and you're also putting trust in that third party. The other thing to consider with system migration is to determine any suitable replacements. So for example, if we are adopting the cloud, we might want to look at moving systems or data to the cloud. The first thing to consider is, what are suitable cloud replacements? So let's take storage, for example. We might have on-premises storage through an Iscsi storage area network. Well, what can we do in the cloud computing environment? Depending on whether it's a public cloud provider and which offerings they have, and the service level agreements will determine if it's a good fit for our needs or not. We also need to determine if the cloud provider offers cloud readiness tools. Now, this is important because using cloud readiness tools, you can essentially run an assessment based on your on-premises environment and let the assessment tool make recommendations for the mapped service in the cloud that would be most appropriate. And often this requires downloading of software agents that will run on servers on-premises. So service level agreements in the cloud computing environment exist for each separate cloud computing service. So running storage in the cloud versus virtual machines versus databases versus developer message queues. And so it's important that we are well versed in service level agreements to make sure that the solution in the cloud still aligns with business requirements that it might have when we had the equivalent running on premises. Often when we look at migrating to the cloud, we are running systems in parallel. That means that often these migrations can't happen overnight. And so we'll have on-premises systems working for a while as we start migrating equivalences in the cloud. And what that also means is we might have to enable synchronization or replication between the on-premises and cloud-based data sets until we decide to cut the cord and go with everything that's migrated in the cloud. Now, an IS audit can sometimes occur at the time that this type of migration is occurring, or it could be a company merger. Data conversion is an important aspect to consider as well, because we have to take into account any data privacy laws and regulations that might apply. For example, as we migrate data from on-premises into the public cloud over an internet connection, we might need to set up a VPN tunnel first so that everything that we transmit is encrypted. Now, we also have the option of data masking, where we can hide sensitive data like credit card numbers. Often this is something that's done as a graphical user interface or as a screen type of security feature. Then we have to configure whether or not we want to filter out unnecessary data. Do we want to migrate an entire large data set, for instance, from on-premises into the cloud, or only filter it out for data that we want to go into the cloud, which may not be the entire data set? The other consideration is data validation, making sure that data, for example, falls within acceptable ranges. So we might only want, for example, customer sales records that fall between $0 and $10,000 to be migrated to another cloud solution. Also, we should consider file formats. So if we are moving files, migrating files from on-premises into the cloud, for example, we have to think about file formats. So while we might have a system on premises that can work with XML files, does the equivalent in the cloud support that same file type? Maybe not. Maybe it supports zip files or PDF or text files. So this is going to be an important aspect. So is data type transformation. Data types include things like Boolean values, true or false values, numeric values, of which there are many types, date and time values, string values, and so on. And so we might have a string data type supported by our on-premises system, but a system that we are going to be using in the cloud that must deal with that data might not support that specific exact data type. So for example, it might support an array of characters in a different system as opposed to just a string data type. So we have to think about this mapping. Some cloud providers will give you the ability to import data and essentially make migration tables to map data types from on-premises into the cloud. So this needs to be done in accordance with laws and regulations to make sure that data is kept private. Most public cloud providers will provide tools that allow you to assess your on-premises infrastructure or specific IT systems on-premises to determine their cloud suitability. In other words, what could we use in the cloud that is the functional equivalent of what is detected on-premises? And in this focal point, we're going to be looking at SQL databases. So as I scroll down here on the web page where I've searched for what's called the Microsoft Data Migration Assistant, I've got the ability to download this tool. This is a tool that I will download and install so that it can properly assess my on-premises SQL environment and make suggestions as to what I might need to consider before migrating that data into the cloud. So I'm going to go ahead and download this. Okay, so I've gone through and installed the Data Migration Assistant. So here on my server where I've installed that tool, I will launch it from the Start menu. Now what I need to do when I start the Data Migration Assistant is create a new project by clicking the plus sign in the left-hand navigator. And from there I can determine if I want to do an assessment, which is what I want to do, or actually carry out a migration from on-premises into the Azure cloud. So I'll leave it on assessment and I will call this Project 1. Now the source server type from the drop-down list, I will leave it at SQL Server. It's the only choice I have. And for the target, I'll leave it as Azure SQL Database. I want to do an assessment to see if my on-premises SQL Server is suited to be migrated to Azure SQL Database. So I'm going to go ahead and click Create to create the project. So the next thing I'm going to do is click Next. I've got to specify a source. Where is my on-premises SQL Server? So I'm going to go ahead and specify the name of that host, and I'll leave it on Windows Authentication, and I will click on Connect to make a connection. Now once I've authenticated successfully to that on-premises SQL source, then I have to determine which database on the server, or databases, I'm interested in assessing. So here I've got my server. I can turn the check mark on there, and it will check all of these databases. However, in this case, perhaps I'll just choose one database as an example, and I'll click Add. So here we can keep adding sources or remove them if we've mistakenly added them as part of the assessment. But here I'm ready to go, so I'm going to go ahead and click Start Assessment in the bottom right. And we can see it's currently working. When the assessment is complete, you'll be placed on the Review Results part of the wizard. And here I can see on the left that I've got unsupported features such as cross-database references, which on the right it tells me is not supported in Azure SQL Database. But the good news about this assessment tool is it will give me a recommendation on what I can do to remedy that showstopper from migrating my on-premises SQL Database into the Azure cloud. So as we go through, we can see all of the specific unsupported features along with the impact and, again, recommendations on what we need to do if we want to complete the migration into Microsoft Azure. In this exercise, the first thing you will do is list 3 common secure coding practices. Next, you will explain the relationship between unit testing and regression testing. Next, you'll describe the purpose of fuzzing, and finally, you'll provide examples of load testing. Pause the video so you have time to think about each of these 4 items, and then come back to view the solutions. One example of secure coding is peer review. Having another set of eyes look over the logic of code can sometimes be very helpful in pointing out code deficiencies. Another example would be input validation, whereby we essentially sanitize what is supplied by a user as input, which should always be treated with suspicion to make sure that the application is not being fed malicious code or something that can cause the application to crash. We can also limit the use of third-party code. By doing so, we aren't transferring as much risk and responsibility into a third party that we have to trust to run their code segments. Unit testing means that we are testing small chunks of code. So if a developer has built a new method for an object class, then maybe just testing the code for that method would be considered unit testing, or testing a specific procedure in a function library that will be used over and over. Regression testing is a little bit different, because what we're doing with regression testing is testing for unwanted negative effects after we've applied a change to code. So regression testing is different than unit testing because we aren't actually testing the code itself. That's unit testing. Instead, what we're doing is looking at other adverse effects to other areas of an application that might be affected. Fuzzing allows us to observe application behavior when we feed the application randomized data or, for example, invalid data inputs that the application would not expect, or malformed packets. These are packets that are sent to an application that it doesn't expect that might have unexpected values in packet header fields or in the packet payload. The purpose of fuzzing is to essentially test our application by feeding it crazy data to make sure the application doesn't disclose any sensitive information, and also to make sure that the application still performs well and doesn't crash. Load testing allows us to determine for an application characteristics such as the maximum amount of data that the application can handle within a specific time frame, the maximum number of concurrent users that can be connected, the expected baseline of performance during peak workloads. Now, by performing load testing, we learn a lot about the application and what it can handle. And by establishing a baseline for performance, we can then determine what's abnormal to see if the application is being stressed during extremely high peak loads. IS audits can sometimes include testing as part of the audit process or as a recommendation that results from audit findings. Bear in mind that with auditing, the objective is part of the process, and the objective might be to determine how secure custom code that results in a custom line of business application is, or how secure some kind of an implementation, such as of a VPN solution is. And as a result, the scope is part of the audit process too. So will we be looking at this source code or this VPN solution within a specific location in the organization, or all of the locations? So there are a number of different types of tests that can be conducted then to test these types of things, to identify weaknesses. The first of which is white box testing. This one is sometimes called transparent testing, and what it means is that the testing team has a lot of information about what they are testing. For example, they would have implementation details about the solution, whether it's source code that's been compiled and results in a custom line of business app, or details about how a multi-tiered web application has been configured, or how a VPN environment has been configured. So this is known to the testing team. They have this information. They would also have access to any related documentation. So in other words, white box testing means that the testers know a lot about the environment before they even begin testing it for security weaknesses. So sometimes this can be helpful because it can illustrate what might happen in the event of collusion between an external actor and someone essentially on the inside. Black box testing, however, is on the opposite end of the spectrum. Sometimes this is called behavioral testing. Now, unlike white box testing, where the testing team essentially knows everything before they even begin testing, the opposite is true with black box testing. In other words, there are no details that are known to the testing team. It's all unknown. So, implementation details, unknown. Documentation, unavailable. Security controls that may be in place, who knows? The team doesn't know this. And so the idea with black box testing is that it would simulate an external attack where an external threat actor might not have any knowledge about anything other than perhaps the result of a network scan and seeing that, for instance, a web server is running. So it's used to identify vulnerabilities, and in turn, those vulnerabilities are then addressed to make sure that security controls meet control objectives. It's all about managing risk. Gray box testing, as you might imagine, sits somewhere between white and black box testing. It means that the testing team has a partial understanding of things like the details about how something was implemented or configured. They might have a sense of any security controls that are in place. They might know what's in place, but perhaps not exactly how it's been configured. So really the idea here is that we have a test that's being conducted essentially from the point of view of perhaps a casual user in the organization that doesn't have access to all the details, or an external threat actor that might have some information about what's been configured, such as source code or an application. The idea is to uncover flaws. And so when it comes to things like source code, with a white box test, the testing team has full access to the source code. But in the case of a gray box test, they wouldn't have access to that same code. And so, as a result, it's important to consider that all of these different types of tests offer their own value. Because with a white box test, if the testers have access to the source code, it might allow them to uncover flaws that are related to security or stability that might have gone unnoticed otherwise with a black box or a gray box test where the source code was not made available. While vulnerability scanning can be a part of an IS audit, it can also be the result of IS audit findings if vulnerability scans aren't run periodically. The purpose of a vulnerability scan is to identify weaknesses at the network level, at the individual host level, and within a host even within a specific application, such as a web app. Vulnerability scanning can be considered passive scanning. The reason we say this is because vulnerability scanning will identify weaknesses but will not actively seek to exploit them to test if they could actually be successful in executing a security breach of some kind. The vulnerability scanning process starts with scanning the network. Now remember that vulnerability scanning might be conducted by legitimate users as well as malicious users. Either way, access to the network would be required in order to scan the network. After scanning the network, network devices are identified, and from there, a malicious user, for example, might target a machine that appears to be running a web server, and so that device would be further scanned looking to see what else is running. Afterwards, a vulnerability database is then used to check for weaknesses on that specific network device. So this can be done both by legitimate users internally as a periodic preventative measure to identify weaknesses and then address them, but also by malicious users looking for weaknesses to exploit. So when you're going to run a vulnerability scan, the first thing to consider is what's normal. Now you'll know that after you've run a number of vulnerability scans to determine what should be on the network and what should be running on hosts on the network. So we need to establish a baseline of what's normal. Now it's also important to keep the vulnerabilities database up to date. Most vulnerability scanning tools will have a database of known things to check for on a variety of different platforms like Mac OS, as well as Windows and Linux, and the Android smartphone operating system, iOS for Apple mobile devices, and so on. So the vulnerabilities database needs to be kept up to date. We then need to think about the targets. Which device or devices are we going to scan looking for vulnerabilities? Most vulnerability scanning tools will also have a credentialing option, which means that you can specify one or more different sets of credentials that will be used against remote hosts that are detected on the network so that it could actually make an authenticated connection and find out more about vulnerabilities on that device. Now, a non-credentialed scan is equally as valuable because that might mimic more what an external attacker might be able to learn about a machine in terms of vulnerabilities. So both are valid. Then there's the reporting. Over time, what we're really looking for with vulnerability scanning, besides the obvious, which is weaknesses that need to be addressed, are also changes over time. Now, threats change over time, which is why we need to run vulnerability scans on a recurring periodic basis. Now, that time interval will vary from one organization to the next, and part of an IS audit would be to determine if in fact vulnerability scanning is being performed periodically, and if not, what that frequency should be. Nessus is a vulnerability scanner. And so what that means is besides just identifying hosts on the network and open ports on those hosts, it can also dig a little bit deeper looking for vulnerabilities within the operating system and its configuration, and even apps and their configurations. I've already downloaded and installed the free version of Nessus, which shows up as a web app on the machine where you install it. And here on that machine, I've gone into my browser and I'm connected to localhost port 8834. The first time you run this, you'll be asked to specify a username and a password, which I've already done. So I'm just going to go ahead and enter those credentials. That puts me in the My Scans folder. I've never done this before, so there's nothing to look at here. But previously run scans, if you've done them, will show up here, and you can go back and look at them to view vulnerabilities. I'm going to click Create a New Scan. That gives me a list of templates from which I can base my scan settings on. So I can run an advanced scan or even just a host discovery scan to discover devices on the network and open ports, or even looking for instances of malware like WannaCry or Spectre and Meltdown, or even running a web application vulnerability test. So I'm just going to go back up here and run an advanced scan. I'm going to give this a name, and maybe I'll put in the date as well. I can also specify the target that I want to go ahead and scan. So for example, I'm going to start at 192.168.0.1 through to 192.168.0.10. So that's what I'm going to do. Now I can also specify credentials that I want to use to scan specific types of devices on the network. So if I click Windows, then I can specify password authentication details, such as a username and a password that might be used to log in to remote hosts. So we can fill in all of those types of details. I'll just scroll up a little bit here. Once I've done that and I'm happy with my configuration, I can click Save. Now we can see that the scan is listed here and the schedule is on demand. Now at any point in time, I can click on that to view the details of the scan and then configure it accordingly. Now if I want to schedule it to run on a periodic basis, I could go ahead and enable the schedule instead of running this just once. And we all know that part of an IS audit should take a look at the periodic assessment of things. In this case, the security posture of devices on the network in terms of new vulnerabilities that might have been discovered that weren't there before. They need to be mitigated. However, I'm going to cancel out of that, and I'm going to go back to my scans, where what I can do is select the scan from the list by putting a check mark in the box, and then we can launch the scan. We can run it. I'm going to go ahead and click that. Now, depending on the type of scan will determine how long it takes to run. So, for example, running an advanced scan like I am here, as opposed to just a basic host scan, is going to take longer. After our Nessus vulnerability scan is completed, we'll see that we've got a timestamp on when that occurred. And so I can then click on the name of the scan to open it up. What we're looking for here are vulnerabilities, because this is a vulnerability scanner. In the legend, we can see that if we have any bright red, that would indicate we've got a critical vulnerability. Luckily here for us, it's only 1% of the overall scan. Then we've got high vulnerabilities, medium, low, and informational. So I can see here in the scan results, IP addresses listed down the left column under host. And of course, one of them here, 192.168.0.6, really gets our attention because it's got a red or critical vulnerability. And so I'm going to go ahead and click right on that to find out more details about that. So as we scroll down, we can see a list of all of the vulnerabilities on this host, of which, according to the listing here, there are 22. So we can see over here the IP address, the MAC address, the OS. Here it looks like some kind of a Epson stylus printer, or it could be a Linksys wireless access point or an Oracle integrated lights out manager tool. But as we go further down and look at all of the vulnerabilities that are listed here, we can start clicking on that vulnerability to identify details. So for example, here there's a medium vulnerability. IP forwarding is enabled on this device, and an attacker could exploit this, and so on and so forth. So when we go back and look at all of our scans, we can then quickly see visually where we might have issues. As I look further down the scan, for example, host 192.168.0.10, there are no issues. So we've got one informational item, but informational is just that. It's not a big problem. So we can read about the details related to that issue, but we need to be focusing on where we have medium, high, and critical-based issues that we need to address. So here, for example, on a laptop out on the network, it looks like we've got SSL version 2 and 3 enabled. SSL, Secure Sockets Layer, was previously used to secure network communications, such as for HTTPS-enabled websites. But the problem is that SSL version 2 and 3 have known vulnerabilities. Really, they are deprecated in favor of newer versions of TLS, Transport Layer Security. So again, the great thing about running vulnerability scans is that we can see where the weaknesses lie, and we can take steps to mitigate those weaknesses, to mitigate the risk and manage it properly. And again, this is crucial. These types of scans need to be run periodically. Now, depending on what the audit objective is for the IS audit will determine what that means. What's the frequency? Should it be done weekly, monthly, quarterly, annually? You probably don't want to leave this to happen only once a year, because then you're leaving potential vulnerabilities open and unaddressed for a long period of time. Nmap is a free open source network scanning tool. It's not a vulnerability scanner as the Nessus tool is. It doesn't identify weaknesses within the operating system and apps, but what Nmap can do as a network scanner is scan the network for devices and also open ports. The great thing about this is we should be using it periodically, because then we can compare older scans with newer scans to identify what's changed on the network. And sometimes that can be an indication of some kind of a security breach. I've already got scans I've taken using this tool, so I'm going to go to the Tools menu and choose Compare Results, where I've got to specify on the left an A scan, as it's labeled here in the interface, and a B scan, and the output showing me the difference between the two of those network scans will then be shown below. So let me go ahead and choose 2 scans taken previously. Once I've done that, I can see down below the output where we've got some items listed in red, also with a minus sign, as well as items listed highlighted in green with a plus sign, things that have added or been changed on the network versus removed, which is the red or the minus. And as we go down through the output, we'll see, for example, instances where in the first scan, the A scan specified up here in an XML file name, we can see that there was a host with a given IP address and MAC address, and it was up when we performed our first scan. But in the second scan, that same host does not appear. So what we see then is that the host is down. So that is a change that we're identifying by comparing these scan results. So as we go through this, we'll also see whether or not hosts were down in the previous scan. So in this case, it was down. Now it's up and running. And we can also see the state of the ports on that machine, the open ports. And we can even get some details, depending on the type of scan that was performed, perhaps about the operating system. Here it's telling us it's an Android operating system embedded within the firmware in a Sony Android TV. So the great thing about this is we can run these network scans at any point in time, and they should be run periodically, so that we can identify anything that's changed from the previous scan and whether or not that's a good thing or whether it's suspicious. In the field, penetration testing is often simply referred to as pen testing. However, this is not the same as a basic network scan. It's also not even the same as a vulnerability scan, because penetration testing is considered active. What this means is while a vulnerability scan would identify weaknesses but not do anything about them, pen testing, on the other hand, does actively attempt to exploit vulnerabilities to see how far one could go from a testing perspective, to break into a system or to disclose sensitive information or even crash a server. Now, with pen testing, we have to be aware of the rules of engagement. Part of this would be scheduling. We need to make sure that the system and network owners are fully aware of, and that we have the consent of them for the scheduling of when pen testing would occur. Now, in some cases, that might be a point of the pen test. It's the unknown. So there's an agreement between the pen testing team and the system owners that pen testing will occur between a certain date and time range, but we don't know exactly when. Part of the element of surprise. That could be a part of it. The other thing to think about is potential service disruption. Because a pen test is active and it can actively exploit discovered vulnerabilities, that could lead to problems such as servers being frozen and therefore affecting productivity if it's a production environment. The other thing is NDAs, non-disclosure agreements. The result of a pen test might be such that it takes advantage of a discovered vulnerability, and as a result, sensitive information, private customer data, medical records, company trade secrets, that type of thing, is disclosed to the pen testing team. And so a non-disclosure agreement is normally required in terms of signing off on it prior to the commencement of a penetration test. With penetration testing, there is the notion of a red team and a blue team. With a red team, what happens is that they are the team that executes the actual penetration tests using specific tools. Now, those tests are conducted against an entire network or devices on the network, even applications like specific websites running on a server, or even specific databases that might contain sensitive information. Even if a web application is multi-tiered and uses a back-end database, the pen testers might try to circumvent going through the front door, so to speak, and try attacking the database directly. The blue team monitors for security events. The purpose of the blue team is to prevent and stop attacks when they are detected. The idea is that it can educate IT staff within the organization on mitigation strategies and techniques, not to mention things that are missed due to insufficient configuration of monitoring or the lack of poring over logs or setting up log alerts correctly. And so the results of penetration testing then can be fed into the Is Audit engine, so to speak, so that we have a sense of vulnerabilities and whether or not there's a real risk of those vulnerabilities being exploited. And of course, that relates to security controls that are put in place that meet control objectives that protect assets. Kali Linux is a freely available tool. It's a Linux distribution that contains plenty of penetration testing tools, including those that could be used for good purposes or for evil. The thing to watch out for as an IS auditor is the appropriate security controls in place to mitigate or manage the risk of attackers gaining access to a network, whether it's wired or wireless. Because if an attacker can get on a network, they can use these freely available tools to pretty much do anything in terms of sending out network packets on that network. And in this case, we're going to use the hping3 command to essentially forge network traffic and inject it out on the network. Here, I'm going to use the hping3 command in -- flood mode. Now, what I'm doing is sending out a SYN flood type of attack that would be used against a host to try to prevent legitimate traffic from getting to it. So it's essentially a type of denial of service attack. Although, unless you have a lot of hosts doing this, it's probably not going to cause a big problem for the target. Here, I'm also telling it that I want the destination port number to look like it's destined for port 80. The transmission will leave the local interface on this host, named ETH0, and we're targeting this against a poor victim at 192.168.03, where I'm running a Wireshark packet capture currently to capture this network traffic. It's going to run in verbose mode, -V. We already know -S is a SYN flood. --rand -source means I want randomized source IP address and port numbers to show up as we send all of these transmissions, this flood of network traffic that we're injecting on the network. And -e means I want to specify something in the payload of the packet. I want it to say fake data, so we can easily identify it. So let's go ahead and press enter to get this started. Again, knowing that it's being captured on the network with the Wireshark network analyzer running on the host we're targeting in this particular example. Now back on the target or victim host, we can see network traffic being captured. I'm going to go ahead and stop. Now I notice here it looks like we've got a lot of randomized source IP addresses all over the map in a short period of time. That's suspicious. Now if I select that one of those captured packets and if we expand the IP header, here we can see the source and the destination IP. The destination is the victim in this case that we're sending this forged traffic to. And if we look at the TCP header, we've got some randomized source port number, but again, it's targeting port 80. And of course, here in the payload, we can see fake data. This is completely forged network traffic. And this is an important thing to bear in mind as an IS auditor, because security controls that might be in place, such as network intrusion detection systems or network intrusion prevention systems, any type of tool like that, or even running Wireshark, as we are here to capture network traffic, whenever you see something that looks suspicious, well, then it might be because you've got a lot of traffic in a short period of time going to the same host and the same port number. But at the same time, don't trust the source IP addresses and MAC addresses and port numbers, because we know it can be easily forged, including down in the packet payload. OWASP stands for the Open Web Application Security Project. This is an organization that is dedicated to securing web applications. And as a result, besides listing the top 10 vulnerabilities for web apps, the OWASP project also produces a number of very useful tools, one of which is the one that I've downloaded and installed and have launched here, OWASP ZAP. ZAP stands for Z Attack Proxy. Now, this can run in many different modes. You can configure your web browser with the IP address of where this is running to proxy through it to get to an app so we can see all the traffic, or you can simply launch the tool and specify a URL that you want to test. So when I start it up, I'm asked if I want to persist any sessions here. I'm going to choose no and start. Now, what I want to do here is run some kind of a scan. So in order to do that, I can go to Quick Start. And here I can specify whether I want to use standard mode or attack mode to test an application. I'm just going to use standard mode here. I've already filled in the URL. Now, this is a web application under my control that I know is vulnerable. Be careful using some of these tools when you don't have permission on the network or the host to run them. Because if that's the case, you don't have permission, do not run them. But here it's my website, so I know what I'm doing. So I'm going to go ahead and click Attack. Now, what I see down below under the Spider tab is all of the things it's trying to crawl or learn about on the site. It's enumerating all of the available items available through the URL that I provided up above. Now, this will take a few minutes. We can see currently it's at 1%. What we want to do is keep our eye on the alerts window. It's already got some issues here related to vulnerabilities in the web application. We're just going to go ahead and wait until the whole thing is completed before we go back and look at all of the alerts to determine any potential issues. So for example, here we can see there's some kind of application error disclosure. And if we take a look and select that, we can start on the right seeing some details. This page contains an error or warning message that might disclose sensitive information, like the location of a file that produced the unhandled exception. So it's always important then to make sure that the active scan, which is still progressing, finishes before you go back and look at all of the alerts. We've already gone back to look at some of them, but we're going to wait a moment until the active scan is completed at 100% so we can see all of the alerts. So now that the scan has completed, if we go back to the Alerts tab, we can see we've got some new entries, such as cross-site scripting, specifically reflected cross-site scripting vulnerabilities. And as we scroll down on the right, we can read details about that. This web application is also vulnerable to SQL injection attacks that could disclose sensitive information. And so the other information here tells us that certain types of conditions can be passed in to user input fields on this web app to result in sensitive database information being displayed that otherwise shouldn't be. So it's important to run periodic web application vulnerability tests to make sure that any risk associated with those websites being available is managed properly. The Is Audit process deals with things like the audit objective and the audit scope, among other things. And in some cases, that might be related to ensuring that network security controls are put in place, such as limiting access to the network in the first place, or using PKI certificates to secure network services like HTTP web servers, or using network security protocols like IPsec, which is going to be our focal point here. We can use IPsec to secure not only a VPN tunnel by encrypting its traffic, but it could also be used to encrypt standard network traffic of any type, not just HTTP. To get started here on my Windows server, which is configured as a Microsoft Active Directory domain controller, I'm going to go into my Start menu because I need to fire up the Group Policy Management tool, which I'll find down under Windows Administrative Tools. Now you can also run this from a workstation if you've installed the tool. It doesn't have to be run on the server. But when I go into the Group Policy Management tool, under my Active Directory domain, I've got a GPO, a Group Policy Object called Default Domain Policy. Now that could contain a whole bunch of configuration settings that would apply to all users and computers in the domain by default. So I'm going to right-click on that GPO and edit the settings. That opens up the Group Policy Management Editor. So I'm going to go ahead and expand that. And in the left-hand navigator, if I want to get down to the IPsec settings, I'm going to have to go down under Computer Configuration Policies, Windows Settings, and down under Security Settings, and finally, in the left-hand navigator, I can see IP Security Policies on Active Directory. There are 3 default policies here, although you could make your own if you wanted to. We're going to use one here called Server Request Security. So machines affected by this group policy object, the GPO for the default domain policy, will then get this setting whereby when communicating over IP, both ends of the connection will check whether or not IPsec is supported. And if it is, they will use it, hence request security, but it's not required. If I wanted that, then I would choose require security. So back into the request security properties, if I were to go, for example, and select all IP traffic and click edit, under authentication methods, I can see Kerberos is used for the machines to authenticate and trust one another. Now that's implied for Active Directory domain joined computers. Now, if you weren't using Active Directory, maybe you were configuring group policy locally on some workgroup computers, and it looks much like this does, then we would be able to add different authentication methods, such as using PKI certificates or a pre-shared key. But in this case, I'm not really going to change anything. I'm just going to cancel out, and I'm going to right-click on that IPsec policy and assign it. Now, when I choose Assign, under the Policy Assigned column, it now says yes, and there's this tiny green dot which tells me that it's currently turned on. Now, once group policy updates on machines, then it will be in effect, this policy setting. And of course, we could force a group policy update at the command line by running gpupdate/force. So what I've done here is captured some network traffic after the IPsec policy is active on Windows machines in the domain. And the traffic includes, among other things, pinging devices. Now, what I'm going to do is filter this packet capture in Wireshark by typing ESP up in the header bar and pressing enter. ESP stands for Encapsulating Security Payload, and it's a form of IPsec that encrypts the packet contents. And sure enough, we can see a number of packets here that use ESP. This implies that IPsec is enabled, at least between the hosts listed here, between the source and destination IP addresses within this packet capture. What's really cool about this is I can see in the selected packet in the headers, the Ethernet header, so I can see MAC addresses, hardware addresses. But after that, if I go into the IP header, I can see source and destination IP addresses, but what follows after that is simply an ESP header. And I really can't make heads or tails in terms of what type of traffic this is. Is it ping traffic? Is it HTTP traffic? Is it SMB file sharing traffic? Is it FTP? The point is we don't know, and we shouldn't if IPsec is enabled. Because after layer 3 of the OSI model, so that would deal with things like the IP header, after that, layer 4, where we have port numbers and so on, is all encrypted along with the payload. And therefore, we don't even know what type of traffic this is. Now, while this might seem like a great thing 100% of the time, and it is from a confidentiality standpoint, because network data is encrypted, you have to be careful, because if we've got firewalls, layer 4 firewalls that need to look at port numbers, this could be a problem because they can't see the port number the way this traffic is encrypted with IPsec on the network now. So always look at both aspects, pros and cons, of securing something on a network, as in this case using IPsec. Today's IS auditors have to have an awareness of cloud computing technologies and the risks associated with that need to be accounted for, and of course, security controls put in place, including processes, to secure cloud computing environments. Here I'm using the Microsoft Azure Cloud Computing Environment, and I've already gone into the Azure Web Console, the GUI, the portal, and I've gone to the Virtual Machines view on the left. I've got a virtual machine here called WinServe1, and it has a status of running. if I click on the name of that virtual machine to open up its properties, I can see it has a private IP address here of 10.1.1.4, but it does not have a public IP. Now, this is a good standard in the sense that when we deploy virtual machines in a cloud computing environment, unless absolutely necessary, they should not be reachable from the internet. However, what if we need to be able to get into that virtual machine to manage it? Well, the idea is to configure a jump box, and a jump box is a machine that's configured that does allow access from the outside in a very restricted manner. And once we gain access to the jump box from it, it serves as a jumping point or a launching pad from which we can then gain access to other internal hosts. So I'm going to configure a new virtual machine here in the Azure portal, which will serve the role of a jump box. So I'm going to start by clicking Create a Resource. And what we're looking at doing here is creating a virtual machine. In this case, I'm going to choose Windows Server 2016. I'm going to fill in some of the blanks here. I have to specify a resource group, which is a collection of cloud resources that are related, into which I want to deploy this virtual machine. I'm going to call this Windows Jump Box. And I'm going to specify a different region into which I want to deploy it. Now notice here I have a message that says we can't have special characters. So one of the reasons we're getting this message is because we've got some spaces within the virtual machine name. Notice when I remove them, all the checks are passed, so the name is valid now. So the region is the geographical location where we want this virtual machine deployed. So maybe in this case I'm going to choose, let's see, a Canadian location, Canada Central. Down below, I'm going to specify the username and password that will be used for this virtual machine. Once I've filled that in, I'm going to make sure down below that a public inbound port allowance is made for Remote Desktop Protocol, RDP, on port 3389. That'll allow me to remote into the jump box, and then from the jump box, I can then remote further to internal hosts that are not publicly reachable. Okay, so now that we've got that done, I'm going to choose Review and Create. And we can see the validation based on our config settings has passed. So let's actually create this virtual machine in the cloud by clicking the Create button. Now that our Windows Jump Box virtual machine is deployed, we can see that it's got a public IP address, which I'm going to copy to the clipboard using the copy icon. Notice it's also got a private IP address, in this case 10.1.1.8, which is on the same subnet as 10.1.1.4, where our other Windows server exists. So this will be our jump box. We come into it through the public IP, and through its private network connection, we can make a connection to other internal hosts that are not publicly available. So here in the remote desktop connection client, I've popped in the public IP of our jump box. So I'm going to go ahead and click Connect. So I'll go ahead and pop in the credentials I specified upon creation of that virtual machine. And after a moment, it asks me to trust the certificate used to secure the connection. I'll just choose Yes. And then it's going to take us into our virtual machine. Now this is the jump box. Once we get to the desktop, we're going to fire up the remote desktop client on it to make sure we can connect to 10.1.1.4, another internal host that is not publicly visible. Okay, we're at the desktop now, so I'm going to go to the Start menu and run the remote desktop client. Might take a second for it to pop up. There it is, remote desktop connection. And I'm going to go ahead and put in 10.1.1.4. Now immediately, we're being asked for credentials. This is good news. I'm going to go ahead and enter them. And then after a moment, we're brought to the desktop of our other internal server that does not have a public IP address. Sometimes the safest way to determine what kind of risk there is against a certain type of system configured in a certain way is to set up a decoy and then monitor malicious activity against that decoy. That's exactly where honeypots come in. Honeypots mimic a production system or multiple systems on a network, and they use fictitious data that might look real but in fact is not. The idea is that a honeypot is configured to appear vulnerable because it is, but that is by design. By monitoring the techniques used by malicious users, we can learn more about how to mitigate any weaknesses. At the same time, we want to be careful and not use real production data, because think of a honeypot as a sacrificial lamb that eventually will be compromised. So there are pros and cons to honeypots, like there are with most configurations in the IT world. Some of the good things about a honeypot include early incident detection. We can detect that someone will try to break into a web server configured in a certain manner on a decoy system without putting a production system at risk. So we can also learn about malicious user attack patterns, attack vectors, attacker identities in some cases, such as IP addresses from which attacks are being executed, although those can be obfuscated pretty easily through proxy anonymizers. But nonetheless, we can still get that information. Some of the cons would include legal liability. Well, how would that work? Well, just imagine that you've set up a honeypot, but it inadvertently allowed an attacker to compromise that host and get further into the network that was unanticipated. And as a result, they were able to get some sensitive information that they wouldn't have been able to get if the honeypot were not configured in that manner. That could be an issue, and certainly it needs to be considered when you are seriously looking at deploying a honeypot or a honeynet, a network of honeypots. The other thing is, what about if we have a system? Let's say it's a virtual machine running Windows that is set up as a honeypot to look vulnerable on purpose. But then attackers take control of that server and from that server conduct illegal activity. How does that work from a legal liability standpoint? That needs to be considered. Now, certainly we don't pretend to be lawyers, so we would have to consult proper legal counsel to determine how and if this should be done. The other thing is how the honeypot is configured. Honeypots can be configured to look like specific server operating systems, whether it be a certain variant of Linux or Windows. It can be configured so that it looks like certain services are running, like DNS, DHCP, a web server, an FTP server, and so on. We could even have individual files or folders that are made available to look like sensitive data. Now, the HoneyDrive honeypot is a Linux-based virtual appliance that you can run on your network and configure it in a variety of different ways. You can make it look like an SSH honeypot or a vulnerable website honeypot. Also, any honeypot type of tool, such as the HoneyDrive project, will also include monitoring and analysis tools. So you can take a look over time at the activity against that honeypot to determine attack patterns and determine whether or not breaches were successful. Heating, ventilation, and air conditioning, otherwise called HVAC, are an important consideration when it comes to security and the protection of digital assets and business processes. Now, as a result, it often gets overlooked as a vulnerability because a lot of the focus these days seems to be on the IT technological security and data disclosure issues. So while HVAC is required, it's one of those things that can be good but also bad. It can have a negative impact against personnel. For example, imagine that an attacker remotely gains access to the temperature control in a facility and turns it up so high that people are forced to leave the building. So there might be government agency regulations that dictate that after a certain temperature in the summer, where the air conditioning might not be working, personnel have to be sent home. And as a result, that could allow attackers to physically use social engineering skills to perhaps get in the building as cleaners to gain access to systems or data that they might otherwise not be able to while people are there. The other thing is equipment. We want to make sure that the equipment runs at peak optimization levels, and that means making sure we have the proper humidity and temperature. The last thing we want is for things to be too warm, not only for personnel, but also for equipment. When we have too much heat, we have an issue with equipment. It shortens the life of the equipment for starters, but it can also result in a system slowdown or a crash. And a crash, for example, could be considered a denial of service type of attack. The other thing to bear in mind related to heating, ventilation, and air conditioning is IoT devices. These days, HVAC IoT devices can be plugged into a network. Of course, they will be wired to the appropriate systems like temperature and humidity control, and they can be configured remotely, often through a smartphone app. Now, while that's convenient, it also presents a risk. And so it's going to be important, as it is with any type of IoT device then, to always change default settings, to apply updates if the IoT device supports updates. You might want to make sure that when you're going through the procurement process, and this could be part of the scope of an IS audit within an organization, to take a look at whether or not IoT devices support updates in the first place. And if they don't get used. The other thing is to place IoT devices on isolated restricted networks, perhaps that are only accessible through a VPN. So then that way, we want to make sure the isolation takes care of a compromised HVAC IoT device that doesn't have access to anything else on the network. But also, we want to make sure that legitimate access, remote access, is done in a secured manner. And so that could be done through a VPN link to that isolated network where the HVAC IoT device resides. Physical security can be a crucial part of a risk assessment. Just imagine someone that defeats physical security and can actually get into a building after hours, and within that building get into a server room that houses storage arrays and backup tapes. That could be a serious problem. So physical security is important. Now, physical security can come in many forms, as we see here, such as video surveillance systems, locked doors and windows, physical facility security like perimeter fencing and lighting, location security where we can track the location of people or devices, and of course physical security also includes physical security guards. The other thing to bear in mind is that physical devices on the network need to be inventoried. Smartphones, laptops, servers, storage arrays, backup devices, VPN appliances, all of that stuff needs to be inventoried, and we need to have inventoried the details about those devices and their configuration, and the location also needs to be known. Whether that location is recorded manually, such as this is router 642 in building A, floor 2, or whether it's got some kind of RFID tag that can be used for inventorying, or maybe even GPS locator information built into the device. So physical security then means that we can put in place a lot of preventative measures to prevent physical security breaches from succeeding. So imagine for traveling users that we would supply them with laptops and lockdown cables, so that if someone's taking training somewhere with their laptop, they can physically secure it to a heavy piece of furniture as they step away for a moment to go get a coffee or to go to lunch, thus preventing the theft of that device. The other thing to consider in a server room is to lock server room doors. This is absolutely crucial. We don't want malicious actors gaining access to physical equipment, because often when physical access to equipment is available, a lot of security measures can be bypassed. Not all of them, but many of them. In the same way, in a larger data center, we should be looking at locked server room racks, where, for example, in a data center that is used by many different organizations, we might have specific racks with different company equipment, and each one would be locked and accessible only to officers of that company. So it's important that we also run inventory periodically. It's one thing to have inventoried the devices on your network and their configuration a year ago, but a lot can change within a year. So part of an IS audit can make recommendations on how frequent these types of tasks should be performed, how often device inventory should be completed. The other thing to think about is the relationship between physical security and digital security. So for example, we might require that client devices are installed with PKI certificates before allowing physical network access, such as through an IEEE 802.1x Ethernet switch. We should also consider the encryption of data at rest. This one is important because if a storage device is physically stolen, so if someone gets into a server room and can physically steal disks from the server or a storage array, and the contents of those disks are not encrypted and it contains sensitive data, we have a problem. And that's how we often hear about a lot of the data privacy security breaches that we hear about in the media. It's because something wasn't encrypted or wasn't encrypted properly. So this is going to be an important part of it. So we might use something like Microsoft BitLocker or a wide variety of other enterprise-grade encryption tools so that even if someone acquires a disk physically, if they don't have the appropriate decryption key, they can't get into it anyway. What they would be able to do is wipe it and reuse it, but that's okay from a sensitive data disclosure standpoint. The other consideration is an air-gapped network. An air-gapped network is one that does not have a connection to an outside network. So it could be part of a military institution or some kind of law enforcement agency that has very sensitive information systems that should not be accessible to the outside, such as through the internet. And so there is no physical connection, wired or wirelessly, to another network. Now, in some cases, with wireless connectivity, we have to be careful. Who's to say that an attacker or a malicious user on the inside doesn't allow an outside wireless connection? And that's why in some cases, such as with military installations, you might actually have buildings that are perhaps underground and shielded to prevent radio frequencies from entering or leaving the facility. So physical security then is a big deal, but we have to put it in context as it relates to the Is Audit. Drones have absolutely exploded with popularity in recent years. You can't go to the local hobby shop without seeing some collection of drones, both cheap and expensive. Drones are useful, but they've also dropped a lot in price, which increases them as a risk. A drone is essentially a mobile airborne device that's controlled remotely, and as such it could be used for reconnaissance, whether by government agencies, military installations, law enforcement, or even nefarious users. If the drone is equipped with a high-definition camera, then that can be used to scan a facility looking for security weaknesses physically. You might remember back around Christmas time in 2018 hearing in the media about drones that ended up grounding planes at London's Gatwick Airport in the UK. Now the reason is because the drones were in the airport's airspace and presented a serious risk to aircraft. And as a result, that is a problem. So if part of the Is Audit Objective relates to the securing of processes at an airport control tower and surrounding airspace, the processes that support that, then this could be an enormous deal. So we have to think about drones and proximity security. Now, because drones have skyrocketed with popularity, that means that lawmakers around the globe have had to address their usage. And so there are plenty of regulations to determine how they're allowed to be used. The first thing to consider is that a drone is an aircraft. Now, as a result, many different countries and even states, provinces, or jurisdictions will require drone owners to have a drone pilot certificate. The drone device itself will need to be registered. And in many cases, there might be rules that state that the drone must be flown below 122 meters or 400 feet, so it doesn't interfere with higher flying aircraft. And at the same time, of course, it needs to be flown away from airports and other aircraft that are known to be in the vicinity. The other thing to think about too, even at the personal level, is the disclosure of private information or private video, pictures, through the use of a drone that's airborne. So there are privacy and voyeurism issues to be considered. Now, with drones and proximity security, there are some variations that we need to think about, one of which is called war flying. Now, you might have heard the term war driving in the past, whereby people, normally IT technicians, would drive around a city metropolis with a wireless device to map out wireless networks that were open in that area. Well, war flying is similar in a way. War flying can be used with software that allows for Wi-Fi sniffing from the airborne drone. So imagine that you're flying a drone in an industrial park or an urban center that's busy, and as that drone approaches within range of a Wi-Fi network, it'll pick up on it and can record the fact that that network is there. And some Wi-Fi networks in tall skyscrapers might only be accessible by being on that floor, which might not be possible due to facility security, but is possible through the walls outside using a drone. So these are risks that have to be considered in this day and age, again, really dependent upon the audit scope and the audit objective. The other thing to think about is the possibility of drones being used to drop drugs into prison yards or to intercept communications from users with mobile phones, or heaven forbid, even to drop explosives. Of course, there is the military use in some parts of the world of unmanned aerial vehicle drones, which are used for war reconnaissance and actually our arm. Bear in mind that some of these higher end drones can actually reach altitudes of 20,000 feet or so. So they might be way out of range of any sensors that might normally detect lower flying drones. So what can we do about this? Well, one of the things that's done these days is geofencing. Geofencing limits where certain devices can be used. So for example, the drone firmware, so the firmware built into the drone device itself, will honor drone no-fly zones. Places like airports come to mind immediately. Now this is based on the GPS positioning of the drone. However, what if you could disable the GPS tracking on the drone device? And as sad as it is to say, there are some websites out there that provide instructions on how to bypass some of these built-in settings that are built into drone devices so that you can actually enter essentially what is restricted airspace using a drone device. There are even documented cases where drone owners can wrap part of the drone with some kind of a foil, thus preventing GPS signaling from working. So essentially, the drone is flying and it can't be detected where it is, except by the remote controller within close proximity. Fire suppression systems within a facility can sometimes fall into the scope of an IS audit. One of the reasons this might be the case is due to legal and regulatory compliance, making sure that we adhere to even local municipal bylaws related to fire hazards and fire prevention. We have to think about how that would apply at the data center level, as well as an individual smaller server room level when it comes to how they are constructed. Again, adhering to the appropriate local building codes is going to be paramount. Then fire detection system selection. We want to make sure that we've got a system that can detect the presence of smoke and that can give people a chance to get out, as well as us the ability to save equipment where possible. Now, the type of fire detection system and fire suppression systems put in place could also have an impact on the amount of property insurance premiums that are paid by the organization. That would also include having the presence of fire extinguishers as required by law. Fire risks start with the harm to personnel. That is first and foremost, and that's the first thing that needs to be avoided. Secondly would be damage to IT-related equipment. Now, it's not necessarily the IT equipment itself that an organization will be overly concerned with, as opposed to the data that results from the use of that equipment. Then there's the issue of customer service disruption. For example, you can imagine what would happen if a fire broke out in a busy call center and it took a few days before the cleanup was completed. Now, that's another aspect, is the post-fire cleanup and the costs that go along with that. So it's worth auditing the IS systems in relation to fire suppression mechanisms ahead of time so that we can avoid those expensive costs after the fact. The other thing to consider is that the equipment isn't as valuable as the data itself and the people that support those business processes. As an IS auditor, we're also going to sometimes have to familiarize ourselves with which laws or regulations or local municipal fire codes apply. And one way that we can look at this is looking at the U.S. National Fire Protection Association standard, otherwise called NFPA 75. This deals with fire suppression techniques to minimize damage to IT infrastructure. In this exercise, you will first explain the difference between a vulnerability scan and penetration testing. Next, you'll describe the purpose of a jump box. Thirdly, you will list 3 examples of physical security. And finally, you will perform a non-credentialed vulnerability scan against a network. Pause the video at this time and think about these exercise items, and then come back to view the solutions. Vulnerability testing is used to identify weaknesses or vulnerabilities, whether at the network or at the individual host level. Now, vulnerability scanning uses a vulnerability database to look for common misconfigurations or missing patches, even at the application level within an operating system. Penetration testing, however, is different, because as opposed to only identifying weaknesses, a penetration test will then attempt to exploit those discovered vulnerabilities. And as a result, if it's a production system that the pen test is being run against, it could actually end up shutting down systems or disclosing sensitive data. A jump box is an administrative connectivity point. It is accessible from an external network, but it does provide access to internal hosts because it's also connected to an internal network. So in the cloud, for instance, we might connect to the public IP address of a virtual machine that is also connected to a private internal cloud network that will allow us access to those other hosts through the jump box, hence the term jump box. Examples of physical security would include geofencing. In other words, using GPS coordinates to determine the location of a device and which options are available on that device, which could include which apps can be used. Physical security guards are another type of physical security, as well as door locks. Nessus is a tool that we can use to perform a vulnerability scan. It's already running on my machine, and I've logged into the web interface for it on port 8834. So at this point, under My Scans, I'm going to click Create a New Scan. We need to create a non-credentialed scan. In this example, let's just do a basic network scan. Now, we'll have to fill in things like the name of the scan, so I'll call it Basic Scan. And for the scan target, I will enter in a range of IP addresses for my network. Now, once I've done that, I have the option of going up to credentials and specifying credentials for different aspects of accessing hosts, like through SSH or through Windows. But in this case, we're not going to specify any unique credentials. So therefore, I'm going to click Save, and I'm going to click the Launch button to start the basic scan. And once our scan is complete, we can click on the name of the scan to open it up and view the details. So by looking at the vulnerabilities color legend, we can determine how many critical, high, medium, low, or informational type of vulnerability messages that we have. Digital forensics is all about the incident response to cybersecurity incidents. So really, digital forensics is the application of computer science and data recovery to the law. And so as a result, there are specific investigative techniques that are used. Bear in mind that with digital forensic, in some incidents, we could be looking at potential evidence that needs to be admissible in a court of law. And so as a result, we have to think about how to properly preserve any gathered data or potential evidence that could be used in a court of law. So think about some of the things that you might have seen in shows and movies, things like Law and Order, CSI, Forensic Files, and so on. Some of those shows are based in fact when it comes to forensic data recovery on the digital IT side. So the digital forensics process then begins with the gathering of evidence. Now, what's important here is that the evidence is gathered in a strict manner in accordance with laws that apply within that jurisdiction. In other words, for instance, we need to make sure that a log is kept about who gathered the evidence and exactly which tools and techniques were used to gather that evidence, such as taking a forensic copy of a storage device and then calculating a unique hash so that we can detect whether or not changes have been made. The idea being is that any analysis that's performed is always done on a copy of data, never the original data, whether it's a disk image copy or perhaps a dump of memory contents at the time that a machine was running, that type of thing. Then finally, we draw conclusions from our analysis of the gathered evidence and report on it. But bear in mind that we need to make sure that throughout this entire process that evidence is gathered, handled, and stored in accordance with the chain of custody, which we'll talk about later. So digital forensics results then will be able to answer questions related to things such as what happened, whether it was a malware infection, or whether an employee was engaged in some kind of illegal activity using company-owned equipment like a smartphone. The other thing to think about is, when did it happen? So looking at date and timestamps and ensuring their accuracy is absolutely crucial. Then determining who was involved. In some cases, simply having a user account that was logged in doing something may not be complete proof that that individual perpetrated a specific action or a crime. We might have to use other evidence in conjunction with that, like video surveillance cameras that places a person at a restricted system where they would have to have been to log in with that account. So today's IS auditor needs to have a sound knowledge of digital forensics and which practices are put into motion, specifically within a specific legal jurisdiction. A digital forensics analyst needs to have the appropriate hardware tools at his or her disposal. And a simple search using your favorite internet search engine will yield plenty of results related to digital forensics hardware, some of which can get very expensive. The first consideration is a digital forensics workstation. This will include a device, often a mobile device like a laptop, that can easily be moved to another location. That includes specialized software, such as for the analysis of things like hard disk images or memory dumps, but as well as including additional hardware peripherals like write blockers, which we'll talk about in a moment. So, hard drive imaging hardware is an option as opposed to hard drive imaging software. Now, the idea is that when we have a specific hardware solution that's dedicated to performing a task, it normally does it more reliably and more quickly than a software equivalent that has to run within an operating system. The thing about hard drive imaging hardware is that sometimes there are compatibility issues with some types of drives, whereas software will be updatable and will have additional support for new types of disk storage media. There are also mobile device acquisition tools. We're talking here about tablets and smartphones, devices that allow us to plug in SIM cards removed from mobile smartphones so that we can perform an analysis on the data. Now, specifically, an analysis on the copy of the data. As a digital forensics analyst, we would never make changes to and analyze the actual source data. We always have at least one copy, ideally two. And at the same time, we would make sure that we generate a hash of whatever it is that we took a copy of, because that hash is unique to the state of the data at that time, and it can then be used to determine if changes have been made to that data. So with an external hardware write blocker, imagine, as we see here on the left, we've got the forensic workstation. And it's got a data cable connection to the actual hardware write blocker device, pictured here in the center of our diagram. Now, the write blocker device prevents writing to the source storage media, so it provides only read-only access. Now, the data cable between the forensic workstation and the write blocker will vary depending on the type of device and the type of forensic workstation you're using. So it might be eSATA, USB SATA, or FireWire. Then, between the write blocker and the suspect storage device, we would have power that would be supplied, for example, to a drive, and also a data cable. So often this is what would be used to make sure that there are no changes made to the source data, because any changes made to the source data means that it would be inadmissible in a court of law. So then, the forensic analyst has the option of taking an image or a copy, for example, of the entire disk storage device on the forensic workstation, generating a hash so changes can be detected, and then performing the analysis on the copy and never on the original source data. A digital forensics analyst needs not only the appropriate hardware to do their job, but also the appropriate digital forensics software. And this software is normally what you would see installed on a forensic workstation that is dedicated to that type of task. Some of the software would include things like hard drive imaging. Hard drive imaging means that we are taking a copy of storage media, whether it's an entire disk or a certain partition on a disk. And the idea is that any analysis and work performed by the digital forensics analyst is done on a copy of the stored data, not the actual true source data. Now, that's important for data admissibility in a court of law. The other reason that we would have a digital forensics station with different types of software is for data recovery. Data recovery could be used to recover data that was legitimately corrupted or mistakenly deleted. However, it can also be used to uncover evidence of a crime being committed. The other thing to watch out for is memory dump software. Now, a memory dump is a point-in-time picture or snapshot of the contents of memory, RAM, which is dependent upon electricity. It's volatile. If we lose the power, we lose the contents of what's in memory. And what's happening in memory can be very much enlightening for a forensic analyst so they can determine what was happening at the time that that memory dump was taken. So what kind of things will we have in memory? Well, think about your own computer usage or even smartphone usage. So certainly a list of running processes, so operating system processes, apps, web browser tabs that are open, network connections, in some cases, even some sensitive data files that you might have open that aren't encrypted once they're opened up because they're decrypted. In the same way, even if we've got encrypted storage media, so on a smartphone device or on a Windows or Linux computer, laptop, disk, if that's encrypted, sometimes the key or the passphrase seed information used to do that encryption is actually stored in memory. So there is a lot of information in electronic memory that is going to be very valuable for a digital forensics analyst. But as always, the proper tools and techniques must be used and documented to gather that information, and then to assure that it's not been tampered with. Pictured in our diagram on the left, we've got a forensic workstation. So this is a station dedicated for use by a digital forensics analyst, and it will be loaded with all kinds of software that allows for things like creating disk images in a safe manner, analyzing disk images, creating memory dumps remotely over the network, running reports on this information, that type of thing. Now, what's happening here is the forensic workstation has a data connection to a write blocker external device. Now, maybe that's a connection through a USB cable or an external SATA cable, eSATA. Now, the write blocker sits between the forensic workstation in this example and the suspect storage device. Now, there are two lines to the suspect storage device. One would be to supply power to the drive if it needs it, and then, of course, a data cable, whether it's USB or FireWire or SATA, that type of thing. Now, what's very important here, when we acquire a disk image, so we would be using software in this example on the forensic workstation to do that, it's always important to generate a unique hash of drive contents. Now, that's fine. We want to make sure that that is done on the acquired data. So we never want to store a hash on the suspect storage device. We're just taking it from that. But we need to have this unique hash value, which is used to prove the state of that disk in this example at that point in time. And any changes will result in a different hash value when it's calculated later in the future. So when the hash is taken in the future, an identical hash means that the copy is accurate and that we haven't had a modification. Now, the other thing to bear in mind is that the suspect disk partitions that we've copied are then mounted and made available on the forensic workstation. That's where the analysis takes place, usually in read-only mode. Now, we can then acquire other additional disk images using a variety of tools, one of which is Access Data's FTK Imager tool, which allows us to take an image of an entire physical or logical drive or even just a folder. The order of volatility really deals with how permanent or temporary storage of data is within a computer system. So we're really talking about what order we should gather evidence in that might be made admissible in a court of law. So we always have to consider the dependency on electricity for items. For example, if we take a look at the CPU within a machine and its registers and its cache, it is considered the most highly volatile in the sense of what is temporary. Because there's a small amount of CPU cache or memory, and the registers can only hold so much data, it is likely that that data will be overwritten much more quickly than things that are stored in memory, regular RAM. So for example, we might have 16 gigabytes of RAM or electronic memory, but only a few megabytes worth of CPU register and cache storage. So the likelihood is it won't last as long as memory contents. Now, memory contents, of course, won't last as long as temporary file systems that might be mounted. This could be, for example, a drive mapping to a file system that exists on another machine elsewhere across the network. And by far, what is the least volatile of these items is disk storage, such as hard disks or solid-state drives or USB media. These do not depend on power like things like CPU registers and cache and memory contents. Naturally, when the power is turned off in a system, whatever was in the CPU registers or cache or memory is gone. Now, luckily, if we've got a temporary paging file, we might have some remnants or artifacts about what was happening in memory. But there's nothing like being able to take a snapshot of memory to see what was really going on at a specific point in time on a computer. And so digital forensic technicians then need to be aware of the order of volatility. If, for example, there is a crime scene and digital evidence is about to be gathered, we have to go through the order of volatility and gather those items that are the most volatile or the least permanent, as listed at the top of this list, before taking, for example, images of disk storage devices, which are considered to be non-volatile. The chain of custody relates to how admissible evidence is in a court of law, and of course laws vary from region to region around the world. The first thing to consider with the chain of custody is how evidence was gathered, and then where evidence was stored, and who had access to the evidence when it was stored. All of these items must be very carefully detailed at a very minute level in order for the chain of custody to properly be adhered to. And again, this can affect the admissibility of evidence in court. So evidence gathering starts with the first responders that are on scene. For example, that could be forensic technicians that arrive on site to seize a suspect's computer system. It's always important to work from a copy of digital data and not on the original data. Working on the original data itself could actually make modifications to the data, thus violating the chain of custody. So we should always use an imaging or cloning solution, whether it's hardware or software based, to take a copy of things like storage media, such as hard disks. Write blockers can also be used to assure that there is no write access to the original copy of data. And this is one of those things that would have to be documented, the fact that a write blocker was used and how it was used and the date and time it was used when gathering evidence. So we need to make sure that the original data does not have any changes made to it. So we need a way to prove that proper steps were taken to prevent that from happening. That's part of the chain of custody. So examples of gathering evidence would include whether or not we should turn off a suspect's computing device like a mobile phone and remove batteries. Now you might first want to run digital forensics tools to take a snapshot of what was in memory or to copy everything that was on the mobile phone to an alternate location and generate a hash. But then why would you want to turn it off and remove the battery? Well, you might want to do that to prevent a remote wipe command from being received from another location that might wipe out any evidence on the device. So you might do this, turn it off, and remove the batteries after having acquired an image of what was on the device. You can also use a Faraday bag or a cage in which a device can be placed so that radio signals cannot enter or leave that location. There's also taking photographs of equipment or computer screens as they were at the time that evidence was seized. Of course, the photographs have to have the appropriate metadata such as proper date and time, and in some cases even location information based on GPS. We should then think about other computing devices that might not be so obvious that might contain very important evidence depending on the nature of the evidence gathering and what's allowed by a warrant, such as scanners and printers and the document history of what was scanned, what might have been faxed if faxing is still being used, or what might have been printed. And then there is, of course, security camera footage if it's available. That can be used in conjunction with digital evidence to place someone at the scene of a crime, for example. And then there is the storage of evidence, such as using anti-static bags to ensure that static electricity doesn't harm digital equipment in any way, using detailed labeling and also an evidence access log for who had access to evidence at different points in time. Also, having evidence stored in climate-controlled storage rooms. And then we have to consider the batteries within computing devices, for example, within a laptop computer. If we know that we're using a laptop computer as stored evidence and it's going to be stored in a specific location, we have to think about the time frame. Because if it's going to be, for example, 10 or more years, well, the internal battery that retains the date and time might fail before we get back to that evidence once again. And so these are just considerations that have to be accounted for. With the chain of custody, a form should be used to document every aspect of evidence gathering, storage, and transferring from one storage location to another, and also an access log of who had access and who might have checked out any of the evidence that was being stored. So here we have a sample chain of custody form, which will include things like the case number, the offense type, the first responder's identification, that could be the badge for a digital forensics officer, the suspect's identifying information, date and time, location, and then, of course, a label number for evidence that was gathered, such as for a hard disk or for a smartphone, the date and time it was gathered, and whether it was released or received between different locations or different parties, and any location or comments that go along with that. So again, it's crucial if we suspect that any gathered evidence might be used in a court of law that the chain of custody be followed properly as required within that legal jurisdiction. Kali Linux is a freely available tool. It's a Linux distribution that contains plenty of penetration testing tools, including those that could be used for good purposes or for evil. The thing to watch out for as an IS auditor is the appropriate security controls in place to mitigate or manage the risk of attackers gaining access to a network, whether it's wired or wireless. Because if an attacker can get on a network, they can use these freely available tools to pretty much do anything in terms of sending out network packets on that network. And in this case, we're going to use the hping3 command to essentially forge network traffic and inject it out on the network. Here, I'm going to use the hping3 command in -- flood mode. Now, what I'm doing is sending out a SYN flood type of attack that would be used against a host to try to prevent legitimate traffic from getting to it. So it's essentially a type of denial of service attack. Although, unless you have a lot of hosts doing this, it's probably not going to cause a big problem for the target. Here, I'm also telling it that I want the destination port number to look like it's destined for port 80. The transmission will leave the local interface on this host, named ETH0, and we're targeting this against a poor victim at 192.168.03, where I'm running a Wireshark packet capture currently to capture this network traffic. It's going to run in verbose mode, -V. We already know -S is a SYN flood. --rand -source means I want randomized source IP address and port numbers to show up as we send all of these transmissions, this flood of network traffic that we're injecting on the network. And -e means I want to specify something in the payload of the packet. I want it to say fake data, so we can easily identify it. So let's go ahead and press enter to get this started. Again, knowing that it's being captured on the network with the Wireshark network analyzer running on the host we're targeting in this particular example. Now back on the target or victim host, we can see network traffic being captured. I'm going to go ahead and stop. Now, I notice here it looks like we've got a lot of randomized source IP addresses all over the map in a short period of time. That's suspicious. Now, if I select one of those captured packets, and if we expand the IP header, here we can see the source and the destination IP. The destination is the victim in this case that we're sending this forged traffic to. And if we look at the TCP header, we've got some randomized source port number, but again, it's targeting port 80. And of course, here in the payload, we can see fake data. This is completely forged network traffic. And this is an important thing to bear in mind as an IS auditor, because security controls that might be in place, such as network intrusion detection systems or network intrusion prevention systems, any type of tool like that, or even running Wireshark as we are here to capture network traffic, whenever you see something that looks suspicious, well, then it might be because you've got a lot of traffic in a short period of time going to the same host and the same port number. But at the same time, don't trust the source IP addresses and MAC addresses and port numbers because we know it can be easily forged, including down in the packet payload. Digital forensics analysts need to have the skills required to uncover deleted data, such as from disk images. In this example, I'm using Kali Linux. In the left-hand navigator bar, I'm going to click the terminal to get to the command line. And the first thing I'm going to do here is go into my home directory, which it appears I'm already in. I can verify this with the pwd, the print working directory command. I'm logged in as user root, which I can verify with who am I, and so I'm in the /root subdirectory. Literally, that's the user root's home directory. Now, I want to take note of my current location in the file system because of output files. You'll see what I mean in a moment. So what I want to do now is do an ls of a listing of what's in /media /root /data1. Here I've got a file called image1. Now, this is an image file that I've taken that was acquired from an existing disk partition. Let me just modify that previous command by adding -l, and we can see here it's quite a large file. It's a little over 1 gigabyte. Okay, so that's an image of the file system in a disk partition. So what I'm going to use is the Foremost tool, which is built into Kali Linux, although you can download it and have it run on different stations. Here I'm going to tell it I'm looking for file types of JPEG, JPG. And then the next thing I'm going to do is tell it exactly which image file I want to look in. To do that, I'm going to use -i, and I'm going to specify my image file. So /media /root /data1 /image1. I want verbose, so -v, and -t to use the current location for output, and I'll press enter. So after a moment, we can see it's working, and okay, it looks like it's got a couple of JPEG files. So what I'm going to do then is do an ls in the current directory, and notice that I've got an output folder with the current date. So what I'm going to do is go into that output directory. So change directory into it. I'll clear the screen, I'll type ls, and I'm going to go into the JPEG directory that was created here. If I do an ls, there are 2 JPEG files that were recovered from that image. So what I'm going to do then is go into the GUI here. Let's just open up the file system. Let's go into the root user's home directory. Here it is. There's the output folder. There's JPEG. Here we've got 2 JPEG images. Now, one of these JPEG images looks like a hard disk, another one is just a Kali Linux logo. So, interestingly, if we were to take a look at the live file system, now we should never do this in reality with a true digital forensics environment, but here I have the luxury of seeing the actual source file system. All it contains is a single JPEG file, the other was deleted. So what we're talking about then is recovering files from a disk image, even those that were deleted. While there are plenty of disks that can be used by a digital forensics analyst to acquire a disk image, here I'm just going to use the built-in Linux dd command. So to get started, I'm going to click on the terminal icon in the left-hand navigator to open up a command prompt. And I'm just going to issue the lsblk command to list block devices, one of which is labeled as being SDC. That's my third disk, which is currently mounted, as we can see, under /media /root /data2. What I want to do is acquire an image using the dd command of SDC. So what I'm going to do is issue the command dd space if, as in input file, equals /dev/SDC. In Linux, everything is a device, and so dev means device. Here I'm referring to the disk device SDC. So I want to take a copy of that and store it in, so OF for output file equals, how about we put this under /media /root /data1, and we call this file image1. And I'm going to go ahead and press enter. And after a moment, we can see that the operation has completed. So why don't we go ahead and take a look at the file system here, and let's navigate to where that image file should have been created. So I'm going to choose other locations on the left, data1, and indeed there's our file image1, which is approximately 1 gigabyte in size. So now we've acquired a disk image that we can use with the appropriate forensics tools to generate a unique hash, to detect changes, and also to actually analyze the contents of that disk image file. In this exercise, the first thing you'll do is describe how forensic disk write blockers work. Next, you will describe the evidence order of volatility. You will then describe how evidence integrity can be proven, so to make sure something isn't corrupt or hasn't been tampered with and that it's authentic. And finally, you'll use the Linux dd command to acquire a disk image. Pause the video, think about each of these 4 items, and then come back to view the solutions. A write blocker device is used to prevent writing to a suspect's storage device. So a physical write blocker would sit between the forensic analyst's workstation and the physical suspect storage device. It sits in between to make sure that we can read from it, such as to acquire an image of the storage device, but not mistakenly write to it. So it sits between the items. Now, what happens is the forensic workstation is connected to the write blocker via a data cable, such as USB, FireWire, or SATA, whereas between the write blocker device and the suspect storage device, we've got 2 connections, one to supply power to the suspect storage device if it needs it, and the other would be a data cable, such as USB, FireWire, and so on. The order of volatility is important for the digital forensics analyst because we need to make sure that the data that is the most likely to disappear first gets acquired first, such as in CPU registers or cache. These represent very small amounts of memory and are more likely to be overwritten before RAM, standard system memory in a machine, of which there might be, for instance, 8 gig or 16 gig. Temporary file systems would follow. And finally, non-volatile storage, which means things like hard disks or USB thumb drives or solid-state drives. These are devices that will not lose the data even if the power is removed. Evidence integrity is related to the chain of custody. The chain of custody deals with the documentation of how evidence was gathered and all the details surrounding that, such as who gathered it, what the purpose was, the location, the date and time, as well as the storage, transfer, and use of that evidence. Hashing is a mechanism that generates a unique value based on an individual file and its input or an entire disk volume. Hashing allows us to detect changes, so we know whether we're working with the original state of data or not. With the Linux dd command, we can specify the input file or IF and specify a disk device that's available or visible to the Linux system, in this case /dev/sdc. The next thing we can do is specify where we want the output image file with OF. Here I'm specifying a mount point, so this is an existing file system that can accept files. And you need to make sure it's got enough disk space to accommodate the image file that you are capturing. So if you're capturing an image here from dev/sdc and that's 500 gig, you're going to need at least 500 gig of free storage space to create the image file in the target location. Without constant monitoring of the IT infrastructure that supports business processes, it can be pretty difficult to catch security incidents when they occur. Continuous monitoring is a big deal, but in order for us to be able to identify what's out of the norm, we have to know what is normal, and that's a baseline. We need to establish baselines to allow for the easy detection of anomalies. That would mean a baseline for specific systems like a web server and what's normal for its performance and what type of network traffic patterns are normal for that site. At the same time, we also have to bear in mind that threats are changing constantly, so what is normal at one point might not be normal later, and that's why continuous monitoring is a big deal. We have to think about new malware variants, new hardware, and software vulnerabilities, as well as issues such as climate change, which can have a big impact on business processes and IT infrastructure, such as the flooding of a data center. Incident management can also kick in once we detect, in fact, there is something suspicious happening. the first thing to consider is assets that need protecting, and then identifying threats against them. And then actually detecting that a threat is occurring. Now, threat detection, this is a big one because it relates directly to monitoring. That's why we would be interested in continuous monitoring. Then, of course, the incident response plan would kick in to respond to that threat so that related parties that are involved in incident response, so incident responders, know their roles and responsibilities to contain the issue. With monitoring, we have the option of logging. Logging of an operating system, logging of network infrastructure devices like routers, firewalls, proxy servers, logging of smartphone apps, logging of individual laptop stations. It goes on and on. Well, also what can be very handy is having alert notifications based on the contents in logs. Now, this will require a specific configuration for an organization or a department or the devices used for a particular project, but we have to make sure that we look for certain anomalies in logs and then send alert notifications, whether that's through email messages to administrators or SMS text messages, and so on. There should be periodic network and individual host scans. Number one, to identify what's on the network and whether it should be there. And secondly, to detect changes. Are there new devices that weren't there previously? Or do we have an existing device with a new port that's open? Or do we have a vulnerability that's newly discovered on a particular host that didn't exist before? And then, of course, IT file and system auditing. We should be auditing the file system on hosts. We should also be auditing system usage. We would do this in comparison with baselines to detect abnormalities. Technology is what makes business processes efficient. Business processes are driven by organizational objectives, and it interacts with assets and personnel, where an asset could be data that has value to the organization, and personnel will use tools, perhaps data analytics tools, to go through that digital asset of data to extract insights. Business processes also define how organizations implement their business strategy to meet business goals. We have to think about all of the techniques, so business process techniques, and the tools that are used to get things done. Now, depending on what the scope of the IS audit entails, will determine exactly which techniques and which tools are part of the audit to make sure that they deliver value to the organization. Also, we have to think about compliance. Business processes need, of course, to serve the business requirements while ensuring we are compliant with applicable laws and regulations. Business processes should also have the ability to adapt over time, to change. We all know that technological solutions change rapidly, and how they are used to support business processes can also change. So this needs to be assessed on a periodic basis. So the periodic review will ensure effectiveness. COVID-5 is a framework that is used at the enterprise level so that companies can make sure that business goals are being met in the most cost-effective and efficient manner possible, using proper IT governance and management. So the COVID-5 process reference model, otherwise called the COVID-5 PRM, has a number of different processes for the governance of enterprise IT. Things like cost management, resource optimization, HR management, supplier management, risk management, security management, and many others. So by taking all of these into account, essentially trying to be as efficient as possible and delivering the most possible value to the company, we can achieve a better overall result for an organization. It's kind of like living in a cold climate and trying to winterize a home to make sure when you heat your house, hot air doesn't leak out through cracks. It's the same type of thing. Looking for inefficiencies on a continuous basis and making sure we make adjustments in a secure manner while adhering to laws and regulations. As an IS auditor, you need to be able to draw conclusions from your IS audit findings. And this is done using sampling techniques. And the reason that this is done is because there's usually not enough time. It's not feasible to look through every piece of information to base your audit conclusions on. And so there are different types of sampling that are then used. So we're really talking about having assurances that audit assertions are backed up by evidence. So this means dealing with what's called the confidence coefficient. And this normally means that the more assurance or the more confidence we have means having a larger sample size. Now you might wonder, what do you mean a sample size? Well, if part of the Is Audit objective is related to looking at how invoice payments are handled, how those processes are structured, then we would have to take a look at how those processes run from beginning to end, so documentation, past historical evidence of the success or failure of those processes, and that's the type of data on which we would base our audit sample. Another example would be perhaps looking at security controls that might protect access to a network and any security incidents that might have occurred over time, and looking at logs or intrusion detection sensor result alerts based on that control. So that's how we get our data that we begin to sample. But again, it's usually not feasible to look through all of the available information because there's simply too much and not enough time. And so that's where audit sampling kicks in. So it's not practical to examine every minute detail. Now at the same time, we should be able to, as IS auditors, when setting up our audit sampling, we need to be able to identify any sample outliers, any deviators from what is expected from the sample. And we also need to set an expectation as to the tolerable amount of error. So what we're really looking at here is the maximum error tolerance that is acceptable within the population, whereby we are willing to accept that it's not 100% accurate, but it's accurate enough that we can still stand behind our audit assertions. The first audit sampling type is attribute sampling. This essentially looks at the presence or the absence of a specific characteristic or attribute. So this would be something that would be used by an IS audit team when what needs to happen is we need to determine how many times the attribute occurs, or in this case with absence, does not show up in a sample population. So we can do this, for example, to take a look at how effective security controls are in mitigating risk. So we might look for a specific type of alert, whether it's a false positive or whether it's truly an alert that relates to a true security incident. We could look at that log information. That would be our sample population where we would look for a specific attribute, such as a false positive. Another type of audit sampling is variable sampling. In this case, we're taking a look at either the total or the average value within our sample population. So what this means then is we could look at monetary amounts. And in this case, we might even use this in relation to business processes to look for any suspicious discrepancies related to finances. The next type of sampling type is discovery sampling. This is used to highlight any deviations in a population that might stray from outside of normal ranges that we've defined previously. And again, this one could be also used as an indication of some kind of fraud that might be taking place, or maybe even just the failure to comply with a standard or a regulation because it stands outside of the normal that's expected. Then we've got statistical sampling. This uses mathematical calculations on a subset of the data. So the idea here is we want to make assumptions based on the results of mathematical formulas, such as determining, for example, the annual rate of occurrence for a negative event that might impact business processes and the supporting IT systems. And so it's important then that audit reports include a lot of information about the sampling technique that was used and how the sourced population data relates to the audit scope. Logging is an important aspect of monitoring a host and a network as a whole. The idea is that we can filter out log information to get past all the noise that's not relevant to focus on what is relevant. And in the case of an IS audit, we might be making sure that security controls are in effect and compliant with security control objectives. And so here in Windows, what I'm going to do on my server is go into the Start menu and type in the word Event to fire up the built-in Windows logging system, the Event Viewer. Now on the left, if I expand, for example, Windows logs, we can see a lot of the built-in logs, the system log, for example. We can see the security log that will contain audit events that are configured in the Windows environment in relation to this server. But if I drill down on the left under Applications and Service Logs, depending on what's been installed on this Windows server will determine what I see here, like Active Directory related items or DNS server items, because this host is also a DNS server. And I can also see Windows PowerShell related log items. If I expand Microsoft, Windows, then I'll have a category of all kinds of components that are part of the operating system. So for example, if I were to go, let's say, down to the G's, then I see group policy operational messages as related to this server. But notice, in this particular case, we've got really a lot of just informational messages, which is no big deal. So we don't want to waste our time looking at informational messages because that's just normal operation. So what I'm going to do then is go to my system log and filter it. Now I could manually scroll through and look for different types of log entries. This is true. But we can also right-click on a log and first of all do a find. So if we're looking at something related, let's say to DNS, then we could search for DNS. Now that's not filtering anything, but it is quickly helping us locate something that might be of interest to us. So here we have a DNS client event related message. However, we can also right-click and filter the current log on a number of different criteria. First thing to consider when you're filtering logs to weed out the noise and only see what's really important is the time frame. So here it says any time, but we could choose, for example, the last 24 hours. We could choose that we're only interested in warning type of event levels. We could also even choose from certain types of event sources. And down below, I can also specify an event ID. An event ID number, I'll just back out of here, which we can see listed here in the event ID column, is always the same for that particular type of event. So let's look at event 7036 here. The remote registry service entered the stop state. Well, if I look at other logged event items related to that same event ID, then we can see here it's related to the volume shadow copy service entered a stop state. And down further below. Okay, so basically we're talking about a service that entered a state, whether it's running or stopped. That's what 7036 means. And so we can filter on that if we're interested, for example, in seeing state changes between services that are running and not running and so on. So once again, I'm going to right-click on the system log on the left, and I'm going to choose Filter Current Log. We're going to tell it we only want warning logged items over the last 24 hours, as we're beginning to do. And down below, I can specify usernames or computer names, but here, I just want to see warning items. Maybe we'll tell it critical and error as well, and I'll click OK. Well, the good news is we don't really see all of those items here, at least not within the last 24 hours. So if we right-click and choose Filter Current Log and say, well, let's see at any time those types of logged events, then we get a bit of a different listing. So here I can see some warning items related to the DNS client. Now, at the same time, we can also build a custom filtered log view. So I'm going to right-click on Custom Views over here in the left-hand navigator and choose Create Custom View. Maybe I'm interested in any critical, warning, or error types of messages. And we were just looking at the system log, but we could choose any collection of logs here. So let's say from the system log, maybe the application log. And I don't care about the event ID or the username or computer name. That's not what I'm interested in. I'll click OK, and I'm going to call this Problems for You. So that's the name of my custom view. It'll be under the custom views listing here. So now under custom views, I've got a new custom listing called Problems for You. And when I click on it, it's always up to date with the latest, well, problems as related from the system log and also the application log. So it's important then to understand how the logging system works in your environment, whether you're going to be looking at logs on a per host basis or having them gathered in a central location for centralized logging or for a SIEM solution. An important aspect of monitoring is having a centralized single administrative pane that you can go to see activity for a multitude of network devices. In this example, I'm going to configure in the Linux environment centralized logging. Here I've used an SSH remote connection to a server called Serv2. It's an Ubuntu Linux server that will serve as a central logging host, and that's how I'm going to configure it. So the first thing I'll do is use the sudo prefix to run an elevated command, service rsyslog, which is the name of the daemon or background service that handles logging, like log forwarding. I'm going to check the status of that. Here I can see that it's currently listed as being active and running, as it should be by default with Ubuntu Linux. So I'm going to press Q to quit out of that, and I'll clear the screen. So the service is running. That's good. Now I want to configure this server to receive log messages from other hosts over the network. To do that, I have to make a change to a configuration file, and I'm going to need elevated privileges to do it. So if I type who am I am not logged in with the root account, which is why I'm using the sudo command prefix. So I'm going to run sudo, and I'm going to use the nano text editor built in to Ubuntu Linux, and I'm going to open up a file under /etc called rsyslog.conf. It's a config file. What I'm interested in doing is making sure that the module load statement for IMUDP and the input type for IMUDP port 514 are uncommented. Now, in some environments, this might be commented by default, which means it's not active. But we want to enable listening on UDP port 514 for incoming log messages from other hosts. So I'm going to go ahead and press Control X to save this file. So I'm going to press letter Y for yes. It asks to configure or specify the file name to write to. That's correct. I'll press Enter. So that part is done. Now I also have to make sure the firewall allows that type of inbound traffic here in Ubuntu Linux. So I could run sudo ufw, this is the firewall command, to allow port 514 over the UDP transport. So 514/UDP. Okay, and then what we can do is make sure that the firewall is restarted. Now we could do that, or it should be in effect immediately. We can also verify whether or not our syslog is in a listening state on this machine. If I were to run sudo and run the netstat command, and let's pass it the parameters tnlpu, let's grep it for our syslog, we can see here that indeed our syslog is in a listening state on the local host at port 514. So it's ready to receive log messages. Now before we go further, let's do ifconfig to see what the IP address of this central logging host is. It is 10.1.1.7. We need to know that because we're going to switch over to server 1, which we will configure to forward log events to this host at 10.1.1.7. Okay, so here on server 1, I'm going to use the sudo command prefix and the nano editor to open up /etc/rsyslog.conf. And what I want to do here in this config file for logging is go to the very bottom and tell it which log messages I want to send to our central host. So I'm going to specify that all log messages star.star, although I could specify, for instance, all informational messages on this host, star.info, be sent. But I'm just going to specify that all log messages should be sent to our server. So then what I'm going to do is add a space and then at 10.1.1.7. That was the IP address of our central logging host. I'll press Control X to save and press the letter Y for yes. And I'll press Enter to confirm the file name. Then I'm going to make sure that we restart that. So sudo service rsyslog restart to restart the rsyslog daemon. And we should be ready to go. So what I can do then is use the logger command to test this. How about we use the logger command and we'll force a message that says test log message on server 1. Now we want to make sure that we check the log file on server 2, because that should have been sent as a log message to our central logging host, which is now set to receive them, server 2. And so we should see this test log message on server 1 in the log file on our central logging host. So we're now back on server 2, and now what I'm going to do is use the tail command to show the last 10 lines within a text file, specifically /var/log/syslog. And here in server 2, notice that we have a message that was initiated on server 1 from a user logged in on that host called C. Blackwell. So we have now successfully configured centralized logging where our first Linux server will forward log messages to our second server. Packet capturing allows IT technicians to capture network traffic and then to analyze it to identify deviations from an established baseline of normalcy, or simply to track what should or should not be on the network in terms of devices and network traffic types. So it's network traffic monitoring, and we can perform packet capturing using either hardware solutions or software solutions. The thing to consider with packet capturing is the placement of the device, whether it's a hardware device or a computer that has packet capturing software on it. We need to make sure it's in a place on the network where it can see relevant network traffic. Often what we'll notice is that with packet capturing, we can place the network interface card, whether it's wired or wireless, into what's called promiscuous mode. Promiscuous mode means that the driver for that network interface will be able to listen for traffic that isn't even destined for the address of that network interface. In a wireless network, Wi-Fi to be specific, wireless routers and access points will have a configuration option called isolation mode. Isolation mode means that each Wi-Fi client connected to the Wi-Fi network is completely isolated from others, and so it can't see all of the Wi-Fi traffic on the Wi-Fi network. Now, that's a bad thing if the goal is to run a packet capturing session from a device connected to that Wi-Fi network. So, in that case, we might want to disable the access point isolation mode while packet capturing is taking place. Then, with a physical network switch, such as an Ethernet switch, we have to determine which port we are physically plugged into and whether that port is enabled for port mirroring or monitoring. In other words, normally with a network switch port that your machine is plugged into, you are only seeing your own unicast traffic as well as broadcast and multicast traffic, but you're not seeing other switch port devices' unicast traffic unless you configure the switch for the port that your device is plugged into where you're capturing traffic, even perhaps using the free Wireshark network analysis tool, and you want to make sure that all of the traffic in the switch is copied to that port so it's seen by your packet capturing session. So all switch port traffic essentially gets copied to that switch monitoring port. We can also capture network traffic on a router. Some router devices will allow packet capturing sessions on remote networks that the router is connected to. And then, of course, those results can be sent to a station even on a different subnet. The other way that we can capture network traffic, and this is more of a nefarious way of doing it, is through what's called Arp Poisoning. Now, this is an attack that can be used by a malicious user, whereby what they're doing is sending out an ARP broadcast to devices on the network, telling all the devices to update their local ARP caches with the MAC address of the attacker's machine. Now, that would be a match with the IP address of the default gateway on the network, so that client devices will now send their traffic through the attacker machine thinking it's going straight to the default gateway for traffic, for example, in an outbound direction. Now, the malicious user device, in turn, would be configured to route IP traffic through the real default gateway, so the traffic is still getting where it needs to go, just being sent through an alternate route whereby the attacker can see all of the network traffic. With packet capturing, we have capture and display filters that can be used. Capture filters, as the name implies, are done at the time that the network traffic is captured. If all we want to see, for example, is HTTP traffic, well, then we could create a capture filter so that's all that actually gets saved in the capture file if we save the results of the packet capture. As the name implies, you can also have a display filter so that you might have captured all kinds of network traffic, but you decide after the fact you want to filter it by a protocol like HTTP or FTP, or by IP address or port number or any number of characteristics. The other thing to bear in mind is how much network traffic that is needed to be captured for a valid sample, especially if we're going to be using a sampling technique like statistical sampling for our Is Audit purposes. Then we might need a baseline comparison. If we're capturing network traffic in order to identify anomalies or suspicious activity, then we need a baseline to compare the current capture to determine, in fact, if anything falls outside of the norm. Wireshark is a free network analysis tool that you can download and run on many different platforms, including Linux and Windows. Here I've already downloaded and installed Wireshark on my Windows 10 computer. Now when you launch Wireshark, you'll see a list of capture interfaces, network interfaces down below based on your local machine's config. Here, for example, I have an interface called Wi-Fi, and I can see that I've got some network activity on that interface. So to start a packet capture on that interface, I simply double-click on it. So I'm going to double-click on Wi-Fi, and it is now capturing network traffic. Now, what's important is to think about the purpose of why you are capturing network traffic in the first place. You have to make sure that you're in a place where you can see the appropriate traffic. For example, if you're plugged into an Ethernet switch physically, you might want to make sure that you're plugged into a port that is configured for port mirroring, essentially which copies all network switch traffic to that port, if your goal is to see all network traffic for devices plugged into that switch. Otherwise, you're only seeing your own network traffic. Now, the other thing to consider is what you're looking for. Sometimes you might run periodic scheduled network scans like this to capture network traffic, simply to essentially run an on-the-spot network audit to see what kind of traffic is being sent around the network and between which hosts. So now that we've captured a bit of traffic, I'm going to go ahead and stop by clicking the stop button. Now, by going through and looking at the packet capture, it's important to understand that each and every line here is a separate packet. And when I select a packet here in Wireshark, in the center section of the screen, I see the packet headers. First thing I see is actually not a header, just some statistics about what was captured. But then it begins with the Ethernet header, where I can see the source and destination MAC address. That's the 48-bit hardware address. That would apply to layer 2 of the OSI model. Next, I would see the Internet Protocol header, which is what we're using because we're using TCP/IP. And this maps to layer 3 of the OSI model, where I've got addressing in the form of source and destination IP addresses. Next thing I would see here, depending on the type of network transmission, is another header. Now, here I see Internet Control Message Protocol. And in the packet payload or data below, which is not encrypted, I can see the clear text. I can see letters of the alphabet. So ICMP is used by a number of different utilities, including the ping command in Windows, where we are testing that a machine is responding by sending some sample data. So here we can see then that we've got a lot of ICMP traffic. And if I wanted to filter that out up here in Wireshark, I just click up in the bar and type in the protocol, in this case ICMP, and enter. And now all I'm looking at is ICMP traffic. In this case, specifically, it looks like ping traffic, because as we look into the ICMP header, we can see exactly what type of request this is, or response. In this case, it's an echo ping reply. So that means if we look at from the opposite direction, from the sending source device, then we see an echo ping request. So someone is pinging 172.217.13.100. Now we can also filter on a number of other items. So notice if I start typing up here in the filter bar, I see examples of past filters or filters that could be typed in, such as filtering on IP addressing. So for IPv4, ip.addr equals, and then a specific IP. So let's try that out. I want to take a look only at this IP address, 172.217.13.100. So ip.addr equals, in this case, 172.217.13.100. And now I'm only looking at transmissions that include that IP address either in the source part of the IP header or as a destination IP address in the IP header. So there's a lot of things that we can gather by looking at this. We're seeing a lot of network traffic. We know that we can filter it. And as we go through, we can determine if anything looks like it's on the network that shouldn't be, such as protocols in use that really shouldn't be in use. Also, we can use this to establish a baseline of what is expected on the network, what's normal for network activity. When you're doing that, make sure that you capture network traffic for a long enough period of time to determine that this is normal. In a larger enterprise, it can be unfeasible for the IT tech team to monitor each and every device on the network looking for indications of a security breach. And that's where Security Information and Event Management, or SIEM, kicks in. This is really a centralized type of tool that provides us with real-time security alerts based on specific types of security events. And those security events could stem from a multitude of different sources, and we'll identify some of those in a moment. Our CIAM centralized tool also allows us to analyze security events and correlate them to other related events. So for example, we might have a customer database security breach that can be correlated to a user account that was hacked a day ago. And so we can see the relationship between some of these items through our CIAM centralized reporting tool that we otherwise might not know. CIAM data sources include web applications, network infrastructure equipment like routers, switches, VPN concentrators, databases, shared folders, and even authentication servers. So what we might do is, within each of these potential CIAM data sources, configure alerts, essentially audit alerts that get triggered when something happens. For example, when a database row is deleted, that triggers an event that we want forwarded to our centralized CIAM system. Or when a file is accessed, a sensitive file is accessed in a shared folder, same thing, we want to know about it. Or when an administrator creates a new user account on an authentication server, we want that to be treated as a security event, even though it's legitimate. The thing about a centralized CIAM solution is that it needs to be tweaked for the specific environment in which it is running, as you might imagine, by looking at all this variation of potential data sources for security alerts. We want to make sure we configure the CIAM solution, which also includes configuring individual data source alerting, so that we reduce false positives. The last thing we want is a flood of alerts going to technicians stating there's a security issue, when in fact there is not. So we need to have a baseline of what's normal then as it relates to each potential data source. What's normal usage for a customer database that we want to monitor for security breaches? What's normal for a web app? What's normal for the shared folder? This needs to be known before we can identify what's abnormal. In other cases, we might need to configure our centralized CIAM solution to be compliant with specific laws or regulations. Now, for example, we might have to have a certain type of encryption strength in place when we transmit over the network and when we store files, data at rest. Otherwise, that will trigger an alarm that will be made known to IT technicians through our centralized CIAM solution. So the alert thresholds then are configured on each individual data source, or it could be done instead of that or in addition to only in the central CIAM configuration. Now, what this would mean is that we would have to feed things like log files or log event items from databases, from shared folders, from authentication servers. All of that would have to be fed into CIAM, so CIAM could then analyze that looking for potential issues, and then, based on our configured alert thresholds, for example, the number of failed login attempts for an admin account could then trigger an alert to show up in the CIAM console. As the name implies, an intrusion detection system, or IDS, is a configuration that's used to detect suspicious activities, or intrusions. This can come in the form of a host IDS. A host intrusion detection system, or HIDS, is specific to a network host. So it could be an agent, a software agent that is configured and listening for activity on a specific device, such as on a server. It might look at running processes, log entries, traffic leaving the host, or traffic coming into the host. And as a result, a host intrusion detection system could have the ability to look at traffic after it arrives at a host and is decrypted. We also have a network IDS potential solution, a NIDS. A network intrusion detection system, as the name implies, isn't specific to looking at the processes and apps and items running on a particular host, but rather at the network as a whole, so that it's looking at network traffic patterns trying to identify suspicious activity. Now, whether we're talking about a HIDS or a NIDS, this can come as a hardware appliance, or it could be software, such as a software agent running on a host, or even a virtual machine appliance configured with intrusion detection software. So it's used to detect anomalies. This means it could look at log entries, and then based on our configuration, raise alarms. But the thing is, we don't want too many alarms raised unless it's critical. We don't want false positives to show up that state that there's a security incident that has occurred, but really there wasn't one that occurred. Intrusion prevention systems, or IPSs, come in the form of host level and network level. Now, they also come in hardware or software forms, just like intrusion detection systems. However, aside from simply detecting anomalies, they can also prevent further damage. So, it can log any anomalies, just like an intrusion detection system can. Based on our configuration, it can raise an alarm if it thinks a security incident has occurred or is in progress. But beyond an IDS, an IPS can also block or reroute traffic. It can run a custom script. Basically, it can be configured to take steps to contain a security incident that is currently in progress. And that's really what differentiates an intrusion prevention system from an intrusion detection system. These days, you'll have unified threat management or UTM solutions, either on premises or in the cloud, that among other things will include intrusion detection and prevention capabilities. Now, whether we're talking about intrusion detection or a prevention system, we need to think about the placement. Where will the device or where will the software be installed and configured? Naturally, when it comes to a host intrusion detection system, if we want to really analyze traffic to a critical web app, we should install the software, if it's a software solution, on that hosting web server. So then that way, presumably we would have HTTPS communication to the web app, which encrypts the transmissions. We want to make sure that we gain access to those HTTP conversations after they've been decrypted. And so we need an agent on the host to do that, hence host intrusion detection. Now, if we not only want to log suspicious activity and perhaps notify administrators, but take steps to stop it, then we're talking about intrusion prevention. These days, most solutions can do both. So we need to establish what's normal. And this is important because every network is different and every business is different. So we need to determine what is normal activity on this host, what is normal activity in terms of the types of network traffic that we see on the network, and between which hosts is that traffic considered to be legitimate, because then we can identify any anomalies from that and start raising alerts about potential security incidents. We know that we should use a host-based intrusion detection system if we've got encrypted network transmissions that are arriving at a host. If we need them to be evaluated by our intrusion detection system, then we'll have to make sure that we have a way to read the traffic after it's been decrypted, such as on the host. We should also think about monitoring inbound and outbound traffic at the host level and the network level. So threats don't always come in the form of inbound traffic to a host or to a network. And we always must remember that these solutions, intrusion detection and prevention systems, are generic, and so they need to be configured for the specific environment in which they are running, which might mean being compliant with certain laws or regulations. And the Is Audit might focus on taking a look at the effectiveness of this as a security control, intrusion detection and prevention, in accordance with control objectives that must be met. In this exercise, you're going to start by describing the purpose of Is Audit sampling. After that, you will describe the purpose of Security Information and Event Monitoring, or SIEM. Next, you will list the characteristics of an intrusion prevention system, an IPS. And finally, you will capture and filter HTTP traffic using Wireshark. Pause the video at this point to give yourself a chance to think about these 4 items, and then come back to view the solutions. Is Audit sampling is used by auditors to have an assurance that their audit assertions are correct and based on evidence. And we have this concept of the confidence coefficient. Basically what this means is the confidence we have in the audit findings and how they were arrived at. And so having a larger sample size might be required sometimes to have a larger information base on which to sample data and then come up with these audit findings. So the idea with Is Audit sampling is that in many cases it's just not practical to examine every specific detail related to the IS audit objective and the scope of that audit, such as looking through all network traffic to determine the efficacy of a security control to protect the network. So we can also use audit sampling types to identify any sample outliers. These would be items that deviate from the norm based on the audit sample. And we can also identify a tolerable error, because if we are not going through all of the minute data related to the audit scope, then we have a sampling of that data population. And so there will be some degree of tolerable error. The key here is to identify the level of that tolerable error so that we can stand behind IS audit assertions, not by saying that everything is 100% perfect and guaranteed to be accurate, but have a reasonable level of assurance in the audit assertions. SIEM is a centralized enterprise class solution related to real-time security alerts. Now, this centralized solution can get a number of events from different sources like databases or authentication servers or cloud components and so on. It can also run event analysis and correlation routines so that we could take a specific security event that might have occurred and see how it relates either in the past or to current activity to other security events that might be related. An intrusion prevention system, or IPS, can detect anomalies and then prevent further damage when security incidents are in progress. However, in order to do this, it must be specifically configured for the environment in which it is running. So it can detect anomalies and log the entries, log the fact that there's something suspicious happening. It can also be configured to raise an alarm, which could send perhaps a notification to relevant administrators about this potential security incident. But because it's an intrusion prevention system, it can also take active steps to essentially contain or stop what's happening by blocking or rerouting the related traffic, or even by running a custom script that might be written in a multitude of different languages, such as PowerShell or a Bash script or a Python script, that might take steps to prevent further damage from the alleged security incident. Here in the free Wireshark tool, I'm going to go ahead and double-click on my Wi-Fi connection where I can see I've got some network traffic activity. That's the network interface through I want to conduct a network packet capture. So I'm going to double-click on that. Now immediately it will be capturing network traffic that is seen by this network interface. Now of course, if we're on a Wi-Fi network and port isolation mode is enabled, then all we're seeing here is really our own network traffic, our own unicast traffic, along with broadcast traffic on the network and multicast traffic. Now if I want to filter the captured traffic for HTTP, then what I could do is stop the capture, assuming I've finished with that, and I could type in HTTP in the bar at the top and press enter. Now once that's been done, any traffic that meets that criteria will be shown below. Here we only have two packet transmissions. We can see the source, the destination IP address. We can see the protocol here is HTTP, and if I select one of those packets, down in the header, I can see, for example, in the Hypertext Transfer Protocol, or HTTP header portion, exactly what's happening. So we've got a GET request for www.hbo.com. We can see the user agent information here, the browser that's being used, and any additional details such as cookie information. An important part of the audit process is audit planning. Before you conduct an audit, you need to know what the business does. What are the business objectives? You need to know the business processes that support those business objectives, and of course, the technology that supports those business processes. So in this scenario, imagine that you are planning an IS audit for a financial services company that specializes in synthetic financial derivatives. So the focus of the audit will be on compliance with financial industry regulations. At the same time, as an IS auditor, you might be exposed to sensitive financial data. So when it comes to audit planning, which recommendations should be made prior to conducting the IS audit? Well, the answer lies in a number of things. First of all, you need to make sure that as an IS auditor, you understand the nature of that business and its processes. So in other words, you might wonder, what on earth is a synthetic financial derivative? You need to take it upon yourself to find out what that is before you can move on with an audit. You need to know your client and the nature of their business. That also means that existing company documentation should be acquired. This could be one way that you could begin to learn about the nature of the business and certain data flows and how transactions are accomplished from beginning to end. You should also consider whether or not a recent risk assessment has been conducted, because if so, you can use that as data to be fed into the IS audit. Otherwise, a new risk assessment will have to be conducted, because that's part of IS auditing. The other consideration is because we're dealing with financial data, a non-disclosure agreement or an NDA should be crafted by lawyers and signed by IS auditors, because inevitably IS auditors will be exposed to sensitive information. The IS audit process involves looking at the risk to assets that have value to an organization and the security controls that mitigate those threats to make sure that they're effective and that they're efficient and that they meet control objectives. In this scenario, we're going to focus on security control cost effectiveness. In our example, let's assume that our client gathers market research data that it then sells to marketing firms, and it's set a value on those market research databases at $250,000 in total. However, a single security breach due to historical past incidents could end up costing up to $10,000 if a security breach occurs against the market research databases, so $10,000. And security breaches are estimated to occur once every 36 months. So in other words, once every 3 years. So given this information, as an IS auditor, we need to start thinking about, well, what kind of security controls are currently in place, how much do they cost, and are they effective? Because if not, we'll have to look at new solutions and then determine if they're worth investing in, or in some cases, if it's cost prohibitive, maybe using some kind of a compensating control that still meets control objectives. So let's say that we determine that protecting the market research databases has an annual cost of $2,600. Now, we might have arrived at this by assessing the current security controls to determine that they are deficient. They do not protect the market research databases sufficiently. They might have at one point in time, but they no longer do currently. And so maybe we have to invest in some intrusion detection and behavioral analysis malware scanners to further protect the databases adequately, again, to meet control objectives. So the question becomes, should our client invest in protecting the databases at this cost? Well, the answer lies in mathematics. In this case, the answer is yes. Investing in protecting the databases at an annual cost of $2,600 is worth it. But how do we know that? How can we back up that assertion? Well, we can look at the annual loss expectancy, the ALE, which is derived by multiplying the single loss expectancy times the annual rate of occurrence. Now, in our example, that means taking $10,000, that's a single loss expectancy cost, multiplied by the annual rate of occurrence, that was once every 3 years, once every 36 months, and when we multiply those together, we get $3,330. So that means that we should invest in this solution because the cost of that protection is less than the annual loss expectancy. IS auditors must have an understanding of technology and related security in conjunction with applying that to business processes that support the business and making sure that things are done in a secured manner, maybe to be compliant with laws and regulations. In this scenario, we're talking about a Wi-Fi network and any potential security recommendations that we might have. So the scenario looks like this. We've got a client that has installed a Wi-Fi router in an executive boardroom. So Wi-Fi then will be used by people in the boardroom to allow them to access the internet. The SSID name for the Wi-Fi network has been set to Executive Boardroom. WPA2 PSK is already configured to encrypt Wi-Fi network communications, and the Wi-Fi router is plugged into the same Ethernet switch as corporate servers. The other considerations include the following. The client has e-commerce websites on the corporate network. The e-commerce sites process payments using customer credit card information. So now, which Wi-Fi security recommendations should be made to secure the environment? Well, the answer lies in the following. If boardroom attendees, let's say, are using laptops when they're working in the boardroom, then we should consider not even using Wi-Fi at all, but rather wired network connections. Of course, that's probably going to be unpopular and a little less convenient, but this would be much more secure than having, for example, executives in a boardroom on a Wi-Fi network. If we are going to use Wi-Fi, then the SSID should really be changed to some generic name. The last thing we want is a malicious user within a reasonable proximity detecting that there's a Wi-Fi network called Executive Boardroom. They now know what that refers to. So really, we should use generic SSID names or something that doesn't make sense, like Garbage Room. Either way, it's not a good idea to have a name broadcast out there that tells people exactly what that wireless network is used for. Even if you disable SSID broadcasting, remember, malicious users have freely available tools that will show them the names of the networks, even if SSID broadcasting has been disabled. We should ensure that the Wi-Fi router is plugged into a switch for public-facing connections only. If the purpose of the Wi-Fi network in the ballroom is to allow attendees to get out to the internet, maybe for research purposes during meetings, then we don't necessarily want to allow access to internal corporate servers. So Wi-Fi networks should always be treated as essentially sacrificial lambs that could be hacked into much more readily than a wired network could be. We should consider radius authentication and network access control. What this means is that we want to make sure that authentication doesn't completely occur on the Wi-Fi router. Because if it gets compromised, and remember, it's the edge point connectivity device, then it means our network is compromised. And so instead, we should configure it such that connections to the Wi-Fi network are received by the Wi-Fi router, which then forwards it off to a radius authentication server elsewhere on an isolated, protected network. So in this way, these Wi-Fi security recommendations would help harden the environment and protect the business. At the same time, part of the job of an IS auditor is to assess risk and security controls to identify deficiencies. In this scenario, the scope of your IS audit is related to traveling users and security. During our IS audit, let's assume that we uncover a pattern of data privacy incidents that stem from users that travel for work. And let's say that it turns out some users log into computers in the hotel guest office to access corporate data, and then they copy it to a USB thumb drive on that computer. So most hotels will have some guest services, sometimes an office location where they have computers set up that hotel guests can use. So the use of those could be questionable in some environments. Let's also assume that traveling users sometimes have gone up to 2 months before receiving any type of software updates on their devices that they travel with, such as corporate-issued laptops. So we need to make recommendations as IS auditors to ensure that traveling users work in a more secure fashion. So we need to ask ourselves, which recommendations can we make that would result in reduced risk? Well, there are a number of parts to this answer. The first of which would be more frequent user awareness training and more up-to-date security policy documentation that is easily accessible by all users. Users should know that they shouldn't be using other computers that aren't controlled by the company to access sensitive company data and then storing it on USB thumb drives that are probably not encrypted. We should consider implementing a data loss prevention or DLP solution that could be configured such that sensitive data is not allowed to be copied to USB removable media, and that only authorized devices controlled by the organization are allowed to access sensitive systems. We might even configure our environment such that USB thumb drives are not allowed at all, or if they are, they must be encrypted. Or it could even be configured that only company-issued USB thumb drives with unique signatures are allowed to be used. Another audit recommendation could be to implement a remote VPN solution that's active prior to user logon. The more that we leave up to the user, the larger the margin for error and the non-compliance with security policies. So if we set it up so that when a machine powers on, it automatically makes a VPN connection, maybe based on the device and its credentials and a PKI certificate, then when the user does anything, they're already connected to the corporate network and they might be able to receive updates that way instead of going up to 2 months without receiving them. In this scenario, the focus will be on public key infrastructure, or PKI, and specifically how it's used to secure network communications. Let's say in our scenario that users complain that when they attempt to send encrypted email messages to a specific user, an error message states that the message cannot be encrypted. Now, this could be a problem if encrypted messages are a requirement due to industry regulations. Let's assume also that executives have asked us to recommend a solution so that email messages received from departmental managers are assured to be authentic, so trusted in other words, and not tampered with. So we have two issues at play here. Now, the answer to this from an IS auditing perspective is that encrypting an email message uses a public key, specifically the public key of the recipient that we are sending an encrypted email message to. And so that means that when we have a sender that is sending an encrypted email message, the sender must have access to the recipient's public key. Now, we need to make sure that that is the case here, that the public key of the recipient is available to who is sending the encrypted message. We also need to make sure that that key is not only available but not expired. These keys are often used in relation to PKI certificates, and we want to make sure that the certificate itself hasn't expired, because when the certificate expires, nothing related to that certificate, like the keys, can be used. The other consideration is that when we digitally sign an email message, what we are doing is using us being the sender, our private key. And what we are doing is generating a unique hash of the message contents and encrypting that hash with our private key. Now, we, as the owners of that private key, are the only ones that should have access to that key. And this is how the recipient can be assured that it really came from us, because the message validation on the other end by the recipient occurs by the recipient using us being the sender, our related public key to verify that the signature is valid. And so it's important then that the keys are kept safe, the private keys. Public keys can be made available to everybody. So in this case, we have a couple of recommendations that could be made. But remember, as an IS auditor, after recommendations have been made, there has to be an agreed upon time period where we will go back to ensure that recommendations have been followed up on, that they've been acted upon, and that changes have been made. Compensating controls, also called alternate controls, are security controls that are put in place to solve a problem, a security issue. Now, these controls still meet control objectives, but they might not be our first choice, because the first choice to put in place might be prohibitively expensive after we perform an analysis to determine the cost effectiveness, or might be too difficult or impractical to implement at the current time. And so we have other controls that can still do the trick. So in our scenario, let's say we've got a requirement to prevent unwanted network access, and another requirement for segregation of duties within the organization. And finally, multi-factor authentication for each application. So what are some potential compensating controls? Well, to prevent unwanted network access, one potential solution is to disable unused switch ports. That would prevent malicious users from having the ability when they're on site to plug in their malicious device and gain network access. Video surveillance can effectively serve as a control for segregation of duties. Now, the benefit here is that when people know they're being surveilled, they behave differently. And that is one way to make sure that there is no fraud or collusion when it comes to business processes. We can use network access control with multi-factor authentication to ensure that multi-factor authentication is used when accessing an application. Multi-factor authentication uses multiple authentication categories. So it might be suggested then in our IS audit recommendations that we configure username and password in addition to the possession of a smart card before given access to specific applications. And we can also configure those applications to trust a single central identity provider. So then that way we don't have to configure security for each and every application. In this exercise, you'll start by describing the relationship between IS auditing and risk management. After that, you will describe how intersecting risk between Wi-Fi security and IT technicians can be managed. Next, you will describe how public and private keys are used. And finally, you'll describe when compensating controls should be used. At this point, pause the video to give yourself a chance to think about each of these 4 items, and then come back to view the solutions. IS auditing is used to identify threats to assets that have value to the organization and to manage that risk. That might mean accepting risk, transferring risk, such as to another source through insurance, for example, or reducing risk by implementing security controls that meet control objectives. Now, when we have IT technicians making changes to Wi-Fi security, we need to ensure that proper change and configuration management processes are adhered to, including getting the approval in the first place to implement the change. Next, there need to be thorough IT technician background checks to ensure that the individuals that are performing these sensitive tasks are trustworthy and of the highest integrity. In a PKI environment, public and private key pairs are mathematically related, and they are issued to users, apps, or devices. When messages are sent to a recipient that need to be encrypted, the encryption occurs using the recipient's public key, and the recipient decrypts that message using their related private key to which only they have access. Digital signatures are used to sign messages so that the recipient can be assured that the message is authentic, that it came from who it says it came from, and that it's not been tampered with. So digitally signing a message means that the sender's private key is used to create the signature, and only they have access to that key, so it had to have come from them. The verification on the recipient end uses the sender's related public key, which can be made publicly available to all parties. Compensating controls are used as an alternative when the first choice, the ideal desired control, cannot be used for some reason. Often the reason might be because the ideal desired control is too difficult to implement, it's just not feasible, or it's too costly to implement.